Section 64 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 4, Chapter 2 of Abstraction or the Formation of Conceptions. Part 1. The metaphysical inquiry into the nature and composition of what have been called abstract ideas, or, in other words, of the notions which answer in the mind to classes and to general names, belongs not to logic but to a different science, and our purpose does not require that we should enter upon it here. We are only concerned with the universally acknowledged fact that such notions or conceptions do exist. The mind can conceive a multitude of individual things as one assemblage or class, and general names do really suggest to us certain ideas or mental representations. Otherwise, we could not use the names with consciousness of a meaning. Whether the idea called up by a general name is composed of the various circumstances in which all the individuals denoted by the name agree and of no others, which is the doctrine of Locke, Brown, and the conceptualists, or whether it be the idea of some one of those individuals clothed in its individualizing peculiarities, but with the accompanying knowledge that those peculiarities are not properties of the class, which is the doctrine of Berkeley, Mr. Bailey, and the modern nominalists, or whether, as held by Mr. James Mill, the idea of the class is that of a miscellaneous assemblage of individuals belonging to the class, or whether finally it be any one or any other of all of these, according to the accidental circumstances of the case. Certain it is that some idea or mental conception is suggested by a general name whenever we either hear it or employ it with consciousness of a meaning. Footnote. Mr. Bailey has given the best statement of this theory. Quote, "The general name," he says, "raises up the image sometimes of one individual of the class formerly seen, sometimes of another, not unfrequently of many individuals in succession, and it sometimes suggests an image made up of elements from several different objects, by a latent process of which I am not conscious." End quote. Letters on the Philosophy of the Human Mind, First Series, Letter 22. But Mr. Bailey must allow that we carry on inductions and ratiocinations respecting the class by means of this idea or conception of some one individual in it. This is all I require. The name of a class calls up some idea, through which we can, to all intents and purposes, think of the class as such, and not solely of an individual member of it. End footnote. And this, which we may call, if we please, a general idea, represents in our minds the whole class of things to which the name is applied. Whenever we think or reason concerning the class, we do so by means of this idea, and the voluntary power which the mind has of attending to one part of what is present to it at any moment, and neglecting another part, enables us to keep our reasonings and conclusions respecting the class unaffected by anything in the idea or mental image which is not really, or at least which we do not really believe to be common to the whole class. Footnote. I have entered rather fully into this question in Chapter 17 of An Examination of Sir William Hamilton's Philosophy, headed The Doctrine of Concepts or General Notions, which contains my last views on the subject. End footnote. There are then such things as general conceptions, or conceptions by means of which we can think generally, and when we form a set of phenomena into a class, that is, when we compare them with one another to ascertain in what they agree, some general conception is implied in this mental operation. And inasmuch as such a comparison is a necessary preliminary to induction, it is most true that induction could not go on without general conceptions. Part 2. But it does not therefore follow that these general conceptions must have existed in the mind previously to the comparison. It is not a law of our intellect that in comparing things with each other and taking note of their agreement, we merely recognize as realized in the outward world something that we already had in our minds. The conception originally found its way to us as the result of such a comparison. It was obtained, in metaphysical phrase, by abstraction from individual things. These things may be things which we perceived or thought of on former occasions, but they may also be the things which we are perceiving or thinking of on the very occasion. When Kepler compared the observed places of the planet Mars and found that they agreed in being points of an elliptic circumference, he applied a general conception which was already in his mind, having been derived from his former experience. But this is by no means universally the case. When we compare several objects and find them to agree in being white, or when we compare the various species of ruminating animals and find them to agree in being cloven-footed, we have just as much a general conception in our minds as Kepler had in his. We have the conception of a white thing, or the conception of a cloven-footed animal. But no one supposes that we necessarily bring these conceptions with us and superinduce them, to adopt Dr. Webber's expression, upon the facts, because in these simple cases everybody sees that the very act of comparison which ends in our connecting the facts by means of the conception may be the source from which we derive the conception itself. If we had never seen any white object, or had never seen any cloven-footed animal before, we should at the same time and by the same mental act acquire the idea and employ it for the colligation of the observed phenomena. Kepler, on the contrary, really had to bring the idea with him and superinduce it upon the facts. He could not evolve it out of them. If he had not already had the idea, he would not have been able to acquire it by a comparison of the planets' positions. But this inability was a mere accident. The idea of an ellipse could have been acquired from the paths of the planets as effectually as from anything else, if the paths had not happened to be invisible. If the planet had left a visible track, and we had been so placed that we could see it at the proper angle, we might have abstracted our original idea of an ellipse from the planetary orbit. Indeed, every conception which can be made the instrument for connecting a set of facts might have been originally involved from those very facts. The conception is a conception of something, and that which it is a conception of is really in the facts, and might, under some supposable circumstances, or by some supposable extension of the faculties which we actually possess, have been detected in them. And not only is this always in itself possible, but it actually happens in almost all cases in which the obtaining of the right conception is a matter of any considerable difficulty. For if there be no new conception required, if one of those already familiar to mankind will serve the purpose, the accident of being the first to whom the right one occurs may happen to almost anybody, at least in the case of a set of phenomena which the whole scientific world are engaged in attempting to connect. The honour, in Kepler's case, was that of the accurate, patient, and toilsome calculations by which he compared the results that followed from his different guesses with the observations of Tycho Brahe. But the merit was very small of guessing an ellipse. The only wonder is that men had not guessed it before, nor could they have failed to do so if there had not existed an obstinate a priori prejudice that the heavenly bodies must move, if not in a circle, in some combination of circles. The really difficult cases are those in which the conception destined to create light and order out of darkness and confusion has to be sought for among the very phenomena which it afterward serves to arrange. Why, according to Dr. Whewell himself, did the ancients fail in discovering the laws of mechanics, that is, of equilibrium and of the communication of motion? Because they had not, or at least had not clearly, the ideas or conceptions of pressure and resistance, momentum and uniform and accelerating force. And whence could they have obtained these ideas, except from the very facts of equilibrium and motion? The tardy development of several of the physical sciences, for example, of optics, electricity, magnetism, and the higher generalizations of chemistry, he ascribes to the fact that mankind had not yet possessed themselves of the idea of polarity, that is, the idea of opposite properties in opposite directions. But what was there to suggest such an idea, until, by a separate examination of several of these different branches of knowledge, it was shown that the facts of each of them did present, in some instances at least, the curious phenomenon of opposite properties in opposite directions. The thing was superficially manifest only in two cases, those of the magnet and of electrified bodies, and there the conception was encumbered with the circumstance of material poles, or fixed points in the body itself, in which points this opposition of properties seemed to be inherent. The first comparison and abstraction had led only to this conception of poles, and if anything corresponding to that conception had existed in the phenomena of chemistry or optics, the difficulty now justly considered so great would have been extremely small. The obscurity arose from the fact that the polarities in chemistry and optics were distinct species, though of the same genus, with the polarities in electricity and magnetism, and that in order to assimilate the phenomena to one another, it was necessary to compare a polarity without poles, such, for instance, as is exemplified in the polarization of light, and the polarity with apparent poles, which we see in the magnet, and to recognize that these polarities, while different in many other respects, agree in the one character which is expressed by the phrase opposite properties in opposite directions. From the result of such a comparison it was that the minds of scientific men formed this new general conception, between which and the first confused feeling of an analogy between some of the phenomena of light and those of electricity and magnetism, there is a long interval filled up by the labours and more or less sagacious suggestions of many superior minds. The conceptions, then, which we employ for the colligation and methodization of facts do not develop themselves from within, but are impressed upon the mind from without. They are never obtained otherwise than by way of comparison and abstraction, and, in the most important and the most numerous cases, are evolved by abstraction from the very phenomena which it is their office to colligate. I am far, however, from wishing to imply that it is not often a very difficult thing to perform this process of abstraction well, or that the success of an inductive operation does not in many cases principally depend upon the skill with which we perform it. Bacon was quite justified in designating as one of the principal obstacles to good induction general conceptions wrongly formed. Quote, notiones temere a rebus abstractiae, to which Dr. Whewell adds that not only does bad abstraction make bad induction, but that, in order to perform induction well, we must have abstracted well. Our general conceptions must be clear and appropriate to the matter in hand. Part 3. In attempting to show what the difficulty in this matter really is, and how it is surmounted, I must beg the reader, once for all, to bear this in mind, that although in discussing the opinions of a different school of philosophy I am willing to adopt their language, and to speak, therefore, of connecting facts through the instrumentality of a conception, This technical phraseology means neither more nor less than what is commonly called comparing the facts with one another and determining in what they agree. Nor has the technical expression even the advantage of being metaphysically correct. The facts are not connected, except in a merely metaphorical acceptation of the term. The ideas of the facts may become connected, that is, we may be led to think of them together, but this consequence is no more than what may be produced by any casual association. What really takes place is, I conceive, more philosophically expressed by the common word comparison than by the phrases to connect or to superinduce. For as the general conception is itself obtained by a comparison of particular phenomena, so, when obtained, the mode in which we apply it to other phenomena is again by comparison. We compare phenomena with each other to get the conception, and we then compare those and other phenomena with the conception. We get the conception of an animal, for instance, by comparing different animals, and when we afterwards see a creature resembling an animal, we compare it with our general conception of an animal, and if it agrees with that general conception, we include it in the class. The conception becomes the type of comparison. And we need only consider what comparison is to see that where the objects are more than two, and still more when they are an indefinite number, a type of some sort is an indispensable condition of the comparison. When we have to arrange and classify a great number of objects according to their agreements and differences, we do not make a confused attempt to compare all with all. We know that two things are as much as the mind can easily attend to at a time, and we therefore fix upon one of the objects, either at hazard or because it offers in a peculiarly striking manner some important character, and taking this as our standard, compare it with one object after another. If we find a second object which presents a remarkable agreement with the first, inducing us to class them together, the question instantly arises, in what particular circumstances do they agree? And to take notice of these circumstances is already a first stage of abstraction, giving rise to a general conception. Having advanced thus far, when we now take in hand a third object, we naturally ask ourselves the question, not merely whether this third object agrees with the first, but whether it agrees with it in the same circumstances in which the second did. In other words, whether it agrees with the general conception which has been obtained by abstraction from the first and second. Thus, we see the tendency of general conceptions, as soon as formed, to substitute themselves as types for whatever individual objects previously answered that purpose in our comparisons. We may perhaps find that no considerable number of other objects agree with this first general conception, and that we must drop the conception, and beginning again with a different individual case, proceed by fresh comparisons to a different general conception. Sometimes, again, we find that the same conception will serve by merely leaving out some of its circumstances, and by this higher effort of abstraction we obtain a still more general conception, as in the case formerly referred to, the scientific world rose from the conception of poles to the general conception of opposite properties in opposite directions. Or as those South Sea Islanders whose conception of a quadruped had been abstracted from hogs, the only animals of that description which they had seen, when they afterward compared that conception with other quadrupeds, dropped some of the circumstances, and arrived at the more general conception which Europeans associate with the term. These brief remarks contain, I believe, all that is well grounded in the doctrine, that the conception by which the mind arranges and gives unity to phenomena must be furnished by the mind itself, and that we find the right conception by a tentative process, trying first one and then another until we hit the mark. The conception is not furnished by the mind until it has been furnished to the mind, and the facts which supply it are sometimes extraneous facts, but more often the very facts which we are attempting to arrange by it. It is quite true, however, that in endeavouring to arrange the facts at whatever point we begin, we never advance 3 steps without forming a general conception, more or less distinct and precise, and that this general conception becomes the clue which we instantly endeavour to trace through the rest of the facts, or rather becomes the standard with which we thenceforth compare them. If we are not satisfied with the agreements which we discover among the phenomena by comparing them with this type, or with some still more general conception, which by an additional stage of abstraction we can form from the type, we change our path and look out for other agreements. We recommence the comparison from a different starting point, and so generate a different set of general conceptions. This is the tentative process which Dr. Whewell speaks of, and which has not unnaturally suggested the theory that the conception is supplied by the mind itself, since the different conceptions which the mind successively tries, it either already possessed from its previous experience, or they were supplied to it in the first stage of the corresponding act of comparison, so that in the subsequent part of the process the conception manifested itself as something compared with the phenomena, not evolved from them. Part 4. If this be a correct account of the instrumentality of general conceptions in the comparison which necessarily precedes induction, we are now able to translate into our own language what Dr. Whewell means by saying that the conceptions, to be subservient to induction, must be clear and appropriate. If the conception corresponds to a real agreement among the phenomena, if the comparison which we have made of a set of objects has led us to class them according to real resemblances and differences, the conception which does this cannot fail to be appropriate for some purpose or other. The question of appropriateness is relative to the particular object we have in view. As soon as, by our comparison, we have ascertained some agreement, something which can be predicated in common of a number of objects, we have obtained a basis on which an inductive process is capable of being founded. But the agreements, or the ulterior consequences to which those agreements lead, may be of very different degrees of importance. If, for instance, we only compare animals according to their colour and class those together which are coloured alike, we form the general conceptions of a white animal, a black animal, and so on, which are conceptions legitimately formed. And if an induction were to be attempted concerning the causes of the colours of animals, this comparison would be the proper and necessary preparation for such an induction, but would not help us toward a knowledge of the laws of any other of the properties of animals. While if, with Cuvier, we compare and class them according to the structure of the skeleton, or with Blainville according to the nature of their outward integuments, the agreements and differences which are observable in these respects are not only of much greater importance in themselves, but are marks of agreement and differences in many other important particulars of the structure and mode of life of the animals. If, therefore, the study of their structure and habits be our object, the conceptions generated by these last comparisons are far more appropriate than those generated by the former. Nothing other than this can be meant by the appropriateness of a conception. When Dr. Whewell says that the ancients, or the schoolmen, or any modern inquirers missed discovering the real law of a phenomenon because they applied to it an inappropriate instead of an appropriate conception, he can only mean that in comparing various instances of the phenomenon, to ascertain in what those instances agreed, they missed the important points of agreement, and fastened upon such as were either imaginary and not agreements at all, or, if real agreements, were comparatively trifling, and had no connection with the phenomenon, the law of which was sought. Aristotle, philosophizing on the subject of motion, remarked that certain motions apparently take place spontaneously. Bodies fall to the ground, flame ascends, bubbles of air rise in water, and so on, and these he called natural motions, while others not only never take place without external incitement, but even when such incitement is applied, tend spontaneously to cease, which, to distinguish them from the former, he called violent motions. Now, in comparing the so-called natural motions with one another, it appeared to Aristotle that they agreed in one circumstance, namely, that the body which moved, or seemed to move spontaneously, was moving toward its own place, meaning thereby the place from whence it originally came, or the place where a great quantity of matter similar to itself was assembled. In the other class of motions, as when bodies are thrown up in the air, they are, on the contrary, moving from their own place. Now, this conception of a body moving toward its own place may justly be considered inappropriate, because, though it expresses a circumstance really found in some of the most familiar instances of motion apparently spontaneous, yet first, there are many other cases of such motion in which that circumstance is absent, the motion, for instance, of the earth and planets. Secondly, even when it is present, the motion on closer examination would often be seen not to be spontaneous, as when air rises in water. It does not rise by its own nature, but is pushed up by the superior weight of the water which presses upon it. Finally, there are many cases in which the spontaneous motion takes place in the contrary direction to what the theory considers as the body's own place. For instance, when a fog rises from a lake, or when water dries up. The agreement, therefore, which Aristotle selected as his principle of classification did not extend to all cases of the phenomenon he wanted to study. Spontaneous motion, while it did include cases of the absence of the phenomenon, cases of motion not spontaneous. The conception was here inappropriate. We may add that, in the case in question, no conception would be appropriate. There is no agreement which runs through all the cases of spontaneous or apparently spontaneous motion and no others. They cannot be brought under one law. It is a case of plurality of causes. Footnote. Other examples of inappropriate conceptions are given by Dr. Whipple, The Philosophy of the Inductive Sciences, founded upon their history, Book 2, page 185, as follows. Quote, Aristotle and his followers endeavored in vain to account for the mechanical relation of forces in the lever by applying the inappropriate geometrical conceptions of the properties of the circle. They failed in explaining the form of the luminous spot made by the sun shining through a hole, because they applied the inappropriate conception of a circular quality in the sun's light. They speculated to no purpose about the elementary composition of bodies because they assumed the inappropriate conception of likeness between the elements and the compound, instead of the genuine notion of elements merely determining the qualities of the compound. End quote. But in these cases there is more than an inappropriate conception. There is a false conception, one which has no prototype in nature, nothing corresponding to it in facts. This is evident in the last two examples, and is equally true in the first. The properties of the circle, which were referred to, being purely fantastical. There is, therefore, an error beyond the wrong choice of a principle of generalization. There is a false assumption of matters of fact. the attempt is made to resolve certain laws of nature into a more general law, that law not being one which, though real, is inappropriate, but one wholly imaginary. End footnote. Part 5. So much for the first of Dr. Whewell's conditions, that conceptions must be appropriate. The second is that they shall be clear, and let us consider what this implies. Unless the conception corresponds to a real agreement, it has a worse defect than that of not being clear. It is not applicable to the case at all. Among the phenomena, therefore, which we are attempting to connect by means of the conception, we must suppose that there really is an agreement, and that the conception is a conception of that agreement. In order, then, that it may be clear, the only requisite is that we shall know exactly in what the agreement consists, that it shall have been carefully observed and accurately remembered. We are said not to have a clear conception of the resemblance among a set of objects when we have only a general feeling that they resemble, without having analyzed their resemblance or perceived in what points it consists, and fixed in our memory an exact recollection of those points. This want of clearness, or, as it may be otherwise called, this vagueness in the general conception, may be owing either to our having no accurate knowledge of the objects themselves, or merely to our not having carefully compared them. Thus a person may have no clear idea of a ship, because he has never seen one, or because he remembers but little, and that faintly, of what he has seen. Or he may have a perfect knowledge and remembrance of many ships of various kinds, frigates among the rest, but he may have no clear but only a confused idea of a frigate, because he has never been told, and has not compared them sufficiently to have remarked and remembered in what particular points a frigate differs from some other kind of ship. It is not, however, necessary in order to have clear ideas that we should know all the common properties of the things which we class together. That would be to have our conception of the class complete as well as clear. It is sufficient if we never class things together without knowing exactly why we do so, without having ascertained exactly what agreements we are about to include in our conception, and if, after having thus fixed our conception, we never vary from it, never include in the class any thing which has not those common properties, nor exclude from it any thing which has. A clear conception means a determinate conception, one which does not fluctuate, which is not one thing today and another tomorrow, but remains fixed and invariable, except when, from the progress of our knowledge, or the correction of some error, we consciously add to it or alter it. A person of clear ideas is a person who always knows, in virtue of what properties his classes are constituted, what attributes are connoted by his general names. The principal requisites, therefore, of clear conceptions are habits of attentive observation, an extensive experience, and a memory which receives and retains an exact image of what is observed. And in proportion as any one has the habit of observing minutely and comparing carefully a particular class of phenomena, and an accurate memory for the results of the observations and comparison, so will his conceptions of that class of phenomena be clear, provided he has the indispensable habit, naturally, however, resulting from those other endowments, of never using general names without a precise connotation. As the clearness of our conceptions chiefly depends upon the carefulness and accuracy of our observing and comparing faculties, so their appropriateness, or rather the chance we have of hitting upon the appropriate conception in any case, mainly depends on the activity of the same faculties. He who by habit, grounded on sufficient natural aptitude, has acquired a readiness in accurately observing and comparing phenomena, will perceive so many more agreements, and will perceive them so much more rapidly than other people, that the chances are much greater of his perceiving in any instance the agreement on which the important consequences depend. Part 6. It is of so much importance that the part of the process of investigating truth discussed in this chapter should be rightly understood that I think it is desirable to restate the results we have arrived at in a somewhat different mode of expression. We cannot ascertain general truths, that is, truths applicable to classes, unless we have formed the classes in such a manner that general truths can be affirmed of them. In the formation of any class, there is involved a conception of it as a class, that is, a conception of certain circumstances as being those which characterize the class and distinguish the objects composing it from all other things. When we know exactly what these circumstances are, we have a clear idea or conception of the class and of the meaning of the general name which designates it. The primary condition implied in having this clear idea is that the class be really a class, that it corresponds to a real distinction, that the things it includes really do agree with one another in certain particulars and differ in those same particulars from all other things. A person without clear ideas is one who habitually classes together under the same general names things which have no common properties, or none which are not possessed also by other things, or who, if the usage of other people prevents him from actually misclassing things, is unable to state to himself the common properties in virtue of which he classes them rightly. But is it not the sole requisite of classification that the classes should be real classes, framed by a legitimate mental process? Some modes of classing things are more valuable than others for human uses, whether of speculation or of practice, and our classifications are not well made unless the things which they bring together not only agree with each other in something which distinguishes them from all other things, but agree with each other and differ from other things in the very circumstances which are of primary importance for the purpose, theoretical or practical, which we have in view, and which constitutes the problem before us. In other words, our conceptions, though they may be clear, are not appropriate for our purpose unless the properties we comprise in them are those which will help us toward what we wish to understand, that is, either those which go deepest into the nature of things, if our object be to understand that, or those which are most closely connected with the particular property which we are endeavoring to investigate. We cannot, therefore, frame good general conceptions beforehand. That the conception we have obtained is the one we want can only be known when we have done the work for the sake of which we wanted it, when we completely understand the general character of the phenomena, or the conditions of the particular property with which we concern ourselves. General conceptions formed without this thorough knowledge are Bacon's notiones temere a rebus abstractiae. Yet such premature conceptions we must be continually making up in our progress to something better. They are an impediment to the progress of knowledge only when they are permanently acquiesced in. When it has become our habit to group things in wrong classes, in groups which either are not really classes, having no distinctive points of agreement, absence of clear ideas, or which are not classes of which anything important to our purpose can be predicated, absence of appropriate ideas, and when, in the belief that these badly made classes are those sanctioned by nature, we refuse to exchange them for others, and cannot or will not make up our general conceptions from any other elements. In that case, all the evils which Bacon ascribes to his notiones temere abstractae really occur. This was what the ancients did in physics, and what the world in general does in morals and politics to the present day. It would thus, in my view of the matter, be an inaccurate mode of expression to say that obtaining appropriate conceptions is a condition precedent to generalization. Throughout the whole process of comparing phenomena with one another for the purpose of generalization, the mind is trying to make up a conception. But the conception which it is trying to make up is that of the really important point of agreement in the phenomena. As we obtain more knowledge of the phenomena themselves and of the conditions on which their important properties depend, our views on this subject naturally alter, and thus we advance from a less to a more appropriate general conception in the progress of our investigations. We ought not, at the same time, to forget that the really important agreement cannot always be discovered by mere comparison of the very phenomena in question, without the aid of a conception acquired elsewhere, as in the case so often referred to of the planetary orbits. The search for the agreement of a set of phenomena is in truth very similar to the search for a lost or hidden object. At first we place ourselves in a sufficiently commanding position and cast our eyes round us, and if we can see the object it is well. If not, we ask ourselves mentally what are the places in which it may be hid, in order that we may there search for it, and so on, until we imagine the place where it really is. And here too we require to have had a previous conception or knowledge of those different places. As in this familiar process, so in the philosophical operation which it illustrates. We first endeavour to find the lost object, or recognize the common attribute, without conjecturally invoking the aid of any previously acquired conception, or, in other words, of any hypothesis. Having failed in this, we call upon our imagination for some hypothesis of a possible place, or a possible point of resemblance, and then look to see whether the facts agree with the conjecture. For such cases, something more is required than a mind accustomed to accurate observation and comparison. It must be a mind stored with general conceptions, previously acquired, of the sorts which bear affinity to the subject of the particular inquiry, and much will also depend on the natural strength and acquired culture of what has been termed the scientific imagination, on the faculty possessed of mentally arranging known elements into new combinations, such as have not yet been observed in nature, though not contradictory to any known laws. But the variety of intellectual habits, the purposes which they serve, and the modes in which they may be fostered and cultivated, are considerations belonging to the art of education, a subject far wider than logic, and which this treatise does not profess to discuss. Here, therefore, the present chapter may properly close. End of section 64. Section 65 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 4, Chapter 3, of Naming as Subsidiary to Induction. Part 1. It does not belong to the present undertaking to dwell on the importance of language as a medium of human intercourse, whether for purposes of sympathy or of information. Nor does our design admit of more than a passing allusion to that great property of names, on which their functions as an intellectual instrument are, in reality, ultimately dependent, their potency as a means of forming and of riveting associations among our other ideas, a subject on which an able thinker, Professor Bain, has thus written, quote, "Names are impressions of sense, and as such take the strongest hold on the mind, and of all other impressions can be most easily recalled and retained in view. They therefore serve to give a point of attachment to all the more volatile objects of thought and feeling. Impressions that when past might be dissipated for ever are, by their connection with language, always within reach. Thoughts of themselves are perpetually slipping out of the field of immediate mental vision, but the name abides with us, and the utterance of it restores them in a moment. Words are the custodians of every product of mind less impressive than themselves. All extensions of human knowledge, all new generalizations, are fixed and spread even unintentionally by the use of words. The child growing up learns, along with the vocables of his mother tongue, that things which he would have believed to be different are, in important points, the same. Without any formal instruction, the language in which we grow up teaches us all the common philosophy of the age. It directs us to observe and know things which we should have overlooked. It supplies us with classifications ready-made, by which things are arranged, as far as the light of a bygone generation admits, with the objects to which they bear the greatest total resemblance. The number of general names in a language, and the degree of generality of those names, afford a test of the knowledge of the era, and of the intellectual insight which is the birthright of any one born into it." End quote. It is not, however, of the functions of names considered generally that we have here to treat, but only of the manner and degree in which they are directly instrumental to the investigation of truth, in other words, to the process of induction. Part 2. Observation and abstraction, the operations which formed the subject of the two foregoing chapters, are conditions indispensable to induction. There can be no induction where they are not. It has been imagined that naming is also a condition equally indispensable. There are thinkers who have held that language is not solely, according to a phrase generally current, an instrument of thought, but the instrument, that names or something equivalent to them, some species of artificial signs, are necessary to reasoning, that there could be no inference and consequently no induction without them. But if the nature of reasoning was correctly explained in the earlier part of the present work, this opinion must be held to be an exaggeration, though of an important truth. If reasoning be from particulars to particulars, and if it consist in recognizing one fact as a mark of another, or a mark of another, nothing is required to render reasoning possible except senses and association. Senses to perceive that two facts are conjoined, association as the law by which one of these two facts raises up the idea of the other. Footnote. This sentence having been erroneously understood as if I had meant to assert that belief is nothing but an irresistible association, I think it necessary to observe that I express no theory respecting the ultimate analysis either of reasoning or of belief, two of the most obscure points in analytical psychology. I am speaking not of the powers themselves, but of the previous conditions necessary to enable those powers to exert themselves, of which conditions I am contending that language is not one, senses and association being sufficient without it. The irresistible association theory of belief and the difficulties connected with the subject have been discussed at length in the notes to the new edition of Mr. James Mill's Analysis of the Phenomena of the Human Mind. End footnote. For these mental phenomena, as well as for the belief or expectation which follows, and by which we recognize as having taken place, or as about to take place, that of which we have perceived a mark, there is evidently no need of language, and this inference of one particular fact from another is a case of induction. It is of this sort of induction that brutes are capable. It is in this shape that uncultivated minds make almost all their inductions, and that we all do so in the cases in which familiar experience forces our conclusions upon us without any active process of inquiry on our part, and in which the belief or expectation follows the suggestion of the evidence with the promptitude and certainty of an instinct. Footnote. Mr. Bailey agrees with me in thinking that whenever, quote, from something actually present to my senses, conjoined with past experience, I feel satisfied that something has happened, or will happen, or is happening, beyond the sphere of my personal observation. End quote. I may with strict propriety be said to reason, and of course to reason inductively, for demonstrative reasoning is excluded by the circumstances of the case. The Theory of Reasoning, 2nd edition, page 27. End footnote. Part 3. But though inference of an inductive character is possible without the use of signs, it could never, without them, be carried much beyond the very simple cases which we have just described, and which form, in all probability, the limit of the reasonings of those animals to whom conventional language is unknown. Without language, or something equivalent to it, there could only be as much reasoning from experience as can take place without the aid of general propositions. Now, though in strictness we may reason from past experience to a fresh individual case without the intermediate stage of a general proposition, yet without general propositions we should seldom remember what past experience we have had, and scarcely ever what conclusions that experience will warrant. The division of the inductive process into two parts, the first ascertaining what is a mark of the given fact, the second whether, in the new case, that mark exists, is natural and scientifically indispensable. It is, indeed, in a majority of cases, rendered necessary by mere distance of time. The experience by which we are to guide our judgments may be other people's experience, little of which can be communicated to us otherwise than by language. When it is our own, it is generally experience long past, unless, therefore, it were recorded by means of artificial signs, little of it, except in cases involving our intenser sensations or emotions, or the subjects of our daily and hourly contemplation, would be retained in the memory. It is hardly necessary to add that when the inductive inference is of any but the most direct and obvious nature, when it requires several observations or experiments in varying circumstances and the comparison of one of these with another, it is impossible to proceed a step without the artificial memory which words bestow. Without words, we should, if we had often seen A and B in immediate and obvious conjunction, expect B whenever we saw A. But to discover their conjunction when not obvious, or to determine whether it is really constant or only casual, and whether there is reason to expect it under any given change of circumstances, is a process far too complex to be performed without some contrivance to make our remembrance of our own mental operations accurate. Now, language is such a contrivance. When that instrument is called to our aid, the difficulty is reduced to that of making our remembrance of the meaning of words accurate. This being secured, whatever passes through our minds may be remembered accurately by putting it carefully into words and committing the words either to writing or to memory. The function of naming, and particularly of general names, in induction may be recapitulated as follows. Every inductive inference which is good at all is good for a whole class of cases, and that the inference may have any better warrant of its correctness than the mere clinging together of two ideas, a process of experimentation and comparison is necessary, in which the whole class of cases must be brought to view, and some uniformity in the course of nature evolved and ascertained, since the existence of such a uniformity is required as a justification for drawing the inference in even a single case. This uniformity, therefore, may be ascertained once for all, and if being ascertained it can be remembered, it will serve as a formula for making in particular cases all such inferences as the previous experience will warrant. But we can only secure its being remembered, or give ourselves even a chance of carrying in our memory any considerable number of such uniformities, by registering them through the medium of permanent signs, which, being from the nature of the case signs not of an individual fact but of a uniformity, that is, of an indefinite number of facts similar to one another, are general signs, universals, general names, and general propositions. Part 4. And here I cannot omit to notice an oversight committed by some eminent thinkers, who have said that the cause of our using general names is the infinite multitude of individual objects, which, making it impossible to have a name for each, compels us to make one name serve for many. This is a very limited view of the function of general names. Even if they were a name for every individual object, we should require general names as much as we now do. Without them we could not express the result of a single comparison, nor record any one of the uniformities existing in nature, and should be hardly better off in respect to induction than if we had no names at all. With none but names of individuals, or, in other words, proper names, we might, by pronouncing the name, suggest the idea of the object, but we could not assert any proposition, except the unmeaning ones formed by predicating two proper names one of another. It is only by means of general names that we can convey any information, predicate any attribute, even of an individual, much more of a class. Rigorously speaking, we could get on without any other general names than the abstract names of attributes. All our propositions might be of the form, quote, such an individual object possesses such an attribute, end quote, or, quote, such an attribute is always, or never, conjoined with such another attribute, end quote. In fact, however, mankind have always given general names to objects as well as attributes, and indeed before attributes. But the general names given to objects imply attributes, derive their whole meaning from attributes, and are chiefly useful as the language by means of which we predicate the attributes which they connote. It remains to be considered what principles are to be adhered to in giving general names, so that these names, and the general propositions in which they fill a place, may conduce most to the purposes of induction. End of section 65. Section 66 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 4, Chapter 4, of the Requisites of a Philosophical Language and the Principles of Definition, Parts 1 through 4. Part 1. In order that we may possess a language perfectly suitable for the investigation and expression of general truths, there are two principal and several minor requisites. The first is, that every general name should have a meaning steadily fixed and precisely determined. When by the fulfillment of this condition such names as we possess are fitted for the due performance of their functions, the next requisite, and the second in order of importance, is that we should possess a name wherever one is needed, wherever there is anything to be designated by it, which is of importance to express. The former of these requisites is that to which our attention will be exclusively directed in the present chapter. Part 2. Every general name, then, must have a certain and knowable meaning. Now the meaning, as has so often been explained, of a general connotative name resides in the connotation, in the attribute on account of which, and to express which, the name is given. Thus, the name animal being given to all things which possess the attributes of sensation and voluntary motion, The word connotes those attributes exclusively, and they constitute the whole of its meaning. If the name be abstract, its denotation is the same with the connotation of the corresponding concrete. It designates directly the attribute which the concrete term implies. To give a precise meaning to general names is, then, to fix with steadiness the attribute or attributes connoted by each concrete general name, and denoted by the corresponding abstract. Since abstract names, in the order of their creation, do not precede but follow concrete ones, as is proved by the etymological fact that they are almost always derived from them, we may consider their meaning as determined by and dependent on the meaning of their concrete, and thus the problem of giving a distinct meaning to general language is all included in that of giving a precise connotation to all concrete general names. This is not difficult in the case of new names, of the technical terms created by scientific inquirers for the purposes of science or art. But when a name is in common use, the difficulty is greater, the problem in this case not being that of choosing a convenient connotation for the name, but of ascertaining and fixing the connotation with which it is already used. That this can ever be a matter of doubt is a sort of paradox. But the vulgar, including in that term all who have not accurate habits of thought, seldom know exactly what assertion they intend to make, what common property they mean to express, when they apply the same name to a number of different things. All which the name expresses with them, when they predicate it of an object, is a confused feeling of resemblance between that object and some of the other things which they have been accustomed to denote by the name. They have applied the name stone to various objects previously seen. They see a new object which appears to them somewhat like the former, and they call it a stone, without asking themselves in what respect it is like, or what mode or degree of resemblance the best authorities, or even they themselves, require as a warrant for using the name. This rough general impression of resemblance is, however, made up of particular circumstances of resemblance, and into these it is the business of the logician to analyze it, to ascertain what points of resemblance among the different things commonly called by name have produced in the common mind this vague feeling of likeness, have given to the things the similarity of aspect which has made them a class, and has caused the same name to be bestowed upon them. But though general names are imposed by the vulgar without any more definite connotation than that of a vague resemblance, general propositions come in time to be made in which predicates are applied to those names, that is, general assertions are made concerning the whole of the things which are denoted by the name. And since by each of these propositions some attribute more or less precisely conceived is of course predicated, the ideas of these various attributes thus become associated with the name, and in a sort of uncertain way it comes to connote them. There is a hesitation to apply the name in any new case in which any of the attributes familiarly predicated of the class do not exist, and thus to common minds the propositions which they are in the habit of hearing or uttering concerning a class make up in a loose way a sort of connotation for the class name. Let us take, for instance, the word civilized. How few could be found, even among the most educated persons, who would undertake to say exactly what the term civilized connotes. Yet there is a feeling in the minds of all who use it that they are using it with a meaning, and this meaning is made up, in a confused manner, of everything which they have heard or read that civilized men or civilized communities are, or may be expected to be. It is at this stage, probably, in the progress of a concrete name, that the corresponding abstract name generally comes into use. Under the notion that the concrete name must of course convey a meaning, or in other words, that there is some property common to all things which it denotes, people give a name to this common property. From the concrete civilized, they form the abstract civilization. But since most people have never compared the different things which are called by the concrete name in such a manner as to ascertain what properties these things have in common, or whether they have any, each is thrown back upon the marks by which he himself has been accustomed to be guided in his application of the term, and these being merely vague hearsays and current phrases are not the same in any two persons, nor in the same person at different times. Hence the word, as civilization for example, which professes to be the designation of the unknown common property, conveys scarcely to any two minds the same idea. No two persons agree in the things they predicate of it, and when it is itself predicated of any thing, no other person knows, nor does the speaker himself know with precision, what he means to assert. Many other words which could be named, as the word honour or the word gentleman, exemplify this uncertainty still more strikingly. It needs scarcely be observed that general propositions of which no one can tell exactly what they assert cannot possibly have been brought to the test of a correct induction. Whether a name is to be used as an instrument of thinking or as a means of communicating the result of thought, it is imperative to determine exactly the attribute or attributes which it is to express, to give it, in short, a fixed and ascertained connotation. Part 3. It would, however, be a complete misunderstanding of the proper office of a logician in dealing with terms already in use, if we were to think that because a name has not at present an ascertained connotation, it is competent to any one to give it such a connotation at his own choice. The meaning of a term actually in use is not an arbitrary quantity to be fixed, but an unknown quantity to be sought. In the first place, it is obviously desirable to avail ourselves, as far as possible, of the associations already connected with the name, not enjoining the employment of it in a manner which conflicts with all previous habits, and especially not so as to require the rupture of those strongest of all associations between names, which are created by familiarity with propositions in which they are predicated of one another. A philosopher would have little chance of having his example followed if he were to give such a meaning to his terms as should require us to call the North American Indians a civilized people, or the higher classes in Europe savages, or to say that civilized people live by hunting and savages by agriculture. Were there no other reason, the extreme difficulty of effecting so complete a revolution in speech would be more than a sufficient one. The endeavour should be that all generally received propositions into which the term enters should be at least as true after its meaning is fixed as they were before, and that the concrete name, therefore, should not receive such a connotation as shall prevent it from denoting things which, in common language, it is currently affirmed of. The fixed and precise connotation which it receives should not be in deviation from, but in agreement, as far as it goes, with the vague and fluctuating connotation which the term already had. To fix the connotation of a concrete name, or the denotation of the corresponding abstract, is to define the name. When this can be done without rendering any received assertions inadmissible, the name can be defined in accordance with its received use, which is vulgarly called defining not the name, but the thing. What is meant by the improper expression of defining a thing, or rather a class of things, for nobody talks of defining an individual, is to define the name subject to the condition that it shall denote those things. This, of course, supposes a comparison of the things, feature by feature and property by property, to ascertain what attributes they agree in, and not unfrequently an operation strictly inductive, for the purpose of ascertaining some unobvious agreement, which is the cause of the obvious agreements. For, in order to give a connotation to a name consistently with its denoting certain objects, we have to make our selection from among the various attributes in which those objects agree. To ascertain in what they do agree is, therefore, the first logical operation requisite. When this has been done as far as is necessary or practicable, the question arises which of these common attributes shall be selected to be associated with the name. For if the class which the name denotes be a kind, the common properties are innumerable, and even if not, they are often extremely numerous. Our choice is first limited by the preference to be given to properties which are well known and familiarly predicated of the class. But even these are often too numerous to be all included in the definition, and, besides, the properties most generally known may not be those which serve best to mark out the class from all others. We should therefore select from among the common properties, if among them any such are to be found, those on which it has been ascertained by experience or proved by deduction that many others depend, or at least which are sure marks of them, and from whence, therefore, many others will follow by inference. We thus see that to frame a good definition of a name already in use is not a matter of choice, but of discussion, and discussion not merely respecting the usage of language, but respecting the properties of things and even the origin of those properties. And hence, every enlargement of our knowledge of the objects to which the name is applied is liable to suggest an improvement in the definition. It is impossible to frame a perfect set of definitions on any subject until the theory of the subject is perfect. And as science makes progress, its definitions are also progressive. Part 4. The discussion of definitions, in so far as it does not turn on the use of words but on the properties of things, Dr. Whewell calls the explication of conceptions. The act of ascertaining, better than before, in what particulars any phenomena which are classed together agree, he calls in his technical phraseology unfolding the general conception in virtue of which they are so classed. Making allowance for what appears to me the darkening and misleading tendency of this mode of expression, several of his remarks are so much to the purpose that I shall take the liberty of transcribing them. He observes that many of the controversies which have had an important share in the formation of the existing body of science have, quote, assumed the form of a battle of definitions. For example, the inquiry concerning the laws of falling bodies led to the question whether the proper definition of a uniform force is that it generates a velocity proportional to the space from rest or to the time. The controversy of the VIII was what was the proper definition of the measure of force. A principal question in the classification of minerals is, what is the definition of a mineral species? Physiologists have endeavored to throw light on their subject by defining organization or some similar term. End quote. Footnote. Novum Organum Renovatum, pages 35 through 37. End footnote. Questions of the same nature were long open and are not yet completely closed respecting the definitions of specific heat, latent heat, chemical combination, and solution. Quote, it is very important for us to observe that these controversies have never been questions of insulated and arbitrary definitions, as men seem often tempted to imagine them to have been. In all cases there is a tacit assumption of some proposition which is to be expressed by means of the definition, and which gives it its importance. The dispute concerning the definition thus acquires a real value, and becomes a question concerning true and false. Thus, in the discussion of the question, what is a uniform force, it was taken for granted that gravity is a uniform force. In the debate of the VIII, it was assumed that in the mutual action of bodies the whole effect of the force is unchanged. In the zoological definition of species, that it consists of individuals which have or may have sprung from the same parents, it is presumed that individuals so related resemble each other more than those which are excluded by such a definition, or perhaps that species so defined have permanent and definite differences. A definition of organization, or of some other term which was not employed to express some principle, would be of no value. The establishment, therefore, of a right definition of a term may be a useful step in the explication of our conceptions, but this will be the case then only when we have under our consideration some proposition in which the term is employed, for then the question really is how the conception shall be understood and defined in order that the proposition may be true. To unfold our conceptions by means of definitions has never been serviceable to science except when it has been associated with an immediate use of the definitions. The endeavour to define a uniform force was combined with the assertion that gravity is a uniform force. The attempt to define accelerating force was immediately followed by the doctrine that accelerating forces may be compounded. The process of defining momentum was connected with the principle that momenta gained and lost are equal. Naturalists would have given in vain the definition of species which we have quoted, if they had not also given the characters of species so separated. Definition may be the best mode of explaining our conception, but that which alone makes it worthwhile to explain it in any mode is the opportunity of using it in the expression of truth. When a definition is propounded to us as a useful step in knowledge, we are always entitled to ask what principle it serves to enunciate." End quote. In giving, then, an exact connotation to the phrase, "a uniform force," the condition was understood that the phrase should continue to denote gravity. The discussion, therefore, respecting the definition resolved itself into this question: what is there of a uniform nature in the motions produced by gravity? By observations and comparisons, it was found that what was uniform in those motions was the ratio of the velocity acquired to the time elapsed, equal velocities being added in equal times. A uniform force, therefore, was defined a force which adds equal velocities in equal times. So again, in defining momentum, it was already a received doctrine that, when two objects impinge upon one another, the momentum lost by the one is equal to that gained by the other. This proposition it was deemed necessary to preserve, not from the motive, which operates in many other cases, that it was firmly fixed in popular belief, for the proposition in question had never been heard of by any but the scientifically instructed, but it was felt to contain a truth. Even a superficial observation of the phenomena left no doubt that in the propagation of motion from one body to another, there was something of which the one body gained precisely what the other lost, and the word momentum had been invented to express this unknown something. The settlement, therefore, of the definition of momentum involved the determination of the question: what is that of which a body, when it sets another body in motion, loses exactly as much as it communicates? And when experiment had shown that this something was the product of the velocity of the body by its mass or quantity of matter, this became the definition of momentum. The following remarks, therefore, are perfectly just. Quote, "The business of definition is part of the business of discovery. To define so that our definition shall have any scientific value requires no small portion of that sagacity by which truth is detected. when it has been clearly seen what ought to be our definition, it must be pretty well known what truth we have to state. The definition, as well as the discovery, supposes a decided step in our knowledge to have been made. The writers on logic in the Middle Ages made definition the last stage in the progress of knowledge, and in this arrangement at least the history of science and the philosophy derived from the history confirm their speculative views." End quote. Footnote: Novum Organum Renovatum, pages 39 and 40. End footnote. For in order to judge finally how the name which denotes a class may best be defined, we must know all the properties common to the class and all the relations of causation or dependence among those properties. If the properties which are fittest to be selected as marks of other common properties are also obvious and familiar, and especially if they bear a great part in producing that general air of resemblance which was the original inducement to the formation of the class, the definition will then be most felicitous. But it is often necessary to define the class by some property not familiarly known, provided that property be the best mark of those which are known. Mr. de Blainville, for instance, founded his definition of life on the process of decomposition and recomposition, which incessantly takes place in every living body, so that the particles composing it are never for 2 instants the same. This is by no means one of the most obvious properties of living bodies. It might escape altogether the notice of an unscientific observer. Yet great authorities, independently of M. de Blainville, who is himself a first-rate authority, have thought that no other property so well answers the conditions required for the definition. End of section 66. Section 67 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 4, Chapter 4 of the Requisites of a Philosophical Language and the Principles of Definition, Parts 5 through 6. Part 5. Having laid down the principles which ought for the most part to be observed in attempting to give a precise connotation to a term in use, I must now add that it is not always practicable to adhere to those principles, and that even when practicable it is occasionally not desirable. Cases in which it is impossible to comply with all the conditions of a precise definition of a name in agreement with usage occur very frequently. There is often no one connotation capable of being given to a word, so that it shall still denote everything it is accustomed to denote, or that all the propositions into which it is accustomed to enter, and which have any foundation in truth, shall remain true. Independently of accidental ambiguities, in which the different meanings have no connection with one another, it continually happens that a word is used in 2 or more senses derived from each other, but yet radically distinct. So long as a term is vague, that is, so long as its connotation is not ascertained and permanently fixed, it is constantly liable to be applied by extension from one thing to another, until it reaches things which have little or even no resemblance to those which were first designated by it. Quote, "Suppose," says Dugald Stewart in his Philosophical Essays, footnote, Novum Organum Renovatum, 4th edition, page 217, end footnote, that the letters A, B, C, D, E denote a series of objects, that A possesses some one quality in common with B, B a quality in common with C, C a quality in common with D, D a quality in common with E, while at the same time no quality can be found which belongs in common to any 3 objects in the series. Is it not conceivable that the affinity between A and B may produce a transference of the name of the first to the second, and that in consequence of the other affinities which connect the remaining objects together, the same name may pass in succession from B to C, from C to D, and from D to E? In this manner, a common appellation will arise between A and E, although the two objects may, in their nature and properties, be so widely distant from each other that no stretch of imagination can conceive how the thoughts were led from the former to the latter. The transitions, nevertheless, may have been all so easy and gradual that, were they successfully detected by the fortunate ingenuity of a theorist, we should instantly recognize not only the verisimilitude but the truth of the conjecture, in the same way as we admit, with the confidence of intuitive conviction, the certainty of the well-known etymological process which connects the Latin preposition e or ex with the English substantive stranger, the moment that the intermediate links of the chain are submitted to our examination. Footnote. Quote, E, ex, extra, extraneous, étranger, stranger. End quote. Another etymological example sometimes cited is the derivation of the English uncle from the Latin avus. It is scarcely possible for two words to bear fewer outward marks of relationship, yet there is but one step between them: avus, avunculus, uncle. So, pilgrim from ager, per agrum, peragrimus, peregrinus, pellegrino, pilgrim. Professor Bain gives some apt examples of these transitions of meaning. Quote, the word damp primarily signified moist, humid, wet, but the property is often accompanied with the feeling of cold or chilliness, and hence the idea of cold is strongly suggested by the word. This is not all. Proceeding upon the superadded meaning, we speak of damping a man's ardor, a metaphor where the cooling is the only circumstance concerned. We go on still further to designate the iron slide that shuts off the draught of the stove, the damper, the primary meaning being now entirely dropped. Dry, in like manner, through signifying the absence of moisture, water, or liquidity, is applied to sulfuric acid containing water, although not thereby ceasing to be a moist, wet, or liquid substance. End quote. So in the phrases dry sherry or champagne. Quote, street, originally a paved way with or without houses, has been extended to roads lined with houses, whether paved or unpaved. Impertinent signified at first irrelevant, alien to the purpose in hand, through which it has come to mean meddling, intrusive, unmannerly, insolent. End quote. Logic 2, pages 173 and 174. End quote. End footnote. The applications which a word acquires by this gradual extension of it from one set of objects to another, Stuart, adopting an expression from Mr. Payne Knight, calls its transitive applications, and after briefly illustrating such of them as are the result of local or casual associations, he proceeds as follows. Footnote. Novum Organon Renovatum, pages 226 and 227. End footnote. Quote, but although by far the greater part of the transitive or derivative applications of words depend on casual and unaccountable caprices of the feelings or the fancy, there are certain cases in which they open a very interesting field of philosophical speculation. Such are those in which an analogous transference of the corresponding term may be remarked universally or very generally in other languages, and in which, of course, the uniformity of the result must be ascribed to the essential principles of the human frame. Even in such cases, however, it will by no means be always found, on examination, that the various applications of the same term have arisen from any common quality or qualities in the objects to which they relate. In the greater number of instances, they may be traced to some natural and universal associations of ideas founded in the common faculties, common organs, and common condition of the human race. According to the different degrees of intimacy and strength in the associations on which the transitions of language are founded, very different effects may be expected to arise. Where the association is slight and casual, the several meanings will remain distinct from each other, and will often, in process of time, assume the appearance of capricious varieties in the use of the same arbitrary sign. Where the association is so natural and habitual as to become virtually indissoluble, the transitive meanings will coalesce in one complex conception, and every new transition will become a more comprehensive generalization of the term in question. End quote. I solicit particular attention to the law of mind expressed in the last sentence, and which is the source of the perplexity so often experienced in detecting these transitions of meaning. Ignorance of that law is the shoal on which some of the most powerful intellects which have adorned the human race have been stranded. The inquiries of Plato into the definitions of some of the most general terms of moral speculation are characterized by Bacon as a far nearer approach to a true inductive method than is elsewhere to be found among the ancients, and are indeed almost perfect examples of the preparatory process of comparison and abstraction. But from being unaware of the law just mentioned, he often wasted the powers of this great logical instrument on inquiries in which it could realize no result, since the phenomena whose common properties he so elaborately endeavored to detect had not really any common properties. Bacon himself fell into the same error in his speculations on the nature of heat, in which he evidently confounded, under the name hot, classes of phenomena which have no property in common. Stuart certainly overstates the matter when he speaks of, quote, a prejudice which has descended to modern times from the scholastic ages, that when a word admits of a variety of significations, these different significations must all be species of the same genus, and must consequently include some essential idea common to every individual to which the generic term can be applied. End quote. Footnote. Essays on some unsettled questions of political economy, page 214. End footnote. For both Aristotle and his followers were well aware that there are such things as ambiguities of language, and delighted in distinguishing them, but they never suspected ambiguity in the cases where, as Stuart remarks, the association on which the transition of meaning was founded is so natural and habitual that the two meanings blend together in the mind, and a real transition becomes an apparent generalization. Accordingly, they wasted infinite pains in endeavoring to find a definition which would serve for several distinct meanings at once, as in an instance noticed by Stuart himself, that of, quote, causation, the ambiguity of the word which in the Greek language corresponds to the English word cause, having suggested to them the vain attempt of tracing the common idea which, in the case of any effect, belongs to the efficient, to the matter, to the form, and to the end. The idle generalities, he adds, we meet with in other philosophers about the ideas of the good, the fit, and the becoming, have taken their rise from the same undue influence of popular epithets on the speculations of the learned. End quote. Footnote. Essays on some unsettled questions of political economy, page 215. End footnote. Among the words which have undergone so many successive transitions of meaning that every trace of a property common to all the things they are applied to, or at least common and also peculiar to those things, has been lost, Stuart considers the word beautiful to be one. And, without attempting to decide a question which in no respect belongs to logic, I cannot but feel with him considerable doubt whether the word beautiful connotes the same property when we speak of a beautiful colour, a beautiful face, a beautiful scene, a beautiful character, and a beautiful poem. The word was doubtless extended from one of these objects to another on account of a resemblance between them, or more probably between the emotions they excited, and by this progressive extension it has at least reached things very remote from those objects of sight to which there is no doubt that it was first appropriated, and it is at least questionable whether there is now any property common to all things which consistently with usage may be called beautiful, except the property of agreeableness, which the term certainly does connote, but which cannot be all that people usually intend to express by it, since there are many agreeable things which are never called beautiful. If such be the case, it is impossible to give the word beautiful any fixed connotation such that it shall denote all the objects which in common use it now denotes, but no others. A fixed connotation, however, it ought to have, for so long as it has not, it is unfit to be used as a scientific term, and is a perpetual source of false analogies and erroneous generalizations. This then constitutes a case in exemplification of our remark that even when there is a property common to all the things denoted by a name, to erect that property into the definition and exclusive connotation of the name is not always desirable. The various things called beautiful unquestionably resemble one another in being agreeable, but to make this the definition of beauty, and so extend the word beautiful to all agreeable things, would be to drop altogether a portion of meaning which the word really, though indistinctly, conveys, and to do what depends on us toward causing those qualities of the objects which the word previously, though vaguely pointed at, to be overlooked and forgotten. It is better in such a case to give a fixed connotation to the term by restricting rather than by extending its use, rather excluding from the epithet beautiful some things to which it is commonly considered applicable, than leaving out of its connotation any of the qualities by which, though occasionally lost sight of, the general mind may have been habitually guided in the commonest and most interesting applications of the term. For there is no question that when people call anything beautiful, they think they are asserting more than that it is merely agreeable. They think they are ascribing a particular sort of agreeableness, analogous to that which they find in some other of the things to which they are accustomed to apply the same name. If therefore there be any peculiar sort of agreeableness which is common, though not to all, yet to the principal things which are called beautiful, it is better to limit the denotation of the term to those things, than to leave that kind of quality without a term to connote it, and thereby divert attention from its peculiarities. Part 6. The last remark exemplifies a rule of terminology which is of great importance, and which has hardly yet been recognized as a rule, but by a few thinkers of the present century. In attempting to rectify the use of a vague term by giving it a fixed connotation, we must take care not to discard, unless advisedly and on the ground of a deeper knowledge of the subject, any portion of the connotation which the word, in however indistinct a manner, previously carried with it, for otherwise language loses one of its inherent and most valuable properties, that of being the conservator of ancient experience, the keeper alive of those thoughts and observations of former ages which may be alien to the tendencies of the passing time. This function of language is so often overlooked or undervalued, that a few observations on it appear to be extremely required. Even when the connotation of a term has been accurately fixed, and still more if it has been left in the state of a vague, unanalyzed feeling of resemblance, there is a constant tendency in the word, through familiar use, to part with a portion of its connotation. It is a well-known law of the mind that a word originally associated with a very complex cluster of ideas is far from calling up all those ideas in the mind every time the word is used. It calls up only one or two, from which the mind runs on by fresh associations to another set of ideas, without waiting for the suggestion of the remainder of the complex cluster. If this were not the case, processes of thought could not take place with anything like the rapidity which we know they possess. Very often, indeed, when we are employing a word in our mental operations, we are so far from waiting until the complex idea which corresponds to the meaning of the word is consciously brought before us in all its parts, that we run on to new trains of ideas by the other associations which the mere word excites, without having realized in our imagination any part whatever of the meaning, thus using the word, and even using it well and accurately, and carrying on important processes of reasoning by means of it in an almost mechanical manner, so much so that some metaphysicians, generalizing from an extreme case, have fancied that all reasoning is but the mechanical use of a set of terms according to a certain form. We may discuss and settle the most important interests of towns or nations by the application of general theorems or practical maxims previously laid down, without having had consciously suggested to us once in the whole process the houses and green fields, the thronged marketplaces and domestic hearths, of which not only those towns and nations consist, but which the words town and nation confessedly mean. Since, then, general names come in this manner to be used, and even to do a portion of their work well, without suggesting to the mind the whole of their meaning, and often with the suggestion of a very small or no part at all of that meaning, we cannot wonder that words so used come in time to be no longer capable of suggesting any other of the ideas appropriated to them than those with which the association is most immediate and strongest, or most kept up by the incidents of life, the remainder being lost altogether, unless the mind, by often consciously dwelling on them, keeps up the association. Words naturally retain much more of their meaning to persons of active imagination, who habitually represent to themselves things in the concrete, with the detail which belongs to them in the actual world. To minds of a different description, the only antidote to this corruption of language is predication. The habit of predicating of the name, all the various properties which it originally connoted, keeps up the association between the name and those properties. But in order that it may do so, it is necessary that the predicates should themselves retain their association with the properties which they severally connote. For the propositions cannot keep the meaning of the words alive if the meaning of the propositions themselves should die. And nothing is more common than for propositions to be mechanically repeated, mechanically retained in the memory, and their truth undoubtingly assented to and relied on, while yet they carry no meaning distinctly home to the mind, and while the matter of fact or law of nature which they originally expressed is as much lost sight of and practically disregarded as if it never had been heard of at all. In those subjects which are at the same time familiar and complicated, and especially in those which are so in as great a degree as moral and social subjects are, it is a matter of common remark how many important propositions are believed and repeated from habit, while no account could be given and no sense is practically manifested of the truths which they convey. Hence it is that the traditional maxims of old experience, though seldom questioned, have often so little effect on the conduct of life, because their meaning is never by most persons really felt until personal experience has brought it home. And thus also it is that so many doctrines of religion, ethics, and even politics, so full of meaning and reality to first converts, have manifested, after the association of that meaning with the verbal formulas has ceased to be kept up by the controversies which accompanied their first introduction, a tendency to degenerate rapidly into lifeless dogmas, which tendency all the efforts of an education expressly and skillfully directed to keeping the meaning alive are barely sufficient to counteract. Considering, then, that the human mind in different generations occupies itself with different things, and in one age is led by the circumstances which surround it to fix more of its attention upon one of the properties of a thing, in another age upon another, it is natural and inevitable that in every age a certain portion of our recorded and traditional knowledge, not being continually suggested by the purists and inquiries with which mankind are at that time engrossed, should fall asleep, as it were, and fade from the memory. It would be in danger of being totally lost if the propositions or formulas, the results of the previous experience, did not remain, as forms of words it may be, but of words that once really conveyed, and are still supposed to convey, a meaning, which meaning, though suspended, may be historically traced, and when suggested may be recognized by minds of the necessary endowments as being still matter of fact or truth. While the formulas remain, the meaning may at any time revive. And as, on the one hand, the formulas progressively lose the meaning they were intended to convey, so, on the other, when this forgetfulness has reached its height and begun to produce obvious consequences, minds arise which from the contemplation of the formulas rediscover the truth, when truth it was which was contained in them, and announce it again to mankind, not as a discovery, but as the meaning of that which they have been taught and still profess to believe. Thus there is a perpetual oscillation in spiritual truths and in spiritual doctrines of any significance, even when not truths. Their meaning is almost always in a process either of being lost or of being recovered. Whoever has attended to the history of the more serious convictions of mankind, of the opinions by which the general conduct of their lives is, or, as they conceive ought to be, more especially regulated, is aware that even when recognizing verbally the same doctrines, they attach to them, at different periods, a greater or a less quantity, and even a different kind of meaning. The words in their original acceptation connoted, and the propositions expressed, a complication of outward facts and inward feelings, to different portions of which the general mind is more particularly alive in different generations of mankind. To common minds, only that portion of the meaning is in each generation suggested, of which that generation possesses the counterpart in its own habitual experience. But the words and propositions lie ready to suggest to any mind duly prepared the remainder of the meaning. Such individual minds are almost always to be found, and the lost meaning, revived by them, again by degrees works its way into the general mind. The arrival of this salutary reaction may, however, be materially retarded by the shallow conceptions and incautious proceedings of mere logicians. It sometimes happens that toward the close of the downward period, when the words have lost part of their significance and have not yet begun to recover it, persons arise whose leading and favourite idea is the importance of clear conceptions and precise thought, and the necessity, therefore, of definite language. These persons, in examining the old formulas, easily perceive that words are used in them without a meaning, and if they are not the sort of persons who are capable of rediscovering the lost signification, they naturally enough dismiss the formula, and define the name without reference to it. In so doing, they fasten down the name to what it connotes in common use at the time when it conveys the smallest quantity of meaning, and introduce the practice of employing it consistently and uniformly according to that connotation. The word in this way acquires an extent of denotation far beyond what it had before. It becomes extended to many things to which it was previously, in appearance capriciously, refused. Of the propositions in which it was formerly used, those which were true in virtue of the forgotten part of its meaning are now, by the clearer light which the definition diffuses, seen not to be true according to the definition, which, however, is the recognized and sufficiently correct expression of all that is perceived to be in the mind of any one by whom the term is used at the present day. The ancient formulas are consequently treated as prejudices, and people are no longer taught as before, though not to understand them, yet to believe that there is truth in them. They no longer remain in the general mind, surrounded by respect and ready at any time to suggest their original meaning. Whatever truths they contain are not only, in these circumstances, rediscovered far more slowly, but when rediscovered, the prejudice with which novelties are regarded is now, in some degree at least, against them, instead of being on their side. An example may make these remarks more intelligible. In all ages, except where moral speculation has been silenced by outward compulsion, or where the feelings which prompt to it still continue to be satisfied by the traditional doctrines of an established faith, one of the subjects which have most occupied the minds of thinking persons is the inquiry, what is virtue? Or, what is a virtuous character? Among the different theories on the subject which have at different times grown up and obtained partial currency, every one of which reflected as in the clearest mirror the express image of the age which gave it birth, there was one according to which virtue consists in a correct calculation of our own personal interests, either in this world only or also in another. To make this theory plausible, it was, of course, necessary that the only beneficial actions which people in general were accustomed to see, or were therefore accustomed to praise, should be such as were, or at least might, without contradicting obvious facts, be supposed to be the result of a prudential regard to self-interest, so that the words really connoted no more in common acceptation than was set down in the definition. Suppose, now, that the partisans of this theory had contrived to introduce a consistent and undeviating use of the term according to this definition. Suppose that they had seriously endeavoured, and had succeeded in the endeavour, to banish the word disinterestedness from the language, had obtained the disuse of all expressions attaching odium to selfishness or commendation to self-sacrifice, or which implied generosity or kindness to be anything but doing a benefit in order to receive a greater personal advantage in return. Need we say that this abrogation of the old formulas for the sake of preserving clear ideas and consistency of thought would have been a great evil? While the very inconsistency incurred by the coexistence of the formulas with philosophical opinions, which seemed to condemn them as absurdities, operated as a stimulus to the re-examination of the subject, and thus the very doctrines originating in the oblivion into which a part of the truth had fallen were rendered indirectly but powerfully instrumental to its revival. The doctrine of the Coleridge school, that the language of any people among whom culture is of old date is a sacred deposit, the property of all ages, and which no one age should consider itself empowered to alter, borders indeed, as thus expressed, on an extravagance, but it is grounded on a truth frequently overlooked by that class of logicians who think more of having a clear than of having a comprehensive meaning, and who perceive that every age is adding to the truth which it has received from its predecessors, but fail to see that a counter-process of losing truths already possessed is also constantly going on, and requiring the most sedulous attention to counteract it. Language is the depository of the accumulated body of experience to which all former ages have contributed their part, and which is the inheritance of all yet to come. We have no right to prevent ourselves from transmitting to posterity a larger portion of this inheritance than we may ourselves have profited by. However much we may be able to improve on the conclusions of our forefathers, we ought to be careful not inadvertently to let any of their premises slip through our fingers. It may be good to alter the meaning of a word, but it is bad to let any part of the meaning drop. Whoever seeks to introduce a more correct use of a term with which important associations are connected should be required to possess an accurate acquaintance with the history of the particular word, and of the opinions which in different stages of its progress it served to express. To be qualified to define the name, we must know all that has ever been known of the properties of the class of objects which are, or originally were, denoted by it. For if we give it a meaning according to which any proposition will be false which has ever been generally held to be true, it is incumbent on us to be sure that we know and have considered all which those who believed the proposition understood by it. End of section 67. Section 68 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 4, Chapter 5, on the natural history of the variations in the meaning of terms. Part 1. It is not only in the mode which has now been pointed out, namely, by gradual inattention to a portion of the ideas conveyed, that words in common use are liable to shift their connotation. The truth is that the connotation of such words is perpetually varying, as might be expected from the manner in which words in common use acquire their connotation. A technical term invented for purposes of art or science has, from the first, the connotation given to it by its inventor, but a name which is in everyone's mouth before anyone thinks of defining it derives its connotation only from the circumstances which are habitually brought to mind when it is pronounced. Among these circumstances, the properties common to the things denoted by the name have naturally a principal place, and would have the sole place, if language were regulated by convention rather than by custom and accident. But besides these common properties, which, if they exist, are certainly present whenever the name is employed, any other circumstance may casually be found along with it, so frequently as to become associated with it in the same manner and as strongly as the common properties themselves. In proportion as this association forms itself, people give up using the name in cases in which those casual circumstances do not exist. They prefer using some other name, or the same name with some adjunct, rather than employ an expression which will call up an idea they do not want to excite. The circumstance originally casual thus becomes regularly a part of the connotation of the word. It is this continual incorporation of circumstances, originally accidental, into the permanent signification of words, which is the cause that there are so few exact synonyms. It is this also which renders the dictionary meaning of a word, by universal remark, so imperfect an exponent of its real meaning. The dictionary meaning is marked out in a broad, blunt way, and probably includes all that was originally necessary for the correct employment of the term. But in process of time, so many collateral associations adhere to words that whoever should attempt to use them with no other guide than the dictionary would confound 1,000 nice distinctions and subtle shades of meaning which dictionaries take no account of, as we notice in the use of a language in conversation or writing by a foreigner not thoroughly master of it. The history of a word, by showing the causes which determine its use, is in these cases a better guide to its employment than any definition, for definitions can only show its meaning at the particular time, or at most the series of its successive meanings, but its history may show the law by which the succession was produced. The word gentleman, for instance, to the correct employment of which a dictionary would be no guide, originally meant simply a man born in a certain rank. From this it came by degrees to connote all such qualities or adventitious circumstances as were usually found to belong to persons of that rank. This consideration at once explains why, in one of its vulgar acceptations, it means anyone who lives without labour, in another without manual labour, and in its more elevated signification it has in every age signified the conduct, character, habits, and outward appearance in whomsoever found, which according to the ideas of that age belonged or were expected to belong to persons born and educated in a high social position. It continually happens that of the two words whose dictionary meanings are either the same or very slightly different, one will be the proper word to use in one set of circumstances, another in another, without its being possible to show how the custom of so employing them originally grew up. The accident that one of the words was used and not the other on a particular occasion or in a particular social circle will be sufficient to produce so strong an association between the word and some speciality of circumstances that mankind abandon the use of it in any other case, and the speciality becomes part of its signification. The tide of custom first drifts the word onto the shore of a particular meaning, then retires and leaves it there. An instance in point is the remarkable change which, in the English language at least, has taken place in the signification of the word loyalty. That word originally meant in English, as it still means in the language from whence it came, fair, open dealing, and fidelity to engagements. In that sense, the quality it expressed was part of the ideal chivalrous or knightly character. By what process in England the term became restricted to the single case of fidelity to the throne, I am not sufficiently versed in the history of courtly language to be able to pronounce. The interval between a loyal chevalier and a loyal subject is certainly great. I can only suppose that the word was, at some period, the favourite term at court to express fidelity to the oath of allegiance, until at length those who wished to speak of any other, and as it was probably deemed inferior sort of fidelity, either did not venture to use so dignified a term, or found it convenient to employ some other in order to avoid being misunderstood. Part 2. Cases are not unfrequent in which a circumstance, at first casually incorporated into the connotation of a word which originally had no reference to it, in time wholly supersedes the original meaning, and becomes not merely a part of the connotation, but the whole of it. This is exemplified in the word pagan, paganus, which originally, as its etymology imports, was equivalent to villager, the inhabitant of a pagus, or village. At a particular era in the extension of Christianity over the Roman Empire, the adherents of the old religion and the villagers or country people were nearly the same body of individuals, the inhabitants of the towns having been earliest converted, as in our own day, and at all times the greater activity of social intercourse renders them the earliest recipients of new opinions and modes, while old habits and prejudices linger longest among the country people. not to mention that the towns were more immediately under the direct influence of the government, which at that time had embraced Christianity. From this casual coincidence, the word paganus carried with it and began more and more steadily to suggest the idea of a worshipper of the ancient divinities, until at length it suggested that idea so forcibly that people who did not desire to suggest the idea avoided using the word. But when paganus had come to connote heathenism, the very unimportant circumstance with reference to that fact of the place of residence was soon disregarded in the employment of the word. As there was seldom any occasion for making separate assertions respecting heathens who lived in the country, there was no need for a separate word to denote them. And pagan came not only to mean heathen, but to mean that exclusively. A case still more familiar to most readers is that of the word villain or villain. This term, as everybody knows, had in the Middle Ages a connotation as strictly defined as a word could have, being the proper legal designation for those persons who were the subjects of the less onerous forms of feudal bondage. The scorn of the semi-barbarous military aristocracy for these, their abject dependents, rendered the act of likening any person to this class of people a mark of the greatest contumely. The same scorn led them to ascribe to the same people all manner of hateful qualities, which doubtless also, in the degrading situation in which they were held, were often not unjustly imputed to them. These circumstances combined to attach the term villain ideas of crime and guilt in so forcible a manner that the application of the epithet seems even to those to whom it legally belonged became an affront, and was abstained from whenever no affront was intended. From that time guilt was part of the connotation, and soon became the whole of it, since mankind were not prompted by any urgent motive to continue making a distinction in their language between bad men of servile station and bad men of any other rank in life. These and similar instances in which the original signification of a term is totally lost, another and an entirely distinct meaning being first engrafted upon the former and finally substituted for it, afford examples of the double movement which is always taking place in language, two counter-movements, one of generalization, by which words are perpetually losing portions of their connotation and becoming of less meaning and more general acceptance. The other of specialization, by which other or even these same words are continually taking on fresh connotation, acquiring additional meaning by being restricted in their employment to a part only of the occasions on which they might properly be used before. This double movement is of sufficient importance in the natural history of language, to which natural history the artificial modifications ought always to have some degree of reference, to justify our dwelling a little longer on the nature of the twofold phenomenon and the causes to which it owes its existence. Part 3. To begin with the movement of generalization. It might seem unnecessary to dwell on the changes in the meaning of names which take place merely from their being used ignorantly by persons who, not having properly mastered the received connotation of a word, apply it in a looser and wider sense than belongs to it. This, however, is a real source of alterations in the language. For when a word, from being often employed in cases where one of the qualities which it connotes does not exist, ceases to suggest that quality with certainty, then even those who are under no mistake as to the proper meaning of the word prefer expressing that meaning in some other way, and leave the original word to its fate. The word squire as standing for an owner of a landed estate, parson as denoting not the rector of the parish but clergyman in general, artist to denote only a painter or sculptor, are cases in point. Such cases give a clear insight into the process of the degeneration of languages in periods of history when literary culture was suspended, and we are now in danger of experiencing a similar evil through the superficial extension of the same culture. So many persons without anything deserving the name of education have become writers by profession, that written language may almost be said to be principally wielded by persons ignorant of the proper use of the instrument, and who are spoiling it more and more for those who understand it. Vulgarisms which creep in nobody knows how are daily depriving the English language of valuable modes of expressing thought. To take a present instance, the verb transpire formerly conveyed very expressively its correct meaning, that is, to become known through unnoticed channels, to exhale, as it were, into publicity through invisible pores, like a vapour or gas disengaging itself. But of late a practice has commenced of employing this word for the sake of finery as a mere synonym of to happen. Quote, the events which have transpired in the Crimea, end quote, meaning the incidents of the war. This vile specimen of bad English is already seen in the dispatches of noblemen and viceroys, and the time is apparently not far distant when nobody will understand the word if used in its proper sense. In other cases, it is not the love of finery, but simple want of education, which makes writers employ words in senses unknown to genuine English. The use of aggravating for provoking, in my boyhood a vulgarism of the nursery, has crept into almost all newspapers and into many books. And when the word is used in its proper sense, as when writers on criminal law speak of aggravating and extenuating circumstances, their meaning, it is probable, is already misunderstood. It is a great error to think that these corruptions of language do no harm. Those who are struggling with the difficulty, and who know by experience how great it already is, of expressing oneself clearly with precision, find their resources continually narrowed by illiterate writers who seize and twist from its purpose some form of speech which once served to convey briefly and compactly an unambiguous meaning. It would hardly be believed how often a writer is compelled to a circumlocution by the single vulgarism introduced during the last few years of using the word alone as an adverb, only not being fine enough for the rhetoric of ambitious ignorance. A man will say, quote, to which I am not alone bound by honour but also by law, end quote, unaware that what he has unintentionally said is that he is not alone bound, some other person being bound with him. Formerly, if anyone said, I am not alone responsible for this, he was understood to mean, what alone his words mean in correct English, that he is not the sole person responsible. But if he now used such an expression, the reader would be confused between that and the two other meanings, that he is not only responsible, but something more, or that he is responsible not only for this, but something besides. The time is coming when Tennyson's Enon could not say, I will not die alone, lest she should be supposed to mean that she would not only die, but do something else. The blunder of writing predicate for predict has become so widely diffused that it bids fair to render one of the most useful terms in the scientific vocabulary of logic unintelligible. The mathematical and logical term, to eliminate, is undergoing a similar destruction. All who are acquainted either with the proper use of the word or with its etymology know that to eliminate a thing is to thrust it out. But those who know nothing about it, except that it is a fine-looking phrase, use it in a sense precisely the reverse, to denote not turning anything out, but bringing it in. They talk of eliminating some truth or other useful result from a mass of details. Footnote: though no such evil consequences as take place in these instances are likely to arise from the modern freak of writing sanatory instead of sanitary, it deserves notice as a charming specimen of pedantry engrafted upon ignorance. Those who thus undertake to correct the spelling of the classical English writers are not aware that the meaning of sanatory, if there were such a word in the language, would have reference not to the preservation of health, but to the cure of disease. End footnote. A similar permanent deterioration in the language is in danger of being produced by the blunders of translators. The writers of telegrams and the foreign correspondents of newspapers have gone on so long translating demander by to demand, without a suspicion that it means only to ask, that, the context generally showing that nothing else is meant, English readers are gradually associating the English word demand with simple asking, thus leaving the language without a term to express a demand in its proper sense. In like manner, transaction, the French word for a compromise, is translated into the English word transaction, while curiously enough the inverse change is taking place in France, where the word compromis has lately begun to be used for expressing the same idea. If this continues, the two countries will have exchanged phrases. Independently, however, of the generalization of names through their ignorant misuse, there is a tendency in the same direction consistently with a perfect knowledge of their meaning, arising from the fact that the number of things known to us, and of which we feel a desire to speak, multiply faster than the names for them. Except on subjects for which there has been constructed a scientific terminology, with which unscientific persons do not meddle, great difficulty is generally found in bringing a new name into use, and independently of that difficulty, it is natural to prefer giving to a new object a name which at least expresses its resemblance to something already known, since by predicating of it a name entirely new, we at first convey no information. In this manner, the name of a species often becomes the name of a genus, as salt, for example, or oil, the former of which words originally denoted only the muriate of soda, the latter, as its etymology indicates, only olive oil, but which now denotes large and diversified classes of substances resembling these in some of their qualities, and connote only those common qualities, instead of the whole of the distinctive properties of olive oil and sea salt. The words glass and soap are used by modern chemists in a similar manner to denote genera of which the substances vulgarly so called are single species, and it often happens, as in those instances, that the term keeps its special signification in addition to its more general one, and becomes ambiguous, that is, two names instead of one. These changes, by which words in ordinary use become more and more generalized and less expressive, take place in a still greater degree with the words which express the complicated phenomena of mind and society. Historians, travellers, and in general those who speak or write concerning moral and social phenomena with which they are not familiarly acquainted, are the great agents in this modification of language. The vocabulary of all except unusually instructed as well as thinking persons is, on such subjects, eminently scanty. They have a certain small set of words to which they are accustomed, and which they employ to express phenomena the most heterogeneous, because they have never sufficiently analyzed the facts to which these words correspond in their own country to have attached perfectly definite ideas to the words. The first English conquerors of Bengal, for example, carried with them the phrase landed proprietor into a country where the rights of individuals over the soil were extremely different in degree and even in nature from those recognized in England. Applying the term with all its English associations in such a state of things, to one who had only a limited right, they gave an absolute right. From another, because he had not an absolute right, they took away all right, drove whole classes of people to ruin and despair, filled the country with banditti, created a feeling that nothing was secure, and produced, with the best intentions, a disorganization of society which had not been produced in that country by the most ruthless of its barbarian invaders. Yet the usage of persons capable of so gross a misapprehension determines the meaning of language, and the words they misuse grow in generality until the instructed are obliged to acquiesce, and to employ those words, first freeing them from vagueness by giving them a definite connotation, as generic terms, subdividing the genera into species. Part 4. While the more rapid growth of ideas than of names thus creates a perpetual necessity for making the same names serve, even if imperfectly, on a greater number of occasions, a counter-operation is going on by which names become, on the contrary, restricted to fewer occasions, by taking on, as it were, additional connotation from circumstances not originally included in the meaning, but which have become connected with it in the mind by some accidental cause. We have seen above, in the words pagan and villain, remarkable examples of the specialization of the meaning of words from casual associations, as well as of the generalization of it in a new direction, which often follows. Similar specializations are of frequent occurrence in the history even of scientific nomenclature. Quote, "It is by no means uncommon," says Dr. Paris in his Pharmacologia, "to find a word which is used to express general characters subsequently become the name of a specific substance in which such characters are predominant, and we shall find that some important anomalies in nomenclature may be thus explained." Footnote. Historical Introduction, Volume 1, pages 66 through 68. End footnote. The term arsenikon, from which the word arsenic is derived, was an ancient epithet applied to those natural substances which possessed strong and acrimonious properties. And as the poisonous quality of arsenic was found to be remarkably powerful, the term was especially applied to orpiment, the form in which this metal most usually occurred. So the term verbena, quasi herbina, originally denoted all those herbs that were held sacred on account of their being employed in the rites of sacrifice, as we learn from the poets. But as one herb was usually adopted upon these occasions, the word verbena came to denote that particular herb only, and it is transmitted to us this day under the same title, that is, verbena or vervain, and indeed, until lately, it enjoyed the medical reputation which its sacred origin conferred upon it, for it was worn suspended around the neck as an amulet. Vitriol, in the original application of the word, denoted any crystalline body with a certain degree of transparency, vitrum. It is hardly necessary to observe that the term is now appropriated to a particular species. In the same manner, bark, which is a general term, is applied to express one genus, and by way of eminence it has the article the prefixed, as in the bark. The same observation will apply to the word opium, which, in its primitive sense, signifies any juice, opus, succus, while it now only denotes one species, that is, that of the poppy. So again, elaterium was used by Hippocrates to signify various internal applications, especially purgatives, of a violent and drastic nature. From the word elavno, agito, movio, stimulo, but by succeeding authors it was exclusively applied to denote the active matter which subsides from the juice of the wild cucumber. The word fecula, again, originally meant to imply any substance which was derived by spontaneous subsidence from a liquid, from feux, the grounds or settlement of any liquor. Afterward it was applied to starch, which is deposited in this manner by agitating the flour of wheat in water. And lastly, it has been applied to a peculiar vegetable principle which, like starch, is insoluble in cold but completely soluble in boiling water, with which it forms a gelatinous solution. This indefinite meaning of the word fecula has created numerous mistakes in pharmaceutic chemistry. Elaterium, for instance, is said to be fecula, and in the original sense of the word it is properly so called, inasmuch as it is procured from a vegetable juice by spontaneous subsidence. But in the limited and modern acception of the term, it conveys an erroneous idea, for instead of the active principle of the juice residing in fecula, it is a peculiar proximate principle, sui generis, to which I have ventured to bestow the name of elatin. For the same reason, much doubt and obscurity involve the meaning of the word extract, because it is applied generally to any substance obtained by the evaporation of a vegetable solution, and specifically to a peculiar proximate principle possessed of certain characters by which it is distinguished from every other elementary body." End quote. A generic term is always liable to become thus limited to a single species, or even individual, if people have occasion to think and speak of that individual or species much oftener than of anything else which is contained in the genus. Thus, by cattle, a stage coachman will understand horses, beasts in the language of agriculturists stands for oxen, and birds with some sportsmen for partridges only. The law of language which operates in these trivial instances is the very same in conformity to which the terms theos, deus, and God were adopted from polytheism by Christianity to express the single object of its own adoration. Almost all the terminology of the Christian Church is made up of words originally used in a much more general acceptation. Ecclesia, assembly. Bishop, episcopus, overseer. Priest, presbyter, elder. Deacon, diaconus, administrator. Sacrament, a vow of allegiance. Evangelium, good tidings. And some words as minister are still used both in the general and in the limited sense. It would be interesting to trace the progress by which author came, in its most familiar sense, to signify a writer, and poetis, or maker, a poet. Of the incorporation into the meaning of a term of circumstances accidentally connected with it at some particular period, as in the case of pagan, instances might easily be multiplied. Physician, physikos, or naturalist, became in England synonymous with a healer of diseases, because until a comparatively late period, medical practitioners were the only naturalists. Cleric, or clericus, a scholar, came to signify an ecclesiastic, because the clergy were for many centuries the only scholars. Of all ideas, however, the most liable to cling by association to anything with which they have ever been connected by proximity are those of our pleasures and pains, of the things which we habitually contemplate as sources of our pleasures or pains. The additional connotation, therefore, which a word soonest and most readily takes on, is that of agreeableness or painfulness in their various kinds and degrees, of being a good or bad thing, desirable or to be avoided, an object of hatred, of dread, contempt, admiration, hope, or love. Accordingly, there is hardly a single name expressive of any moral or social fact calculated to call forth strong affections, either of a favourable or of a hostile nature, which does not carry with it decidedly and irresistibly a connotation of those strong affections, or at the least of approbation or censure, insomuch that to employ those names in conjunction with others by which the contrary sentiments were expressed would produce the effect of a paradox, or even a contradiction in terms. The baneful influence of a connotation thus acquired on the prevailing habits of thought, especially in morals and politics, has been well pointed out on many occasions by Bentham. It gives rise to the fallacy of question-begging names. The very property which we are inquiring whether a thing possesses or not has become so associated with the name of the thing as to be part of its meaning, insomuch that by merely uttering the name we assume the point which was to be made out, one of the most frequent sources of apparently self-evident propositions. Without any further multiplication of examples to illustrate the changes which usage is continually making in the signification of terms, I shall add as a practical rule that the logician, not being able to prevent such transformations, should submit to them with a good grace when they are irrevocably effected, and if a definition is necessary, define the word according to its new meaning, retaining the former as a second signification if it is needed, and if there is any chance of being able to preserve it either in the language of philosophy or in common use. Logicians cannot make the meaning of any but scientific terms. That of all other words is made by the collective human race. But logicians can ascertain clearly what it is which, working obscurely, has guided the general mind to a particular employment of a name, and when they have found this, they can clothe it in such distinct and permanent terms that mankind shall see the meaning which before they only felt, and shall not suffer it to be afterward forgotten or misapprehended. End of section 68. Section 69 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 4, Chapter 6. The Principles of a Philosophical Language Further Considered. Part 1. We have, thus far, considered only one of the requisites of a language adapted for the investigation of truth, that its terms shall each of them convey a determinate and unmistakable meaning. There are, however, as we have already remarked, other requisites, some of them important only in the second degree, but one which is fundamental and barely yields in point of importance, if it yields at all, to the quality which we have already discussed at so much length. That the language may be fitted for its purposes, not only should every word perfectly express its meaning, but there should be no important meaning without its word. Whatever we have occasion to think of often, and for scientific purposes, ought to have a name appropriated to it. This requisite of philosophical language may be considered under three different heads, that number of separate conditions being involved in it. Part 2. First, there ought to be all such names as are needful for making such a record of individual observations that the words of the record shall exactly show what fact it is which has been observed. In other words, there should be an accurate descriptive terminology. The only things which we can observe directly being our own sensations or other feelings, A complete descriptive language would be one in which there should be a name for every variety of elementary sensation or feeling. Combinations of sensations or feelings may always be described if we have a name for each of the elementary feelings which compose them, but brevity of description and clearness, which often depends very much on brevity, are greatly promoted by giving distinctive names not to the elements alone, but also to all combinations which are of frequent recurrence. On this occasion, I cannot do better than quote from Dr. Whewell some of the excellent remarks which he has made on this important branch of our subject. Footnote: History of Scientific Ideas, 2, pages 110 and 111. End footnote. Quote, "The meaning of descriptive technical terms can be fixed in the first instance only by convention, and can be made intelligible only by presenting to the senses that which the terms are to signify. The knowledge of a colour by its name can only be taught through the eye. No description can convey to a hearer what we mean by apple green or French grey. It might perhaps be supposed that, in the first example, the term apple, referring to so familiar an object, sufficiently suggests the colour intended, but it may easily be seen that this is not true, for apples are of many different hues of green, and it is only by a conventional selection that we can appropriate the term to one special shade. When this appropriation is once made, the term refers to the sensation and not to the parts of the term, for these enter into the compound merely as a help to the memory. Whether the suggestion be a natural connection, as in apple green, or a casual one, as in French grey, in order to derive due advantage from technical terms of the kind, they must be associated immediately with the perception to which they belong, and not connected with it through the vague usages of common language. The memory must retain the sensation, and the technical word must be understood as directly as the most familiar word and more distinctly. When we find such terms as tin white or pinchbeck brown, the metallic colour so denoted ought to start up in our memory without delay or search. This, which it is most important to recollect with respect to the simpler properties of bodies, as colour and form, is no less true with respect to more compound notions. In all cases the term is fixed to a peculiar meaning by convention, and the student, in order to use the word, must be completely familiar with the convention, so that he has no need to frame conjectures from the word itself. Such conjectures would always be insecure and often erroneous. Thus the term papilionaceous, applied to a flower, is employed to indicate not only a resemblance to a butterfly, but a resemblance arising from 5 petals of a certain peculiar shape and arrangement. And even if the resemblance were much stronger than it is in such cases, yet, if it were produced in a different way, as for example by 1 petal or 2 only, instead of a standard 2 wings and a keel, consisting of 2 parts more or less united into one, we should no longer be justified in speaking of it as a papilionaceous flower." End quote. When, however, the thing named is, as in this last case, a combination of simple sensations, it is not necessary, in order to learn the meaning of the word, that the student should refer back to the sensations themselves. It may be communicated to him through the medium of other words. The terms, in short, may be defined, but the names of elementary sensations or elementary feelings of any sort cannot be defined, nor is there any mode of making their signification known but by making the learner experience the sensation, or referring him, through some known mark, to his remembrance of having experienced it before. Hence it is only the impressions on the outward senses, or those inward feelings which are connected in a very obvious and uniform manner with outward objects, that are really susceptible of an exact descriptive language. The countless variety of sensations which arise, for instance, from disease, or from peculiar physiological states, it would be in vain to attempt to name. For as no one can judge whether the sensation I have is the same with his, the name cannot have, to us two, real community of meaning. The same may be said to a considerable extent of purely mental feelings, but in some of the sciences which are conversant with external objects, it is scarcely possible to surpass the perfection to which this quality of a philosophical language has been carried. Quote, "The formation of an exact and extensive descriptive language for botany has been executed with a degree of skill and felicity which, before it was attained, could hardly have been dreamed of as attainable." Footnote: History of Scientific Ideas, 2, pages 111 through 113. End footnote. Every part of a plant has been named, and the form of every part, even the most minute, has had a large assemblage of descriptive terms appropriated to it, by means of which the botanist can convey and receive knowledge of form and structure as exactly as if each minute part were presented to him vastly magnified. This acquisition was part of the Linnaean reform. Tournefort, says Decandolle, appears to have been the first who really perceived the utility of fixing the sense of terms in such a way as always to employ the same word in the same sense, and always to express the same idea by the same words. But it was Linnaeus who really created and fixed this botanical language, and this is his fairest claim to glory, for by this fixation of language he has shed clearness and precision over all parts of the science. It is not necessary here to give any detailed account of the terms of botany. The fundamental ones have been gradually introduced as the parts of the plants were more carefully and minutely examined. Thus the flower was necessarily distinguished into the calyx, the corolla, the stamens, and the pistils. The sections of the corolla were termed petals by Columna. Those of the calyx were called sepals by Necker. Sometimes terms of greater generality were devised, as perianth, to include the calyx and corolla, whether one or both of these were present. Pericarp, for the part enclosing the grain, of whatever kind it be, fruit, nut, pod, and so on. And it may easily be imagined that descriptive terms may, by definition and combination, become very numerous and distinct. Thus leaves may be called primatifid, pinnatipartite, pinnatisect, pinnatilobate, palmatifid, palmatiparite, and so on. And each of these words designates different combinations of the modes and extent of the divisions of the leaf with the divisions of its outline. In some cases, arbitrary numerical relations are introduced into the definitions. Thus, a leaf is called bilobate when it is divided into two parts by a notch. But if the notch go to the middle of its length, it is bifid. If it goes near the base of the leaf, it is bipartite. If to the base, it is bisect. Thus, too, a pod of a cruciferous plant is a siliqua, if it is 4 times as long as it is broad. But if it be shorter than this, it is a silicula. Such terms being established, the form of the very complex leaf or frond of a fern, Hymenphilum wilsoni, is exactly conveyed by the following phrase: fronds rigid pinnate, pinnae recurved subunilateral, pinnatifid the segments linear undivided, or bifid spinuloso serrate. Other characters as well as form are conveyed with the like precision. Colour, by means of a classified scale of colours. This was done with most precision by Werner, and his scale of colours is still the most usual standard of naturalists. Werner also introduced a more exact terminology with regard to other characters which are important in mineralogy, as luster, hardness. But Mohs improved upon this step by giving a numerical scale of hardness, in which talc is 1, gypsum 2, calcspar 3, and so on. Some properties, as specific gravity, by their definition, give at once a numerical measure, and others, as crystalline form, require a very considerable array of mathematical calculation and reasoning to point out their relations and gradations. End quote. Part 3. Thus far of descriptive terminology, or of the language requisite for placing on record our observation of individual instances. But when we proceed from this to induction, or rather to that comparison of observed instances which is the preparatory step toward it, we stand in need of an additional and a different sort of general names. Whenever, for purposes of induction, we find it necessary to introduce, in Dr. Whewell's phraseology, some new general conception, that is, whenever the comparison of a set of phenomena leads to the recognition in them of some common circumstance, which, our attention not having been directed to it on any former occasion, is to us a new phenomenon, it is of importance that this new conception, or this new result of abstraction, should have a name appropriated to it, especially if the circumstance it involves be one which leads to many consequences, or which is likely to be found also in other classes of phenomena. No doubt in most cases of the kind, the meaning might be conveyed by joining together several words already in use. But when a thing has to be often spoken of, there are more reasons than the saving of time and space for speaking of it in the most concise manner possible. What darkness would be spread over geometrical demonstrations if, wherever the word circle is used, the definition of a circle were inserted instead of it. In mathematics and its applications, where the nature of the processes demands that the attention should be strongly concentrated, but does not require that it should be widely diffused, the importance of concentration also in the expressions has always been duly felt, and a mathematician no sooner finds that he shall often have occasion to speak of the same two things together, than he at once creates a term to express them whenever combined, just as, in his algebraic operations, he substitutes for lower a raised to the power m plus lower b raised to the power n, together multiplied by lower p, all divided by lower q, or for lower a divided by b plus lower b divided by lower c plus lower c divided by lower d, and so on, the single letter upper P, upper Q, or upper S, not solely to shorten his symbolic expressions, but to simplify the purely intellectual part of his operations, by enabling the mind to give its exclusive attention to the relation between the quantity S and the other quantities which enter into the equation, without being distracted by thinking unnecessarily of the parts of which S itself is composed. But there is another reason, in addition to that of promoting perspicuity, for giving a brief and compact name to each of the more considerable results of abstraction which are obtained in the course of our intellectual phenomena. By naming them, we fix our attention upon them. We keep them more constantly before the mind. The names are remembered, and being remembered, suggest their definition, while if instead of specific and characteristic names, the meaning had been expressed by putting together a number of other names, that particular combination of words already in common use for other purposes would have had nothing to make itself remembered by. If we want to render a particular combination of ideas permanent in the mind, there is nothing which clinches it like a name specially devoted to express it. If mathematicians had been obliged to speak of, quote, that to which a quantity in increasing or diminishing is always approaching nearer, so that the difference between becomes less than any assignable quantity, but to which it never becomes exactly equal, end quote. Instead of expressing all this by the simple phrase, the limit of a quantity, we should probably have long remained without most of the important truths which have been discovered by means of the relation between quantities of various kinds and their limits. If instead of speaking of momentum, it had been necessary to say, quote, the product of the number of units of velocity in the velocity by the number of units of mass in the mass, end quote, many of the dynamical truths now apprehended by means of this complex idea would probably have escaped notice for want of recalling the idea itself with sufficient readiness and familiarity. And on subjects less remote from the topics of popular discussion, whoever wishes to draw attention to some new or unfamiliar distinction among things will find no way so sure as to invent or select suitable names for the express purpose of marking it. A volume devoted to explaining what the writer means by civilization does not raise so vivid a conception of it as the single expression that civilization is a different thing from cultivation. The compactness of that brief designation for the contrasted quality being an equivalent for a long discussion. So, if we would impress forcibly upon the understanding and memory the distinction between the two different conceptions of a representative government, we cannot more effectually do so than by saying that delegation is not representation. Hardly any original thoughts on mental or social subjects ever make their way among mankind or assume their proper importance in the minds even of their inventors until aptly selected words or phrases have, as it were, nailed them down and held them fast. Part 4. Of the three essential parts of a philosophical language, we have now mentioned two: a terminology suited for describing with precision the individual facts observed, and a name for every common property of any importance or interest which we detect by comparing these facts, including, as the concretes corresponding to those abstract terms, names for the classes which we artificially construct in virtue of those properties, or as many of them at least as we have frequent occasion to predicate anything of. But there is a sort of classes for the recognition of which no such elaborate process is necessary, because each of them is marked out from all others not by some one property, the detection of which may depend on a difficult act of abstraction, but by its properties generally. I mean the kinds of things, in the sense which in this treatise has been specially attached to that term. By a kind, it will be remembered, we mean one of those classes which are distinguished from all others, not by one or a few definite properties, but by an unknown multitude of them, the combination of properties on which the class is grounded being a mere index to an indefinite number of other distinctive attributes. The class horse is a kind, because the things which agree in possessing the characters by which we recognize a horse agree in a great number of other properties, as we know, and, it cannot be doubted, in many more than we know. Animal, again, is a kind, because no definition that could be given of the name animal could either exhaust the properties common to all animals, or supply premises from which the remainder of those properties could be inferred. but a combination of properties which does not give evidence of the existence of any other independent peculiarities does not constitute a kind. White horse, therefore, is not a kind, because horses which agree in whiteness do not agree in anything else except the qualities common to all horses, and whatever may be the causes or effects of that particular colour. On the principle that there should be a name for everything which we have frequent occasion to make assertions about, there ought evidently to be a name for every kind. For as it is the very meaning of a kind that the individuals composing it have an indefinite multitude of properties in common, it follows that, if not with our present knowledge, yet with that which we may hereafter acquire, the kind is a subject to which there will have to be applied many predicates. The third component element of a philosophical language, therefore, is that there shall be a name for every kind. In other words, there must not only be a terminology, but also a nomenclature. The words nomenclature and terminology are employed by most authors almost indiscriminately. Dr. Whewell being, as far as I am aware, the first writer who has regularly assigned to the two words different meanings. The distinction, however, which he has drawn between them being real and important, his example is likely to be followed, and, as is apt to be the case when such innovations in language are felicitously made, a vague sense of the distinction is found to have influenced the employment of the terms in common practice, before the expediency had been pointed out of discriminating them philosophically. Every one would say that the reform effected by Lavoisier and Guiton-Morveau in the language of chemistry consisted in the introduction of a new nomenclature, not of a new terminology. Linear, lanceolate, oval or oblong, serrated, dentate or crenate leaves are expressions forming part of the terminology of botany, while the names Viola odorata and Ilex europaeus belong to its nomenclature. A nomenclature may be defined the collection of the names of all the kinds with which any branch of knowledge is conversant, or more properly, of all the lowest kinds or infirme species, those which may be subdivided indeed, but not into kinds, and which generally accord with what in natural history are termed simply species. Science possesses two splendid examples of a systematic nomenclature, that of plants and animals, constructed by Linnaeus and his successors, and that of chemistry, which we owe to the illustrious group of chemists who flourished in France toward the close of the 18th century. In these two departments, not only has every known species or lowest kind a name assigned to it, but when new lowest kinds are discovered, names are at once given to them on a uniform principle. In other sciences, the nomenclature is not at present constructed on any system, either because the species to be named are not numerous enough to require one, as in geometry, for example, or because no one has yet suggested a suitable principle for such a system, as in mineralogy, in which the want of a scientifically constructed nomenclature is now the principal cause which retards the progress of the science. Part 5. A word which carries on its face that it belongs to a nomenclature seems at first sight to differ from other concrete general names in this, that its meaning does not reside in its connotation, in the attributes implied in it, but in its denotation, that is, in the particular group of things which it is appointed to designate, and cannot therefore be unfolded by means of a definition, but must be made known in another way. This opinion, however, appears to me erroneous. Words belonging to a nomenclature differ, I conceive, from other words mainly in this, that besides the ordinary connotation, they have a peculiar one of their own. Besides connoting certain attributes, they also connote that those attributes are distinctive of a kind. The term peroxide of iron, for example, belonging by its form to the systematic nomenclature of chemistry, bears on its face that it is the name of a peculiar kind of substance. It moreover connotes, like the name of any other class, some portion of the properties common to the class, in this instance the property of being a compound of iron and the largest dose of oxygen with which iron will combine. These two things, the fact of being such a compound and the fact of being a kind, constitute the connotation of the name peroxide of iron. When we say of the substance before us that it is the peroxide of iron, we thereby assert first that it is a compound of iron and a maximum of oxygen, and next that the substance so composed is a peculiar kind of substance. Now, this second part of the connotation of any word belonging to a nomenclature is as essential a portion of its meaning as the first part, while the definition only declares the first, and hence the appearance that the signification of such terms cannot be conveyed by a definition, which appearance, however, is fallacious. The name viola odorata denotes a kind, of which a certain number of characters, sufficient to distinguish it, are enunciated in botanical works. This enumeration of characters is surely, as in other cases, a definition of the name. No, say some, it is not a definition, for the name viola odorata does not mean those characters. It means that particular group of plants, and the characters are selected from among a much greater number, merely as marks by which to recognize the group. But to this I reply that the name does not mean that group, for it would be applied to that group no longer than while the group is believed to be an infima species. If it were to be discovered that several distinct kinds have been confounded under this one name, no one would any longer apply the name viola odorata to the whole of the group, but would apply it, if retained at all, to one only of the kinds retained therein. What is imperative, therefore, is not that the name shall denote one particular collection of objects, but that it shall denote a kind, and a lowest kind. The form of the name declares that, happen what will, it is to denote an infima species, and that, therefore, the properties which it connotes, and which are expressed in the definition, are to be connoted by it no longer than while we continue to believe that those properties, when found together, indicate a kind, and that the whole of them are found in no more than one kind. With the addition of this peculiar connotation implied in the form of every word which belongs to a systematic nomenclature, the set of characters which is employed to discriminate each kind from all other kinds, and which is a real definition, constitutes as completely as in any other case the whole meaning of the term. It is no objection to say that, as is often the case in natural history, the set of characters may be changed and another substituted as being better suited for the purpose of distinction, while the word, still continuing to denote the same group or things, is not considered to have changed its meaning. For this is no more than may happen in the case of any other general name. We may, in reforming its connotation, leave its denotation untouched, and it is generally desirable to do so. The connotation, however, is not the less for this the real meaning, for we at once apply the name wherever the characters set down in the definition are found, and that which exclusively guides us in applying the term must constitute its signification. If we find contrary to our previous belief that the characters are not peculiar to one species, we cease to use the term coextensively with the characters. But then it is because the other portion of the connotation fails, the condition that the class must be a kind. The connotation, therefore, is still the meaning. The set of descriptive characters is a true definition, and the meaning is unfolded, not indeed, as in other cases, by the definition alone, but by the definition and the form of the word taken together. Part 6. We have now analyzed what is implied in the two principal requisites of a philosophical language. First, precision or definiteness, and secondly, completeness. Any further remarks on the mode of constructing a nomenclature must be deferred until we treat of classification, the mode of naming the kinds of things being necessarily subordinate to the mode of arranging those kinds into larger classes. With respect to the minor requisites of terminology, some of them are well stated and illustrated in the Aphorisms Concerning the Language of Science, included in Dr. Whewell's Philosophy of the Inductive Sciences. These, as being of secondary importance in the peculiar point of view of logic, I shall not further refer to, but shall confine my observations to one or more quality, which, next to the two already treated of, appears to be the most valuable which the language of science can possess. Of this quality, a general notion may be conveyed by the following aphorism. Whenever the nature of the subject permits our reasoning processes to be, without danger, carried on mechanically, the language should be constructed on as mechanical principles as possible, while in the contrary case it should be so constructed that there shall be the greatest possible obstacles to a merely mechanical use of it. I am aware that this maxim requires much explanation, which I shall at once proceed to give. At first, as to what is meant by using a language mechanically. The complete or extreme case of the mechanical use of language is when it is used without any consciousness of a meaning, and with only the consciousness of using certain visible or audible marks in conformity to technical rules previously laid down. This extreme case is nowhere realized except in the figures of arithmetic, and still more the symbols of algebra, a language unique in its kind and approaching as nearly to perfection for the purposes to which it is destined as can perhaps be said of any creation of the human mind. Its perfection consists in the completeness of its adaptation to a purely mechanical use. The symbols are mere counters, without even the semblance of a meaning apart from the convention which is renewed each time they are employed, and which is altered at each renewal, the same symbol A or X being used on different occasions to represent things which, except that, like all things, they are susceptible of being numbered, have no property in common. There is nothing, therefore, to distract the mind from the set of mechanical operations which are to be performed upon the symbols, such as squaring both sides of the equation, multiplying or dividing them by the same or by equivalent symbols, and so forth. Each of these operations, it is true, corresponds to a syllogism, represents one step of a ratiocination relating not to the symbols, but to the things signified by them. But as it has been found practicable to frame a technical form by conforming to which we can make sure of finding the conclusion of the ratiocination, our end can be completely attained without our ever thinking of anything but the symbols. Being thus intended to work merely as mechanism, they have the qualities which mechanism ought to have. They are of the least possible bulk, so that they take up scarcely any room and waste no time in their manipulation. They are compact and fit so closely together that the eye can take in the whole at once of almost every operation which they are employed to perform. These admirable properties of the symbolic language of mathematics have made so strong an impression on the minds of many thinkers as to have led them to consider the symbolic language in question as the ideal type of philosophical language generally. To think that names in general, or, as they are fond of calling them, signs, are fitted for the purposes of thought in proportion as they can be made to approximate to the compactness, the entire unmeaningness, and the capability of being used as counters without a thought of what they represent, which are characteristics of the A and B, the X and Y of algebra. This notion has led to sanguine views of the acceleration of the progress of science by means which, I conceive, cannot possibly conduce to that end, and forms part of that exaggerated estimate of the influence of signs, which has contributed in no small degree to prevent the real laws of our intellectual operations from being rightly understood. In the first place, a set of signs by which we reason without consciousness of their meaning can be serviceable at most only in our deductive operations. In our direct inductions we cannot for a moment dispense with a distinct mental image of the phenomena, since the whole operation turns on a perception of the particulars in which those phenomena agree and differ. But further, this reasoning by counters is only suitable to a very limited portion even of our deductive processes. In our reasonings respecting numbers, the only general principles which we ever have occasion to introduce are these: things which are equal to the same thing are equal to one another, and the sums of differences of equal things are equal, with their various corollaries. Not only can no hesitation ever arise respecting the applicability of these principles, since they are true of all magnitudes whatever, but every possible application of which they are susceptible may be reduced to a technical rule, and such, in fact, the rules of the calculus are. But if the symbols represent any other things than mere numbers, let us say even straight or curved lines, we have then to apply theorems of geometry, not true of all lines without exception, and to select those which are true of the lines we are reasoning about. And how can we do this unless we keep completely in mind what particular lines these are? Since additional geometrical truths may be introduced into the ratiocination in any stage of its progress, we cannot suffer ourselves, during even the smallest part of it, to use the names mechanically, as we use algebraical symbols, without an image annexed to them. It is only after ascertaining that the solution of a question concerning lines can be made to depend on a previous question concerning numbers, or in other words, after the question has been, to speak technically, reduced to an equation, that the unmeaning signs become available, and that the nature of the facts themselves to which the investigation relates can be dismissed from the mind. Up to the establishment of the equation, the language in which mathematicians carry on their reasoning does not differ in character from that employed by close reasoners on any other kind of subject. I do not deny that every correct ratiocination, when thrown into the syllogistic shape, is conclusive from the mere form of the expression, provided none of the terms used be ambiguous. And this is one of the circumstances which have led some writers to think that if all names were so judiciously constructed and so carefully defined as not to admit of any ambiguity, the improvement thus made in language would not only give to the conclusions of every deductive science the same certainty with those of mathematics, but would reduce all reasonings to the application of a technical form, and enable their conclusiveness to be rationally assented to after a merely mechanical process, as is undoubtedly the case in algebra. But if we expect geometry, the conclusions of which are already as certain and exact as they can be made, there is no science but that of number, in which the practical validity of a reasoning can be apparent to any person who has looked only at the reasoning itself. Whoever has assented to what was said in the last book concerning the case of the composition of causes, and the still stronger case of the entire supersession of one set of laws by another, is aware that geometry and algebra are the only sciences of which the propositions are categorically true. The general propositions of all other sciences are true only hypothetically, supposing that no counteracting cause happens to interfere. A conclusion, therefore, however correctly deduced in point of form from admitted laws of nature, will have no other than a hypothetical certainty. At every step we must assure ourselves that no other law of nature has superseded or intermingled its operation with those which are the premises of the reasoning. And how can this be done by merely looking at the words? We must not only be constantly thinking of the phenomena themselves, but we must be constantly studying them, making ourselves acquainted with the peculiarities of every case to which we attempt to apply our general principles. The algebraic notation, considered as a philosophical language, is perfect in its adaptation to the subjects for which it is commonly employed, namely, those of which the investigations have already been reduced to the ascertainment of a relation between numbers. But admirable as it is for its own purpose, the properties by which it is rendered such are so far from constituting it the ideal model of philosophical language in general, that the more nearly the language of any other branch of science approaches to it, the less fit that language is for its own proper functions. On all other subjects, instead of contrivances to prevent our attention from being distracted by thinking of the meaning of signs, we ought to wish for contrivances to make it impossible that we should ever lose sight of that meaning, even for an instant. With this view, as much meaning as possible should be thrown into the formation of the word itself, the aids of derivation and analogy being made available to keep alive a consciousness of all that is signified by it. In this respect, those languages have an immense advantage which form their compounds and derivatives from native roots, like the German, and not from those of a foreign or dead language, as is so much the case with English, French, and Italian. And the best are those which form them according to fixed analogies, corresponding to the relations between the ideas to be expressed. All languages do this more or less, but especially among modern European languages, the German, while even that is inferior to the Greek, in which the relation between the meaning of a derivative word and that of its primitive is in general clearly marked by its mode of formation, except in the case of words compounded with prepositions, which are often, in both those languages, extremely anomalous. But all that can be done by the mode of constructing words to prevent them from degenerating to sounds passing through the mind without any distinct apprehension of what they signify is far too little for the necessity of the case. Words, however well constructed originally, are always tending, like coins, to have their inscription worn off by passing from hand to hand, and the only possible mode of reviving it is to be ever stamping it afresh, by living in the habitual contemplation of the phenomena themselves, and not resting in our familiarity with the words that express them. If anyone, having possessed himself of the laws of phenomena as recorded in words, whether delivered to him originally by others, or even found out by himself, is content from thenceforth to live among these formulae, to think exclusively of them, and of applying them to cases as they arise, without keeping up his acquaintance with the realities from which these laws were collected, not only will he continually fail in his practical efforts, because he will apply his formulae without duly considering whether, in this case and in that, Other laws of nature do not modify or supersede them, but the formulae themselves will progressively lose their meaning to him, and he will cease at last even to be capable of recognizing with certainty whether a case falls within the contemplation of his formula or not. It is, in short, as necessary, on all subjects not mathematical, that the things on which we reason should be conceived by us in the concrete, and, clothed in circumstances, as it is in algebra that we should keep all individualizing peculiarities sedulously out of view. With this remark, we close our observations on the philosophy of language. End of section 69. Section 70 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 4, Chapter 7, of Classification as Subsidiary to Induction. Part 1. There is, as has been frequently remarked in this work, a classification of things which is inseparable from the fact of giving them general names. Every name which connotes an attribute divides, by that very fact, all things whatever into two classes, those which have the attribute and those which have it not, those of which the name can be predicated and those of which it cannot. And the division thus made is not merely a division of such things as actually exist or are known to exist, but of all such as may hereafter be discovered, and even of all which can be imagined. On this kind of classification we have nothing to add to what has previously been said. The classification which requires to be discussed as a separate act of the mind is altogether different. In the one, the arrangement of objects in groups and distribution of them into compartments is a mere incidental effect consequent on the use of names given for another purpose, namely, that of simply expressing some of their qualities. In the other, the arrangement and distribution are the main object, and the naming is secondary to, and purposely conforms itself to, instead of governing, that more important operation. Classification thus regarded is a contrivance for the best possible ordering of the ideas of objects in our minds, for causing the ideas to accompany or succeed one another in such a way as shall give us the greatest command over our knowledge already acquired and lead most directly to the acquisition of more. The general problem of classification, in reference to these purposes, may be stated as follows: to provide that things shall be thought of in such groups, and those groups in such an order, as will best conduce to the remembrance and to the ascertainment of their laws. Classification thus considered differs from classification in the wider sense, in having reference to real objects exclusively, and not to all that are imaginable, its object being the due coordination in our minds of those things only, with the properties of which we have actually occasion to make ourselves acquainted. But on the other hand, it embraces all really existing objects. We cannot constitute any one class properly, except in reference to a general division of the whole of nature. We cannot determine the group in which any one object can most conveniently be placed, without taking into consideration all the varieties of existing objects, all at least which have any degree of affinity with it. No one family of plants or animals could have been rationally constituted, except as part of a systematic arrangement of all plants or animals. Nor could such a general arrangement have been properly made, without first determining the exact place of plants and animals in a general division of nature. Part 2. There is no property of objects which may not be taken, if we please, as the foundation for a classification or mental grouping of those objects, and in our first attempts we are likely to select for that purpose properties which are simple, easily conceived, and perceptible on a first view without any previous process of thought. Thus, Tournefort's arrangement of plants was founded on the shape and divisions of the corolla, and that which is commonly called the Linnaean, though Linnaeus also suggested another and more scientific arrangement, was grounded chiefly on the number of the stamens and pistils. But these classifications, which are at first recommended by the facility they afford of ascertaining to what class any individual belongs, are seldom much adapted to the ends of that classification which is the subject of our present remarks. The Linnaean arrangement answers the purpose of making us think together of all those kinds of plants which possess the same number of stamens and pistils. But to think of them in that manner is of little use, since we seldom have anything to affirm in common of the plants which have a given number of stamens and pistils. If plants of the class Pentandria, order Monogynia, agree in any other properties, the habit of thinking and speaking of the plants under a common designation would conduce to our remembering those common properties so far as they were ascertained, and would dispose us to be on the lookout for such of them as were not yet known. But since this is not the case, the only purpose of thought which the Linnaean classification serves is that of causing us to remember, better than we should otherwise have done, the exact number of stamens and pistils of every species of plants. Now, as this property is of little importance or interest, the remembering it with any particular accuracy is of no moment, and inasmuch as, by habitually thinking of plants in those groups, we are prevented from habitually thinking of them in groups which have a greater number of properties in common, the effect of such a classification, when systematically adhered to, upon our habits of thought, must be regarded as mischievous. The ends of scientific classification are best answered when the objects are formed into groups respecting which a greater number of general propositions can be made, and those propositions more important that could be made respecting any other groups into which the same things could be distributed. The properties, therefore, according to which objects are classified should, if possible, be those which are causes of many other properties, or at any rate which are sure marks of them. Causes are preferable both as being the surest and most direct of marks, and as being themselves the properties on which it is of most use that our attention should be strongly fixed. But the property which is the cause of the chief peculiarities of a class is, unfortunately, seldom fitted to serve also as the diagnostic of the class. Instead of the cause, we must generally select some of its more prominent effects, which may serve as marks of the other effects and of the cause. A classification thus formed is properly scientific or philosophical, and is commonly called a natural, in contradistinction to a technical or artificial classification or arrangement. The phrase natural classification seems most peculiarly appropriate to such arrangements as correspond, in the groups which they form, to the spontaneous tendencies of the mind, by placing together the objects most similar in their general aspect, in opposition to those technical systems which, arranging things according to their agreement in some circumstance arbitrarily selected, often throw into the same group objects which, in the general aggregate of their properties, present no resemblance, and into different and remote groups, others which have the closest similarity. It is one of the most valid recommendations of any classification to the character of a scientific one, that it shall be a natural classification in this sense also, for the test of its scientific character is the number and importance of the properties which can be asserted in common of all objects included in a group. and properties on which the general aspect of the things depends are, if only on that ground, important as well as, in most cases, numerous. But though a strong recommendation, this circumstance is not a sine qua non, since the most obvious properties of things may be of trifling importance compared with others that are not obvious. I have seen it mentioned as a great absurdity in the Linnaean classification that it places, which, by the way, it does not, the violet by the side of the oak. It certainly dissevers natural affinities and brings together things quite as unlike as the oak and the violet are. But the difference, apparently so wide, which renders the juxtaposition of these two vegetables so suitable an illustration of a bad arrangement, depends to the common eye mainly on mere size and texture. Now, if we made it our study to adopt the classification which would involve the least peril of similar rapprochement, we should return to the obsolete division into trees, shrubs, and herbs, which, though of primary importance with regard to mere general aspect, yet, compared even with so petty and unobvious a distinction as that into dicotyledons and monocotyledons, answers to so few differences in the other properties of plants that a classification founded on it, independently of the indistinctness of the lines of demarcation, would be as completely artificial and technical as the Linnaean. Our natural groups, therefore, must often be founded not on the obvious, but on the unobvious properties of things, when these are of greater importance. But in such cases it is essential that there should be some other property or set of properties more readily recognizable by the observer, which coexist with, and may be received as marks of, the properties which are the real groundwork of the classification. A natural arrangement, for example, of animals must be founded in the main on their internal structure. But, as M. Comte remarks, it would be absurd that we should not be able to determine the genus and species of an animal without first killing it. On this ground, the preference among zoological classifications is probably due to that of M. de Blainville, founded on the differences in the external integuments, differences which correspond much more accurately than might be supposed to the really important varieties, both in the other parts of the structure and in the habits and history of the animals. This shows more strongly than ever how extensive a knowledge of the properties of objects is necessary for making a good classification of them. And as it is one of the uses of such a classification that by drawing attention to the properties on which it is founded, and which, if the classification be good, are marks of many others, it facilitates the discovery of those others. We see in what manner our knowledge of things and our classification of them tend mutually and indefinitely to the improvement of each other. We said just now that the classification of objects should follow those of their properties, which indicate not only the most numerous, but also the most important peculiarities. What is here meant by importance? It has reference to the particular end in view, and the same objects, therefore, may admit with propriety of several different classifications. Each science or art forms its classification of things according to the properties which fall within its special cognizance, or of which it must take account in order to accomplish its peculiar practical end. A farmer does not divide plants, like a botanist, into dicotyledonous and monocotyledonous, but into useful plants and weeds. A geologist divides fossils not like a zoologist into families corresponding to those of living species, but into fossils of the Paleozoic, Mesozoic, and Tertiary periods, above the coal and below the coal, and so on. Whales are or are not fish according to the purpose for which we are considering them. Quote, If we are speaking of the internal structure and physiology of the animal, we must not call them fish, for in these respects they deviate widely from fishes. They have warm blood, and produce and suckle their young as land quadrupeds do. But this would not prevent our speaking of the whale fishery, and calling such animals fish on all occasions connected with this employment. For the relations thus arising depend upon the animals living in the water, and being caught in a manner similar to other fishes. A plea that human laws which mention fish do not apply to whales would be rejected at once by an intelligent judge. Footnote: Novum Organon Renovatum, pages 286 and 287. End footnote. These different classifications are all good for the purposes of their own particular departments of knowledge or practice. But when we are studying objects not for any special practical end, but for the sake of extending our knowledge of the whole of their properties and relations, we must consider as the most important attributes those which contribute most, either by themselves or by their effects, to render the things like one another and unlike other things, which give to the class composed of them the most marked individuality, which fill, as it were, the largest space in their existence, and would most impress the attention of a spectator who knew all their properties, but was not specially interested in any. Classes formed on this principle may be called, in a more emphatic manner than any others, natural groups. Part 3. On the subject of these groups, Dr. Whewell lays down a theory grounded on an important truth, which he has, in some respects, expressed and illustrated very felicitously, but also, as it appears to me, with some admixture of error. It will be advantageous for both these reasons to extract the statement of his doctrine in the very words he has used. Quote, natural groups, according to this theory, are given by type, not by definition. End quote. Footnote. History of Scientific Ideas, 2, pages 120 through 122. End footnote. And this consideration accounts for that, quote, indefiniteness and indecision which we frequently find in the descriptions of such groups, and which must appear so strange and inconsistent to anyone who does not suppose these descriptions to assume any deeper ground of connection than an arbitrary choice of the botanist. Thus, in the family of the rose tree, we are told that the ovules are very rarely erect, the stigmata usually simple. Of what use, it might be asked, can such loose accounts be? To which the answer is that they are not inserted in order to distinguish the species, but in order to describe the family, and the total relations of the ovules and the stigmata of the family are better known by this general statement. A similar observation may be made with regard to the anomalies of each group, which occur so commonly that Dr. Lindley, in his Introduction to the Natural System of Botany, makes the anomalies an article in each family. Thus, part of the character of Rosacea is that they have alternate stipulate leaves, and that the albumen is obliterated. But yet in Loea, one of the genera of this family, the stipulae are absent, and the albumen is present in another Naella. This implies, as we have already seen, that the artificial character, or diagnosis, as Mr. Lindley calls it, is imperfect. It is, though, very nearly, yet not exactly, commensurate with the natural group, and hence in certain cases this character is made to yield to the general weight of natural affinities. These views of classes determined by characters which cannot be expressed in words, of propositions which state not what happens in all cases, but only usually, of particulars which are included in a class, though they transgress the definition of it, may probably surprise the reader. They are so contrary to many of the received opinions respecting the use of definitions and the nature of scientific propositions that they will probably appear to many persons highly illogical and unphilosophical. But a disposition to such a judgment arises in a great measure from this, that the mathematical and mathematico-physical sciences have, in a great degree, determined men's views of the general nature and form of scientific truth, while natural history has not yet had time or opportunity to exert its due influence upon the current habits of philosophizing. The apparent indefiniteness and inconsistency of the classifications and definitions of natural history belongs in a far higher degree to all other except mathematical speculations, and the modes in which approximations to exact distinctions and general truths have been made in natural history may be worthy our attention, even for the light they throw upon the best modes of pursuing truth of all kinds. Though in a natural group of objects a definition can no longer be of any use as a regulative principle, classes are not therefore left quite loose without any certain standard or guide. The class is steadily fixed, though not precisely limited. It is given, though not circumscribed. It is determined not by a boundary line without, but by a central point within, not by what it strictly excludes, but by what it eminently includes, by an example, not a precept. In short, instead of a definition, we have a type for our director. Quote, a type is an example of any class, for instance, a species of a genus, which is considered as eminently possessing the character of the class. All the species which have a greater affinity with this type species than with any others form the genus, and are arranged about it, deviating from it in various directions and different degrees. Thus, a genus may consist of several species which approach very near the type, and of which the claim to a place with it is obvious, while there may be other species which straggle farther from this central knot, and which yet are clearly more connected with it than with any other. And even if there should be some species of which the place is dubious, and which appear to be equally bound to two generic types, it is easily seen that this would not destroy the reality of the generic groups, any more than the scattered trees of the intervening plain prevent our speaking intelligibly of the distinct forests of two separate hills. The type species of every genus, the type genus of every family, is then one which possesses all the characters and properties of the genus in a marked and prominent manner. The type of the rose family has alternate stipulate leaves, wants the albumen, has the ovules not erect, has the stigmata simple, and besides these features which distinguish it from the exceptions or varieties of its class, it has the features which make it prominent in its class. It is one of those which possess clearly several leading attributes, and thus, though we cannot say of any one genus that it must be the type of the family, or of any one species that it must be the type of the genus, we are still not wholly to seek. The type must be connected by many affinities with most of the others of its group. It must be near the centre of the crowd, and not one of the stragglers. End quote. In this passage, the latter part of which especially I cannot help noticing as an admirable example of philosophic style, Dr. Whewell has stated very clearly and forcibly, but, I think, without making all necessary distinctions, one of the principles of a natural classification. What this principle is, what are its limits, and in what manner he seems to me to have overstepped them will appear when we have laid down another rule of natural arrangement, which appears to me still more fundamental. Part 4. The reader is by this time familiar with the general truth, which I restate so often on account of the great confusion in which it is commonly involved, that there are in nature distinctions of kind, distinctions not consisting in a given number of definite properties plus the effects which follow from those properties, but running through the whole nature, through the attributes generally of the things so distinguished. Our knowledge of the properties of a kind is never complete. We are always discovering and expecting to discover new ones. Where the distinction between two classes of things is not one of kind, we expect to find their properties alike, except where there is some reason for their being different. On the contrary, when the distinction is in kind, we expect to find the properties different, unless there be some cause for their being the same. All knowledge of a kind must be obtained by observation and experiment upon the kind itself. No inference respecting its properties from the properties of things not connected with it by kind goes for more than the sort of presumption usually characterized as an analogy, and generally in one of its fainter degrees. Since the common properties of a true kind, and consequently the general assertions which can be made respecting it, or which are certain to be made hereafter as our knowledge extends, are indefinite and inexhaustible, and since the very first principle of natural classification is that of forming the classes so that the objects composing each may have the greatest number of properties in common, this principle prescribes that every such classification shall recognize and adopt into itself all distinctions of kind which exist among the objects it professes to classify. To pass over any distinctions of kind and substitute definite distinctions which, however considerable they may be, do not point to ulterior unknown differences, would be to replace classes with more by classes with fewer attributes in common, and would be subversive of the natural method of classification. Accordingly, all natural arrangements, whether the reality of the distinction of kinds was felt or not by their framers, have been led by the mere pursuit of their own proper end to conform themselves to the distinctions of kind so far as these have been ascertained at the time. The species of plants are not only real kinds, but are probably, all of them, real lowest kinds. Infamy species, which, if we were to subdivide, as of course it is open to us to do, into subclasses, the subdivision would necessarily be founded on definite distinctions, not pointing, apart from what may be known of their causes or effects, to any difference beyond themselves. In so far as a natural classification is grounded on real kinds, its groups are certainly not conventional. It is perfectly true that they do not depend upon an arbitrary choice of the naturalist, but it does not follow, nor, I conceive, is it true, that these classes are determined by a type and not by characters. To determine them by a type would be as sure a way of missing the kind as if we were to select a set of characters arbitrarily. They are determined by characters, but these are not arbitrary. The problem is to find a few definite characters which point to the multitude of indefinite ones. Kinds are classes between which there is an impassable barrier, and what we have to seek is marks whereby we may determine on which side of the barrier an object takes its place. The characters which will best do this should be chosen. If they are also important in themselves, so much the better. When we have selected the characters, we parcel out the objects according to those characters, and not, I conceive, according to resemblance to a type. we do not compose the species Ranunculus acris of all plants which bear a satisfactory degree of resemblance to a model buttercup, but of those which possess certain characters selected as marks by which we might recognize the possibility of a common parentage, and the enumeration of those characters is the definition of the species. The question next arises whether, as all kinds must have a place among the classes, so all the classes in a natural arrangement must be kinds, and to this I answer, certainly not. The distinctions of kinds are not numerous enough to make up the whole of a classification. Very few of the genera of plants, or even of the families, can be pronounced with certainty to be kinds. The great distinctions of vascular and cellular, dicotyledonous or exogenous, and monocotyledonous or endogenous plants, are perhaps differences of kind. The lines of demarcation which divide those classes seem, though even on this I would not pronounce positively, to go through the whole nature of the plants. But the different species of a genus or genera of a family usually have in common only a limited number of characters. A rose does not seem to differ from a rubus, or the umbelliferae from the ranunculaceae, in much else than the characters botanically assigned to those genera or those families. Unenumerated differences certainly do exist in some cases. There are families of plants which have peculiarities of chemical composition, or yield products having peculiar effects on the animal economy. The cruciferae and fungi contain an unusual proportion of nitrogen. The Labitae are the chief sources of essential oils. The Solanae are very commonly narcotic, and so on. In these and similar cases there are possibly distinctions of kind, but it is by no means indispensable that there should be. Genera and families may be eminently natural, though marked out from one another by properties limited in number, provided those properties are important and the objects contained in each genus or family resemble each other more than they resemble anything which is excluded from the genus or family. After the recognition and definition, then, of the infamous species, the next step is to arrange those infamous species into larger groups, making these groups correspond to kinds wherever it is possible, but in most cases without any such guidance. And in doing this it is true that we are naturally and properly guided, in most cases at least by resemblance to a type. We form our groups round certain selected kinds, each of which serves as a sort of exemplar of its group. But though the groups are suggested by types, I cannot think that a group when formed is determined by the type, that in deciding whether a species belongs to the group, a reference is made to the type and not to the characters, that the characters cannot be expressed in words. This assertion is inconsistent with Dr. Whewell's own statement of the fundamental principle of classification, namely that general assertions shall be possible. If the class did not possess any characters in common, what general assertions would be possible respecting it, except that they all resemble each other more than they resemble anything else? Nothing whatever could be predicated of the class. The truth is, on the contrary, that every genus or family is framed with distinct reference to certain characters, and is composed first and principally of species which agree in possessing all those characters. To these are added, as a sort of appendix, such other species generally in small number as possess nearly all the properties selected, wanting some of them one property, some another, and which, while they agree with the rest almost as much as these agree with one another, do not resemble in an equal degree any other group. our conception of the class continues to be grounded on the characters, and the class might be defined those things which either possess that set of characters or resemble the things that do so, more than they resemble anything else. And this resemblance itself is not, like resemblance between simple sensations, an ultimate fact, unsusceptible of analysis. Even the inferior degree of resemblance is created by the possession of common characters. Whatever resembles the genus rose more than it resembles any other genus, does so because it possesses a greater number of the characters of that genus than of the characters of any other genus. Nor can there be any real difficulty in representing by an enumeration of characters the nature and degree of the resemblance which is strictly sufficient to include any object in the class. There are always some properties common to all things which are included. Others there often are, to which some things, which are nevertheless included, are exceptions. But the objects which are exceptions to one character are not exceptions to another. The resemblance which fails in some particulars must be made up for in others. The class, therefore, is constituted by the possession of all the characters which are universal and most of those which admit of exceptions. If a plant had the ovules erect, the stigmata divided, possessed the albumen, and was without stipules, it possibly would not be classed among the Rosacea. But it may want any one or more than one of these characters, and not be excluded. The ends of a scientific classification are better answered by including it. Since it agrees so nearly in its known properties with the sum of the characters of the class, it is likely to resemble that class more than any other in those of its properties which are still undiscovered. Not only, therefore, are natural groups, no less than any artificial classes, determined by characters, they are constituted in contemplation of, and by reason of, characters. But it is in a contemplation not of those characters only which are rigorously common to all the objects included in the group, but of the entire body of characters, all of which are found in most of those objects, and most of them in all. And hence our conception of the class, the image in our minds which is representative of it, is that of a specimen complete in all the characters, most naturally a specimen which, by possessing them all in the greatest degree in which they are ever found, is the best fitted to exhibit clearly and in a marked manner what they are. It is by a mental reference to this standard, not instead of, but in illustration of the definition of the class, that we usually and advantageously determine whether any individual or species belongs to the class or not. And this, as it seems to me, is the amount of truth contained in the doctrine of types. We shall see presently that where the classification is made for the express purpose of a special inductive inquiry, it is not optional, but necessary for fulfilling the conditions of a correct inductive method, that we should establish a type species, or genus, namely, the one which exhibits in the most eminent degree the particular phenomenon under investigation. But of this hereafter. It remains, for completing the theory of natural groups, that a few words should be said on the principles of the nomenclature adapted to them. Part 5. A nomenclature in science is, as we have said, a system of the names of kinds. These names, like other class names, are defined by the enumeration of the characters distinctive of the class. The only merit which a set of names can have beyond this is to convey, by the mode of their construction, as much information as possible, so that a person who knows the thing may receive all the assistance which the name can give in remembering what he knows, while he who knows it not may receive as much knowledge respecting it as the case admits of, by merely being told its name. There are two modes of giving to the name of a kind this sort of significance. The best, but which unfortunately is seldom practicable, is when the word can be made to indicate, by its formation, the very properties which it is designed to connote. The name of a kind does not, of course, connote all the properties of the kind, since these are inexhaustible, but such of them as are sufficient to distinguish it, such as are sure marks of all the rest. Now, it is very rarely that one property, or even any 2 or 3 properties, can answer this purpose. To distinguish the common daisy from all other species of plants would require the specification of many characters, and a name cannot, without being too cumbrous for use, give indication, by its etymology or mode of construction, of more than a very small number of these. The possibility, therefore, of an ideally perfect nomenclature is probably confined to the one case in which we are happily in possession of something approaching to it, the nomenclature of elementary chemistry. The substances, whether simple or compound, with which chemistry is conversant, are kinds, and as such, the properties which distinguish each of them from the rest are innumerable. But in the case of compound substances, the simple ones are not numerous enough to require a systematic nomenclature. There is one property, the chemical composition, which is of itself sufficient to distinguish the kind, and is, with certain reservations not yet thoroughly understood, a sure mark of all the other properties of the compound. All that was needful, therefore, was to make the name of every compound express, on the first hearing, its chemical composition, that is, to form the name of the compound in some uniform manner, from the names of the simple substances which enter into it as elements. This was done most skilfully and successfully by the French chemists, though their nomenclature has become inadequate to the convenient expression of the very complicated compounds now known to chemists. The only thing left unexpressed by them was the exact proportion in which the elements were combined, and even this, since the establishment of the atomic theory, it has been found possible to express by a simple adaptation of their phraseology. But where the characters which must be taken into consideration in order sufficiently to designate the kind are too numerous to be all signified in the derivation of the name, and where no one of them is of such preponderant importance as to justify its being singled out to be so indicated, we may avail ourselves of a subsidiary resource. Though we cannot indicate the distinctive properties of the kind, we may indicate its nearest natural affinities by incorporating into its name the name of the proximate natural group of which it is one of the species. On this principle is founded the admirable binary nomenclature of botany and zoology. In this nomenclature, the name of every species consists of the name of the genus or natural group next above it, with a word added to distinguish the particular species. The last portion of the compound name is sometimes taken from some one of the peculiarities in which that species differs from others of the genus, as Clematis integrifolia, Potentilla alba, Viola palustris, Artemisia vulgaris, sometimes from a circumstance of an historical nature, as Narcissus poeticus, Potentilla tormentilla, indicating that the plant is that which was formerly known by the latter name. Exacum Candoyi, from the fact that de Candoyi was its first discoverer. And sometimes the word is purely conventional, as Thlaspi bursa pastoris, ranunculus thora. It is of little consequence which, since the second, or, as it is usually called, the specific name, could at most express independently of convention no more than a very small portion of the connotation of the term. But by adding to this the name of the superior genus, we may make the best amends we can for the impossibility of so contriving the name as to express all the distinctive characters of the kind. We make it, at all events, express as many of those characters as are common to the proximate natural group in which the kind is included. If even those common characters are so numerous or so little familiar as to require a further extension of the same resource, we might, instead of a binary, adopt a ternary nomenclature, employing not only the name of the genus, but that of the next natural group in order of generality above the genus, commonly called the family. This was done in the mineralogical nomenclature proposed by Professor Mohs. Quote, "The names framed by him were not composed of 2 but of 3 elements, designating respectively the species, the genus, and the order. Thus, he has such species as rhombohedral, lime, haloid, octohedral, fluor, haloid, prismatic, hal, baryte." End quote. Footnote: Novum Organon Renovatum, page 274. End footnote. The binary construction, however, has been found sufficient in botany and zoology, the only sciences in which this general principle has hitherto been successfully adopted in the construction of a nomenclature. Besides the advantage which this principle of nomenclature possesses in giving to the names of species the greatest quantity of independent significance which the circumstances of the case admit of, it answers the further end of immensely economizing the use of names and preventing an otherwise intolerable burden on the memory. When the names of species become extremely numerous, some artifice, as Dr. Whewell observes, History of Scientific Ideas, Book 1, page 133, becomes absolutely necessary to make it possible to recollect or apply them. Quote, "The known species of plants, for example, were 10,000 in the time of Linnaeus and are now probably 60,000. It would be useless to endeavour to frame and employ separate names for each of these species. The division of the objects into a subordinated system of classification enables us to introduce a nomenclature which does not require this enormous number of names. Each of the genera has its name, and the species are marked by the addition of some epithet to the name of the genus. In this manner, about 1,700 generic names, with a moderate number of specific names, were found by Linnaeus sufficient to designate with precision all the species of vegetables known at his time." End quote. And though the number of generic names has since greatly increased, it has not increased in anything like the proportion of the multiplication of known species. End of section 70. Section 71 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 4, Chapter 8 of Classification by Series. Part 1. Thus far, we have considered the principles of scientific classification so far only as relates to the formation of natural groups, and at this point most of those who have attempted a theory of natural arrangement, including among the rest Dr. Whewell, have stopped. There remains, however, another and a not less important portion of the theory, which has not yet, as far as I am aware, been systematically treated of by any writer except Monsieur Comte. This is the arrangement of the natural groups into a natural series. Footnote. Dr. Webble, in his reply, Philosophy of Discovery, page 270, says that he, quote, stopped short of, or rather passed by, the doctrine of a series of organized beings, because he thought it bad and narrow philosophy. End quote. If he did, it was evidently without understanding this form of the doctrine, for he proceeds to quote a passage from his History, in which the doctrine he condemns is designated as that of, quote, a mere linear progression in nature which would place each genus in contact only with the preceding and succeeding ones. End quote. Now the series treated of in the text agrees with this linear progression in nothing whatever, but in being a progression. End quote. The end of classification as an instrument for the investigation of nature is, as before stated, to make us think of those objects together which have the greatest number of important common properties, and which, therefore, we have oftenest occasion, in the course of our inductions, for taking into joint consideration. Our ideas of objects are thus brought into the order most conducive to the successful prosecution of inductive inquiries generally. But when the purpose is to facilitate some particular inductive inquiry, more is required. To be instrumental to that purpose, the classification must bring those objects together, the simultaneous contemplation of which is likely to throw most light upon the particular subject. That subject being the laws of some phenomenon, or some set of connected phenomena. The very phenomenon or set of phenomena in question must be chosen as the groundwork of the classification. The requisites of a classification intended to facilitate the study of a particular phenomenon are, first, to bring into one class all kinds of things which exhibit that phenomenon, in whatever variety of forms or degrees, and secondly, to arrange those kinds in a series according to the degree in which they exhibit it, beginning with those which exhibit most of it, and terminating with those which exhibit least. The principal example, as yet, of such a classification is afforded by comparative anatomy and physiology, from which, therefore, our illustrations shall be taken. Part 2. The object being supposed to be the investigation of the laws of animal life, the first step after forming the most distinct conception of the phenomenon itself possible in the existing state of our knowledge, is to erect into one great class, that of animals, all the known kinds of beings where that phenomenon presents itself, in however various combinations with other properties, and in however different degrees. As some of these kinds manifest the general phenomenon of animal life in a very high degree, and others in an insignificant degree, barely sufficient for recognition, we must in the next place arrange the various kinds in a series, following one another according to the degrees in which they severally exhibit the phenomenon, beginning, therefore, with man, and ending with the most imperfect kind of zoophytes. This is merely saying that we should put the instances from which the law is to be inductively collected into the order which is implied in one of the 4 methods of experimental inquiry discussed in the preceding book. The 4th method, that of concomitant variations. As formerly remarked, this is often the only method to which recourse can be had with assurance of a true conclusion, in cases in which we have but limited means of effecting, by artificial experiments, a separation of circumstances usually conjoined. The principle of the method is that facts which increase or diminish together and disappear together are either cause and effect, or effects of a common cause. When it has been ascertained that this relation really subsists between the variations, a connection between the facts themselves may be confidently laid down, either as a law of nature or only as an empirical law according to circumstances. That the application of this method must be preceded by the formation of such a series as we have described is too obvious to need being pointed out, and the mere arrangement of a set of objects in a series according to the degrees in which they exhibit some fact of which we are seeking the law is too naturally suggested by the necessities of our inductive operations to require any lengthened illustration here. But there are cases in which the arrangement required for the special purpose becomes the determining principle of the classification of the same objects for general purposes. This will naturally and properly happen when those laws of the objects which are sought in the special inquiry enact so principal a part in the general character and history of those objects, exercise so much influence in determining all the phenomena of which they are either the agents or the theatre, that all other differences existing among the objects are fittingly regarded as mere modifications of the one phenomenon sought, effects determined by the cooperation of some incidental circumstance with the laws of that phenomenon. Thus, in the case of animated beings, the differences between one class of animals and another may reasonably be considered as mere modifications of the general phenomenon, animal life. Modifications arising either from the different degrees in which that phenomenon is manifested in different animals, or from the intermixture of the effects of incidental causes peculiar to the nature of each, with the effects produced by the general laws of life, those laws still exercising a predominant influence over the result. Such being the case, no other inductive inquiry respecting animals can be successfully carried on except in subordination to the great inquiry into the universal laws of animal life, and the classification of animals best suited to that one purpose is the most suitable to all the other purposes of zoological science. Part 3. To establish a classification of this sort, or even to apprehend it when established, requires the power of recognizing the essential similarity of a phenomenon in its minuter degrees and obscurer forms with what is called the same phenomenon in the greatest perfection of its development, that is, of identifying with each other all phenomena which differ only in degree and in properties which we suppose to be caused by difference of degree. In order to recognize this identity, or, in other words, this exact similarity of quality, the assumption of a type species is indispensable. We must consider as the type of the class that among the kinds included in it which exhibits the properties constitutive of the class in the highest degree, conceiving the other varieties as instances of degeneracy, as it were, from that type, deviations from it by inferior intensity of the characteristic property or properties. For every phenomenon is best studied, caeteris paribus, where it exists in the greatest intensity. It is there that the effects which either depend on it or depend on the same causes with it will also exist in the greatest degree. It is there, consequently, and only there, that those effects of it, or joint effects with it, can become fully known to us, so that we may learn to recognize their smaller degrees, or even their mere rudiments, in cases in which the direct study would have been difficult or even impossible. Not to mention that the phenomenon in its higher degrees may be attended by effects or collateral circumstances which, in its smaller degrees, do not occur at all, requiring for their production in any sensible amount a greater degree of intensity of the cause than is there met with. In man, for example, the species in which both the phenomenon of animal and that of organic life exist in the highest degree, many subordinate phenomena develop themselves in the course of his animated existence, which the inferior varieties of animals do not show. The knowledge of these properties may nevertheless be of great avail toward the discovery of the conditions and laws of the general phenomenon of life, which is common to man with those inferior animals, and they are even rightly considered as properties of animated nature itself, because they may evidently be affiliated to the general laws of animated nature, because we may fairly presume that some rudiments or feeble degrees of those properties would be recognized in all animals by more perfect organs, or even by more perfect instruments than ours, and because those may be correctly termed properties of a class which a thing exhibits exactly in proportion as it belongs to the class, that is, in proportion as it possesses the main attributes constitutive of the class. Part 4. It remains to consider how the internal distribution of the series may most properly take place, in what manner it should be divided into orders, families, and genera. The main principle of division must of course be natural affinity. The classes formed must be natural groups, and the formation of these has already been sufficiently treated of. But the principles of natural grouping must be applied in subordination to the principle of natural series. The groups must not be so constituted as to place in the same group things which ought to occupy different points of the general scale. The precaution necessary to be observed for this purpose is that the primary divisions must be grounded not on all distinctions indiscriminately, but on those which correspond to variations in the degree of the main phenomenon. The series of animated nature should be broken into parts at the points where the variation in the degree of intensity of the main phenomenon, as marked by its principal characters, sensation, thought, voluntary motion, and so on, begins to be attended by conspicuous changes in the miscellaneous properties of the animal. Such well-marked changes take place, for example, where the class Mammalia ends, at the points where fishes are separated from insects, insects from mollusca, and so on. When so formed, the primary natural groups will compose the series by mere juxtaposition without redistribution, each of them corresponding to a definite portion of the scale. In like manner, each family should, if possible, be so subdivided that one portion of it shall stand higher and the other lower, though of course contiguous in the general scale. And only when this is impossible is it allowable to ground the remaining subdivisions on characters having no determinable connection with the main phenomenon. Where the principal phenomenon so far transcends in importance all other properties on which a classification could be grounded, as it does in the case of animated existence, any considerable deviation from the rule last laid down is in general sufficiently guarded against by the first principle of a natural arrangement, that of forming the groups according to the most important characters. All attempts at a scientific classification of animals, since first their anatomy and physiology were successfully studied, have been framed with a certain degree of instinctive reference to a natural series, and have accorded in many more points than they have differed with the classification which would most naturally have been grounded on such a series. But the accordance has not always been complete, and it still is often a matter of discussion which of several classifications best accords with the true scale of intensity of the main phenomenon. Cuvier, for example, has been justly criticized for having formed his natural groups with an undue degree of reference to the mode of alimentation, a circumstance directly connected only with organic life, and not leading to the arrangement most appropriate for the purposes of an investigation of the laws of animal life, since both carnivorous and herbivorous or frugivorous animals are found at almost every degree in the scale of animal perfection. Blainville's classification has been considered by high authorities to be free from this defect, as representing correctly, by the mere order of the principal groups, the successive degeneracy of animal nature from its highest to its most imperfect exemplification. Part 5. A classification of any large portion of the field of nature in conformity to the foregoing principles has hitherto been found practicable only in one great instance, that of animals. In the case even of vegetables, the natural arrangement has not been carried beyond the formation of natural groups. Naturalists have found, and probably will continue to find it impossible to form those groups into any series, the terms of which correspond to real gradations in the phenomenon of vegetative or organic life. Such a difference of degree may be traced between the class of vascular plants and that of cellular, which includes lichens, algae, and other substances whose organization is simpler and more rudimentary than that of the highest order of vegetables, and which therefore approach nearer to mere inorganic nature. But when we rise much above this point, we do not find any sufficient difference in the degree in which different plants possess the properties of organization and life. The dicotyledons are of more complex structure and somewhat more perfect organization than the monocotyledons, and some dicotyledonous families, such as the Compositae, are rather more complex in their organization than the rest. But the differences are not of a marked character, and do not promise to throw any particular light upon the conditions and laws of vegetable life and development. If they did, the classification of vegetables would have to be made, like that of animals, with reference to the scale or series indicated. Although the scientific arrangements of organic nature afford as yet the only complete example of the true principles of rational classification, whether as to the formation of groups or of series, those principles are applicable to all cases in which mankind are called upon to bring the various parts of any extensive subject into mental coordination. They are as much to the point when objects are to be classed for purposes of art or business, as for those of science. The proper arrangement, for example, of a code of laws depends on the same scientific conditions as the classification in natural history. Nor could there be a better preparatory discipline for that important function than the study of the principles of a natural arrangement, not only in the abstract, but in their actual application to the class of phenomena for which they were first elaborated, and which are still best school for learning their use. Of this the great authority on codification, Bentham, was perfectly aware, and his early Fragment on Government, the admirable introduction to a series of writings unequalled in their department, contains clear and just views, as far as they go, on the meaning of a natural arrangement, such as could scarcely have occurred to anyone who lived anterior to the age of Linnaeus and Bernard de Jussieu. End of section 71. Section 72 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 5 on Fallacies. Chapter 1 of Fallacies in General. Errare non modo affermando et negando, sed etiam sentiendo, et in tacita hominum cogitione contigit. Hobbes, Computatio Civ Logica, Chapter 5. Il lui semble qu'il n'y a que douter par fantaisie, et qu'il n'y a à que dire en général que notre nature est infâme, que notre esprit est plein d'aveuglement, qu'il faut avoir un grand soin de se défaire de ses préjugés et autres choses semblables. Ils pensent que cela suffit pour ne plus se laisser séduire à ses sens et pour ne plus se tromper du tout. Il ne suffit pas de dire que l'esprit est faible, il faut lui faire sentir ses faiblesses. Ce n'est pas assez de dire qu'il est sujet à l'erreur, il faut lui découvrir en quoi consistent ces erreurs. Malebranche, Recherche de la vérité. Part 1. It is a maxim of the schoolmen that contrarior medem est scientia. We never really know what a thing is unless we are also able to give a sufficient account of its opposite. Conformably to this maxim, one considerable section in most treatises on logic is devoted to the subject of fallacies, and the practice is too well worthy of observance to allow our departing from it. The philosophy of reasoning, to be complete, ought to comprise the theory of bad as well as of good reasoning. We have endeavoured to ascertain the principles by which the sufficiency of any proof can be tested, and by which the nature and amount of evidence needful to prove any given conclusion can be determined beforehand. If these principles were adhered to, then although the number and value of the truths ascertained would be limited by the opportunities or by the industry, ingenuity, and patience of the individual inquirer, at least error would not be embraced instead of truth. But the general consent of mankind, founded on their experience, vouches for their being far indeed from even this negative kind of perfection in the employment of their reasoning powers. In the conduct of life, in the practical business of mankind, wrong inferences, incorrect interpretations of experience, unless after much culture of the thinking faculty, are absolutely inevitable, and with most people, after the highest degree of culture they ever attain, such erroneous inferences, producing corresponding errors in conduct, are lamentably frequent. Even in the speculations to which eminent intellects have systematically devoted themselves, and in reference to which the collective mind of the scientific world is always at hand to aid the efforts and correct the aberrations of individuals, it is only from the more perfect sciences, from those of which the subject matter is the least complicated, that opinions not resting on a correct induction have at length, generally speaking, been expelled. In the departments of inquiry relating to the more complex phenomena of nature, and especially those of which the subject is man, whether as a moral and intellectual, a social, or even as a physical being, the diversity of opinions still prevalent among instructed persons, and the equal confidence with which those of the most contrary ways of thinking cling to their respective tenets, are proof not only that right modes of philosophizing are not yet generally adopted on those subjects, but that wrong ones are, that inquirers have not only in general missed the truth, but have often embraced error, that even the most cultivated portion of our species have not yet learned to abstain from drawing conclusions with which the evidence does not warrant. The only complete safeguard against reasoning ill is the habit of reasoning well. Familiarity with the principles of correct reasoning, and practice in applying those principles. It is, however, not unimportant to consider what are the most common modes of bad reasoning, by what appearances the mind is most likely to be seduced from the observance of true principles of induction, what, in short, are the most common and most dangerous varieties of apparent evidence, whereby persons are misled into opinions for which there does not exist evidence really conclusive. A catalogue of the varieties of apparent evidence which are not real evidence is an enumeration of fallacies. Without such an enumeration, therefore, the present work would be wanting in an essential point. And while writers who included in their theory of reasoning nothing more than ratiocination have in consistency with this limitation confined their remarks to the fallacies which have their seat in that portion of the process of investigation. We who profess to treat of the whole process must add to our directions for performing it rightly warnings against performing it wrongly in any of its parts, whether the ratiocinative or the experimental portion of it be in fault, or the fault lie in dispensing with ratiocination and induction altogether. Part 2. In considering the sources of unfounded inference, it is unnecessary to reckon the errors which arise not from a wrong method, nor even from ignorance of the right one, but from a casual lapse, through hurry or inattention, in the application of the true principles of induction. Such errors, like the accidental mistakes in casting up a sum, do not call for philosophical analysis or classification. Theoretical considerations can throw no light upon the means of avoiding them. In the present treatise, our attention is required not to mere inexpertness in performing the operation in the right way, the only remedies for which are increased attention and more sedulous practice, but to the modes of performing it in a way fundamentally wrong. The conditions under which the human mind persuades itself that it has sufficient grounds for a conclusion which it has not arrived at by any of the legitimate methods of induction, which it has not, even carelessly or over hastily, endeavoured to test by those legitimate methods. Part 3. There is another branch of what may be called the philosophy of error, which must be mentioned here, though only to be excluded from our subject. The sources of erroneous opinions are twofold, moral and intellectual. Of these, the moral do not fall within the compass of this work. They may be classed under two general heads, indifference to the attainment of truth, and bias, of which last the most common case is that in which we are biased by our wishes, but the liability is almost as great to the undue adoption of a conclusion which is disagreeable to us, as of one which is agreeable, if it be of a nature to bring into action any of the stronger passions. Persons of timid character are the more predisposed to believe any statement, the more it is calculated to alarm them. Indeed, it is a psychological law, deducible from the most general laws of the mental constitution of man, that any strong passion renders us credulous as to the existence of objects suitable to excite it. But the moral causes of opinions, though with most persons the most powerful of all, are but remote causes. They do not act directly, but by means of the intellectual causes, to which they bear the same relation that the circumstances called, in the theory of medicine, predisposing causes bear to exciting causes. Indifference to truth cannot, in and by itself, produce erroneous belief. It operates by preventing the mind from collecting the proper evidences, or from applying to them the test of a legitimate and rigid induction, by which omission it is exposed unprotected to the influence of any species of apparent evidence which offers itself spontaneously, or which is elicited by that smaller quantity of trouble which the mind may be willing to take. As little is bias a direct source of wrong conclusions. We cannot believe a proposition only by wishing or only by dreading to believe it. The most violent inclination to find a set of propositions true will not enable the weakest of mankind to believe them without a vestige of intellectual grounds, without any even apparent evidence. It acts indirectly by placing the intellectual grounds of belief in an incomplete or distorted shape before his eyes. It makes him shrink from the irksome labour of a rigorous induction when he has a misgiving that its result may be disagreeable, and in such examination as he does institute, it makes him exert that which is in a certain measure voluntary. his attention unfairly giving a larger share of it to the evidence which seems favourable to the desired conclusion, a smaller to that which seems unfavourable. It operates, too, by making him look out eagerly for reasons or apparent reasons to support opinions which are conformable, or resist those which are repugnant to his interests or feelings. And when the interests or feelings are common to great numbers of persons, reasons are accepted and pass current which would not for a moment be listened to in that character if the conclusion had nothing more powerful than its reasons to speak in its behalf. The natural or acquired partialities of mankind are continually throwing up philosophical theories, the sole recommendation of which consists in the premises they afford for proving cherished doctrines or justifying favourite feelings, and when any one of these theories has been so thoroughly discredited as no longer to serve the purpose, another is always ready to take its place. This propensity, when exercised in favour of any widely spread persuasion or sentiment, is often decorated with complimentary epithets, and the contrary habit of keeping the judgment in complete subordination to evidence is stigmatized by various hard names as scepticism, immorality, coldness, hard-heartedness, and similar expressions according to the nature of the case. But though the opinions of the generality of mankind, when not dependent on mere habit and inculcation, have their root much more in the inclinations than in the intellect, it is a necessary condition to the triumph of the moral bias that it should first pervert the understanding. Every erroneous inference, though originating in moral causes, involves the intellectual operation of admitting insufficient evidence as sufficient, and whoever was on his guard against all kinds of inconclusive evidence which can be mistaken for conclusive, would be in no danger of being led into error even by the strongest bias. There are minds so strongly fortified on the intellectual side that they could not blind themselves to the light of truth, however really desirous of doing so. They could not, with all the inclination in the world, pass off upon themselves bad arguments for good ones. If the sophistry of the intellect could be rendered impossible, that of the feelings, having no instrument to work with, would be powerless. A comprehensive classification of all those things which, not being evidence, are liable to appear such to the understanding, will therefore of itself include all errors of judgment arising from moral causes, to the exclusion only of errors of practice committed against better knowledge. To examine, then, the various kinds of apparent evidence which are not evidence at all, and of apparently conclusive evidence which do not really amount to conclusiveness, is the object of that part of our inquiry into which we are about to enter. The subject is not beyond the compass of classification and comprehensive survey. The things indeed which are not evidence of any given conclusion are manifestly endless, and this negative property, having no dependence on any positive ones, cannot be made the groundwork of a real classification. But the things which, not being evidence, are susceptible of being mistaken for it, are capable of a classification having reference to the positive property which they possess of appearing to be evidence. We may arrange them, at our choice, on either of two principles, according to the cause which makes them appear to be evidence, not being so, or according to the particular kind of evidence which they simulate. The classification of fallacies, which will be attempted in the ensuing chapter, is founded on these considerations jointly. End of section 72. Section 73 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 5, Chapter 2, Classification of Fallacies. Part 1. In attempting to establish certain general distinctions which shall mark out from one another the various kinds of fallacious evidence, we propose to ourselves an altogether different aim from that of several eminent thinkers who have given, under the name of political or other fallacies, a mere enumeration of a certain number of erroneous opinions, false general propositions which happen to be often met with, loci communes of bad arguments on some particular subject. Logic is not concerned with the false opinions which people happen to entertain, but with the manner in which they come to entertain them. The question is not what facts have at any time been erroneously supposed to be proof of certain other facts, but what property in the facts it was which led any one to this mistaken supposition. When a fact is supposed, though incorrectly, to be evidentiary of, or a mark of, some other fact, there must be a cause of the error. The supposed evidentiary fact must be connected in some particular manner with the fact of which it is deemed evidentiary, must stand in some particular relation to it, without which relation it would not be regarded in that light. The relation may either be one resulting from the simple contemplation of the two facts side by side with one another, or it may depend on some process of mind by which a previous association has been established between them. Some peculiarity of relation, however, there must be. The fact which can, even by the wildest aberration, be supposed to prove another fact, must stand in some special position with regard to it, and if we could ascertain and define that special position, we should perceive the origin of the error. We cannot regard one fact as evidentiary of another unless we believe that the two are always, or in the majority of cases, conjoined. If we believe A to be evidentiary of B, if when we see A we are inclined to infer B from it, the reason is because we believe that wherever A is, B also either always or for the most part exists, either as an antecedent, a consequent, or a concomitant. If when we see A we are inclined not to expect B, if we believe A to be evidentiary of the absence of B, it is because we believe that where A is, B either is never, or at least seldom found. Erroneous conclusions, in short, no less than correct conclusions, have an invariable relation to a general formula, either expressed or tacitly implied. When we infer some fact from some other fact which does not really prove it, we either have admitted, or, if we maintained consistency, ought to admit some groundless general proposition respecting the conjunction of the two phenomena. For every property, therefore, in facts or in our mode of considering facts, which leads us to believe that they are habitually conjoined when they are not, or that they are not when in reality they are, there is a corresponding kind of fallacy, and an enumeration of fallacies would consist in a specification of those properties in facts and those peculiarities in our mode of considering them, which gives rise to this erroneous opinion. Part 2. To begin then, the supposed connection or repugnance between the two facts may either be a conclusion from evidence, that is, from some other proposition or propositions, or may be admitted without any such ground, admitted as the phrase is on its own evidence, embraced as self-evident, as an axiomatic truth. This gives rise to the first great distinction, that between fallacies of inference and fallacies of simple inspection. In the latter division must be included not only all cases in which a proposition is believed and held for true, literally without any extrinsic evidence, either of specific experience or general reasoning, but those more frequent cases in which simple inspection creates a presumption in favour of a proposition, not sufficient for belief, but sufficient to cause the strict principles of a regular induction to be dispensed with, and creating a predisposition to believe it on evidence which would be seen to be insufficient if no such presumption existed. This class, comprehending the whole of what may be termed natural prejudices, and which I shall call indiscriminately fallacies of simple inspection, or fallacies a priori, shall be placed at the head of our list. Fallacies of inference or erroneous conclusions from supposed evidence must be subdivided according to the nature of the apparent evidence from which the conclusions are drawn, or, what is the same thing, according to the particular kind of sound argument which the fallacy in question simulates. But there is a distinction to be first drawn, which does not answer to any of the divisions of sound arguments, but arises out of the nature of bad ones. We may know exactly what our evidence is, and yet draw a false conclusion from it. We may conceive precisely what our premises are, what alleged matters of fact or general principles are the foundation of our inference, and yet, because the premises are false, or because we have inferred from them what they will not support, our conclusion may be erroneous. But a case perhaps even more frequent is that in which the error arises from not conceiving our premises with due clearness, that is, as shown in the preceding book, with due fixity, forming one conception of our evidence when we collect or receive it, and another when we make use of it, or unadvisedly and in general unconsciously substituting, as we proceed, different premises in the place of those with which we set out, or a different conclusion for that which we undertook to prove. This gives existence to a class of fallacies which may be justly termed, in a phrase borrowed from Bentham, fallacies of confusion, comprehending among others all those which have their source in language, whether arising from the vagueness or ambiguity of our terms, or from casual associations with them. When the fallacy is not one of confusion, that is, when the proposition believed and the evidence on which it is believed are steadily apprehended and unambiguously expressed, there remain to be made two cross divisions. The apparent evidence may be either particular facts or foregone generalizations, that is, the process may simulate either simple induction or deduction, and again, the evidence, whether consisting of supposed facts or of general propositions, may be false in itself, or, being true, may fail to bear out the conclusion attempted to be founded on it. This gives us first fallacies of induction and fallacies of deduction, and then a subdivision of each of these according as the supposed evidence is false or true but inconclusive. Fallacies of induction, where the facts on which the induction proceeds are erroneous, may be termed fallacies of observation. The term is not strictly accurate, or rather not accurately coextensive with the class of fallacies which I propose to designate by it. Induction is not always grounded on facts immediately observed, but sometimes on facts inferred, and when these last are erroneous, the error may not be, in the literal sense of the term, an instance of bad observation, but of bad inference. It will be convenient, however, to make only one class of all the inductions of which the error lies in not sufficiently ascertaining the facts on which the theory is grounded, whether the cause of failure be malobservation or simple non-observation, and whether the malobservation be direct or by means of intermediate marks which do not prove what they are supposed to prove. And in the absence of any comprehensive term to denote the ascertainment by whatever means of the facts on which an induction is grounded, I will venture to retain for this class of fallacies under the explanation now given, the title of Fallacies of Observation. The other class of inductive fallacies in which the facts are correct, but the conclusion not warranted by them, are properly denominated fallacies of generalization, and these again fall into various subordinate classes or natural groups, some of which will be enumerated in their proper place. When we now turn to fallacies of deduction, namely those modes of incorrect argumentation in which the premises, or some of them, are general propositions, and the argument a ratiocination, we may of course subdivide these also into two species similar to the two preceding, namely, those which proceed on false premises, and those of which the premises, though true, do not support the conclusion. But of these species, the first must necessarily fall under some one of the heads already enumerated, for the error must be either in those premises which are general propositions, or in those which assert individual facts. In the former case, it is an inductive fallacy of one or the other class. In the latter, it is a fallacy of observation, unless in either case the erroneous premise has been assumed on simple inspection, in which case the fallacy is a priori. Or, finally, the premises of whichever kind they are may never have been conceived in so distinct a manner as to produce any clear consciousness by what means they were arrived at, as in the case of what is called reasoning in a circle, and then the fallacy is one of confusion. There remain, therefore, as the only class of fallacies having properly their seat in deduction, those in which the premises of the ratiocination do not bear out its conclusion. The various cases, in short, of vicious argumentation provided against by the rules of the syllogism. We shall call these fallacies of ratiocination. Part 3. We must not, however, expect to find that men's actual errors always, or even commonly, fall so unmistakably under some one of these classes as to be incapable of being referred to any other. Erroneous arguments do not admit of such a sharply cut division as valid arguments do. An argument fully stated, with all its steps distinctly set out in language not susceptible of misunderstanding, must, if it be erroneous, be so in some one of these 5 modes unequivocally, or indeed of the first 4, since the 5th on such a supposition would vanish. But it is not in the nature of bad reasoning to express itself thus unambiguously. When a sophist, whether he is imposing on himself or attempting to impose on others, can be constrained to throw his sophistry into so distinct a form, it needs, in a large proportion of cases, no further exposure. In all arguments, everywhere but in the schools, some of the links are suppressed. A fortiori, when the arguer either intends to deceive or is a lame and inexpert thinker, little accustomed to bring his reasoning processes to any test, and it is in those steps of the reasoning which are made in this tacit and half-conscious, or even wholly unconscious manner, that the error oftenest lurks. In order to detect the fallacy, the proposition thus silently assumed must be supplied, but the reasoner, most likely, has never really asked himself what he was assuming. His confuter, unless permitted to extort it from him by the Socratic mode of interrogation, must himself judge what the suppressed premise ought to be in order to support the conclusion. And hence, in the words of Archbishop Whately, quote, "It must be often a matter of doubt, or rather of arbitrary choice, not only to which genus each kind of fallacy should be referred, but even to which kind to refer any one individual fallacy. For since, in any course of argument, one premise is usually suppressed, it frequently happens in the case of a fallacy that the hearers are left to the alternative of supplying either a premise which is not true, or else one which does not prove the conclusion. For example, if a man expatiates on the distress of the country and thence argues that the government is tyrannical, we must suppose him to assume either that every distressed country is under a tyranny, which is a manifest falsehood, or merely that every country under a tyranny is distressed, which, however true, proves nothing, the middle term being undistributed. End quote. The former would be ranked in our distribution among fallacies of generalization, the latter among those of ratiocination. Quote, which are we to suppose the speaker meant us to understand? Surely, if he understood himself, just whichever each of his hearers might happen to prefer, some might assent to the false premise, others allow the unsound syllogism. End quote. Almost all fallacies, therefore, might in strictness be brought under our fifth class, fallacies of confusion. A fallacy can seldom be absolutely referred to any of the other classes. We can only say that if all the links were filled up which should be capable of being supplied in a valid argument, it would either stand thus, forming a fallacy of one class, or thus, a fallacy of another. Or at the furthest we may say that the conclusion is most likely to have originated in a fallacy of such and such a class. Thus, in the illustration just quoted, the error committed may be traced with most probability to a fallacy of generalization, that of mistaking an uncertain mark or piece of evidence for a certain one, concluding from an effect to some one of its possible causes, when there are others which would have been equally capable of producing it. Yet, though the five classes run into each other, and a particular error often seems to be arbitrarily assigned to one of them rather than to any of the rest, there is considerable use in so distinguishing them. We shall find it convenient to set apart, as fallacies of confusion, those of which confusion is the most obvious characteristic, in which no other cause can be assigned for the mistake committed than neglect or inability to state the question properly and to apprehend the evidence with definiteness and precision. In the remaining four classes, I shall place not only the cases in which the evidence is clearly seen to be what it is, and yet a wrong conclusion drawn from it, but also those in which, although there be confusion, the confusion is not the sole cause of the error, but there is some shadow of a ground for it in the nature of the evidence itself. And in distributing these cases of partial confusion among the four classes, I shall, when there can be any hesitation as to the precise seat of the fallacy, suppose it to be in that part of the process in which, from the nature of the case and the tendencies of the human mind, an error would, in the particular circumstances, be the most probable. After these observations, we shall proceed without further preamble to consider the five classes in their order. End of section 73. Section 74 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 5, Chapter 3. Fallacies of Simple Inspection or A Priori Fallacies. Parts 1 through 5. Part 1. The tribe of errors of which we are to treat in the first instance are those in which no actual inference takes place at all. The proposition, it cannot in such cases be called a conclusion, being embraced, not as proved, but as requiring no proof, as a self-evident truth, or else as having such intrinsic verisimilitude that external evidence, not in itself amounting to proof, is sufficient in aid of the antecedent presumption. An attempt to treat this subject comprehensively would be a transgression of the bounds prescribed to this work, since it would necessitate the inquiry which, more than any other, is the grand question of what is called metaphysics, that is, what are the propositions which may reasonably be received without proof? That there must be some such propositions all are agreed, since there cannot be an infinite series of proof, a chain suspended from nothing. But to determine what these propositions are is the opus magnum of the more recondite mental philosophy. Two principal divisions of opinion on the subject have divided the schools of philosophy from its first dawn. The one recognizes no ultimate premises but the facts of our subjective consciousness, our sensations, emotions, intellectual states of mind, and volitions. These, and whatever by strict rules of induction can be derived from these, it is possible, according to this theory, for us to know. Of all else we must remain in ignorance. The opposite school hold that there are other existences suggested indeed to our minds by these subjective phenomena, but not inferable from them by any process either of deduction or of induction, which, however, we must by the constitution of our mental nature recognize as realities, and realities too of a higher order than the phenomena of our consciousness, being the efficient causes and necessary substrata of all phenomena. Among these entities they reckon substances, whether matter or spirit, from the dust under our feet to the soul, and from that to deity. All these, according to them, are preternatural or supernatural beings, having no likeness in experience, though experience is entirely a manifestation of their agency. Their existence, together with more or less of the laws to which they conform in their operations, are, on this theory, apprehended and recognized as real by the mind itself intuitively. Experience, whether in the form of sensation or of mental feeling, having no other part in the matter than as affording facts which are consistent with these necessary postulates of reason, and which are explained and accounted for by them. As it is foreign to the purpose of the present treatise to decide between these conflicting theories, we are precluded from inquiring into the existence or defining the extent and limits of knowledge a priori, and from characterizing the kind of correct assumption which the fallacy of incorrect assumption, now under consideration, simulates. Yet since it is allowed on both sides that such assumptions are often made improperly, we may find it practicable, without entering into the ultimate metaphysical grounds of the discussion, to state some speculative propositions and suggest some practical cautions respecting the forms in which such unwarranted assumptions are most likely to be made. Part 2. In the cases in which, according to the thinkers of the ontological school, the mind apprehends, by intuition, things and the laws of things not cognizable by our sensitive faculty, those intuitive or supposed intuitive perceptions are undistinguishable from what the opposite school are accustomed to call ideas of the mind. When they themselves say that they perceive the things by an immediate act of a faculty given for that purpose by their Creator, it would be said of them by their opponents that they find an idea or conception in their own minds, and from the idea or conception infer the existence of a corresponding objective reality. Nor would this be an unfair statement, but a mere version into other words of the account given by many of themselves, and one to which the more clear-sighted of them might, and generally do, without hesitation, subscribe. Since, therefore, in the cases which lay the strongest claims to be examples of knowledge a priori, the mind proceeds from the idea of a thing to the reality of the thing itself, we cannot be surprised by finding that illicit assumptions a priori consists in doing the same thing erroneously, in mistaking subjective facts for objective, laws of the percipient mind for laws of the perceived object, properties of the ideas or conceptions for properties of the things conceived. Accordingly, a large proportion of the erroneous thinking which exists in the world proceeds on a tacit assumption that the same order must obtain among the objects in nature which obtains among our ideas of them, that if we always think of two things together, the two things must always exist together, that if one thing makes us think of another as preceding or following it, that other must precede it or follow it in actual fact, and conversely, that when we cannot conceive two things together, they cannot exist together, and that their combination may, without further evidence, be rejected from the list of possible occurrences. Few persons, I am inclined to think, have reflected on the great extent to which this fallacy has prevailed and prevails in the actual beliefs and actions of mankind. For a first illustration of it, we may refer to a large class of popular superstitions. If any one will examine in what circumstances most of these things agree, which in different ages and by different portions of the human race have been considered as omens or prognostics of some interesting event, whether calamitous or fortunate, they will be found very generally characterized by this peculiarity, that they cause the mind to think of that, of which they are therefore supposed to forebode the actual occurrence. Talk of the devil and he will appear has passed into a proverb. Talk of the devil, that is, raise the idea, and the reality will follow. In times when the appearance of that personage in a visible form was thought to be no unfrequent occurrence, it has doubtless often happened to persons of vivid imagination and susceptible nerves that talking of the devil has caused them to fancy they saw him, as even in our more incredulous days, listening to ghost stories predisposes us to see ghosts, and thus, as a prop to the a priori fallacy, there might come to be added an auxiliary fallacy of malobservation, with one of false generalization grounded on it. Fallacies of different orders often heard or cluster together in this fashion, one smoothing the way for another. But the origin of the superstition is evidently that which we have assigned. In like manner, it has been universally considered unlucky to speak of misfortune. The day on which any calamity happened has been considered an unfortunate day, and there has been a feeling everywhere, and in some nations a religious obligation, against transacting any important business on that day. For on such a day our thoughts are likely to be of misfortune. For a similar reason, any untoward occurrence in commencing an undertaking has been considered ominous of failure, and often, doubtless, has really contributed to it by putting the persons engaged in the enterprise more or less out of spirits. But the belief has equally prevailed, where the disagreeable circumstance was, independently of superstition, too insignificant to depress the spirits by any influence of its own. All know the story of Caesar's accidentally stumbling in the act of landing on the African coast, and the presence of mind with which he converted the direful presage into a favourable one by exclaiming, "Africa, I embrace thee!" Such omens, it is true, were often conceived as warnings of the future, given by a friendly or a hostile deity. But this very superstition grew out of a pre-existing tendency. The god was supposed to send, as an indication of what was to come, something which people were already disposed to consider in that light. So in the case of lucky or unlucky names, Herodotus tells us how the Greeks, on the way to Mycale, were encouraged in their enterprise by the arrival of a deputation from Samos, one of the members of which was named Hegesistratus, the leader of armies. Cases may be pointed out in which something which could have no real effect but to make persons think of misfortune was regarded not merely as a prognostic, but as something approaching to an actual cause of it. The ephemi of the Greeks and favet linguis, or bona verba queso, of the Romans, evince the care with which they endeavoured to repress the utterance of any word expressive or suggestive of ill fortune, not from notions of delicate politeness, to which their general mode of conduct and feeling had very little reference, but from bona fide alarm lest the event so suggested to the imagination should in fact occur. Some vestige of a similar superstition has been known to exist among uneducated persons even in our own day. It is thought an unchristian thing to talk of or suppose the death of any person while he is alive. It is known how careful the Romans were to avoid, by an indirect mode of speech, the utterance of any word directly expressive of death or other calamity, how instead of mortis est, they said vixit, and, quote, be the event fortunate or otherwise, end quote, instead of adverse. The name maleventum, of which Salmasius so sagaciously detected the Thessalian origin, malois, maluentos, they changed into the highly propitious denomination beneventum, egesta into segesta and epidamnus, a name so interesting in its associations to the reader of Thucydides, they exchange for diracium, to escape the perils of a word suggestive of damnum, or detriment. Quote, if a hare cross the highway, says Sir Thomas Browne, there are few above 80 that are not perplexed thereat, which, notwithstanding, is but an augurial terror, according to that received expression, in auspicatum dat iter oblatus lepus. And the ground of the conceit was probably no greater than this, that a fearful animal passing by us portended unto us something to be feared, as upon the like consideration the meeting of a fox presaged some future imposture. End quote. Footnote. Vulgar Errors, Book 5, Chapter 21. End footnote. Such superstitions as these last must be the result of study. They are too recondite for natural or spontaneous growth. But when the attempt was once made to construct a science of predictions, any association, though ever so faint or remote, by which an object could be connected in however far-fetched a manner with ideas either of prosperity or of danger and misfortune, was enough to determine its being classed among good or evil omens. An example of rather a different kind from any of these, but falling under the same principle, is the famous attempt on which so much labour and ingenuity were expended by the alchemists to make gold potable. The motive to this was a conceit that potable gold could be no other than the universal medicine. And why gold? Because it was so precious. It must have all marvellous properties as a physical substance, because the mind was already accustomed to marvel at it. From a similar feeling, quote, every substance, says Dr. Paris, whose origin is involved in mystery, has at different times been eagerly applied to the purposes of medicine. Footnote. Pharmacologia, Historical Introduction, page 16. End footnote. Not long since, one of those showers which are now known to consist of the excrements of insects fell in the north of Italy. The inhabitants regarded it as manna, or some supernatural panacea, and they swallowed it with such avidity that it was only by extreme address that a small quantity was obtained for a chemical examination. End quote. The superstition in this instance, though doubtless partly of a religious character, probably in part also arose from the prejudice that a wonderful thing must, of course, have wonderful properties. Part 3. The instances of a priori fallacy which we have hitherto cited belong to the class of vulgar errors, and do not now, nor in any but a rude age ever could, impose upon minds of any considerable attainments. But those to which we are about to proceed have been and still are all but universally prevalent among thinkers. The same disposition to give objectivity to a law of the mind, to suppose that what is true of our ideas of things must be true of the things themselves, exhibits itself in many of the most accredited modes of philosophical investigation, both on physical and on metaphysical subjects. In one of its most undisguised manifestations, it embodies itself in two maxims which lay claim to axiomatic truth. Things which we cannot think of together cannot coexist, and things which we cannot help thinking of together must coexist. I am not sure that the maxims were ever expressed in these precise words, but the history both of philosophy and of popular opinions abounds with exemplifications of both forms of the doctrine. To begin with the latter of them, things which we cannot think of except together must exist together. This is assumed in the generally received and accredited mode of reasoning which concludes that A must accompany B in point of fact because, quote, it is involved in the idea, end quote. Such thinkers do not reflect that the idea, being a result of abstraction, ought to conform to the facts, and cannot make the facts conform to it. The argument is at most admissible as an appeal to authority, a surmise that what is now part of the idea must, before it became so, have been found by previous inquirers in the facts. Nevertheless, the philosopher who more than all others made professions of rejecting authority, Descartes, constructed his system on this very basis. His favourite device for arriving at truth, even in regard to outward things, was by looking into his own mind for it. Credidi me, says his celebrated maximum, pro regula generali sumere possa, omni e quod valde delucide e distincte concipibam verum esse. End quote. Whatever can be clearly conceived must certainly exist. That is, as he afterwards explains it, if the idea includes existence. And on this ground he infers that geometrical figures really exist because they can be distinctly conceived. Whenever existence is involved in an idea, a thing conformable to the idea must really exist, which is as much as to say whatever the idea contains must have its equivalent in the thing, and what we are not able to leave out of the idea cannot be absent from the reality. Footnote. The author of one of the Bridgewater treatises has fallen, as it seems to me, into a similar fallacy when, after arguing in rather a curious way to prove that matter may exist without any of the known properties of matter, and may therefore be changeable, he concludes that it cannot be eternal because, quote, eternal, passive existence necessarily involves incapability of change, end quote. I believe it would be difficult to point out any other connection between the facts of eternity and unchangeableness than a strong association between the two ideas. Most of the a priori arguments, both religious and anti-religious, on the origin of things are fallacies drawn from the same source. End footnote. This assumption pervades the philosophy not only of Descartes, but of all the thinkers who received their impulse mainly from him, in particular the two most remarkable among them, Spinoza and Leibniz, from whom the modern German metaphysical philosophy is essentially an emanation. I am indeed disposed to think that the fallacy now under consideration has been the cause of 2/3 of the bad philosophy, and especially of the bad metaphysics, which the human mind has never ceased to produce. Our general ideas contain nothing but what has been put into them, either by our passive experience or by our active habits of thought, and the metaphysicians in all ages who have attempted to construct the laws of the universe by reasoning from our supposed necessities of thought have always proceeded, and only could proceed, by laboriously finding in their own minds what they themselves had formerly put there, and evolving from their ideas of things what they had first involved in those ideas. In this way, all deeply rooted opinions and feelings are enabled to create apparent demonstrations of their truth and reasonableness, as it were, out of their own substance. The other form of the fallacy, things which we cannot think of together cannot exist together, including, as one of its branches, that what we cannot think of as existing cannot exist at all, may thus be briefly expressed: whatever is inconceivable must be false. Against this prevalent doctrine I have sufficiently argued in a former book, and nothing is required in this place but examples. Footnote: see section 24 of this work, Book 2, Chapter 5, Part 6, also section 26, Book 2, Chapter 7, Parts 1, 2, and 3, also section 27, Book 2, Chapter 7, Part 4. See also Examination of Sir William Hamilton's Philosophy, Chapter 6, and elsewhere. End footnote. It was long held that antipodes were impossible because of the difficulty which was found in conceiving persons with their heads in the same direction as our feet, and it was one of the received arguments against the Copernican system that we cannot conceive so great a void space as that system supposes to exist in the celestial regions. When men's imaginations had always been used to conceive the stars as firmly set in solid spheres, they naturally found much difficulty in imagining them in so different, and, as it doubtless appeared to them, so precarious a situation. But they had no right to mistake the limitation, whether natural or, as in fact proved only artificial, of their own faculties, for an inherent limitation of the possible modes of existence in the universe. It may be said in objection that the error in these cases was in the minor premise, not the major, an error of fact, not of principle, that it did not consist in supposing that what is inconceivable cannot be true, but in supposing antipodes to be inconceivable, when present experience proves that they can be conceived. Even if this objection were allowed, and the proposition that what is inconceivable cannot be true were suffered to remain unquestioned as a speculative truth, it would be a truth on which no practical consequence could ever be founded, since on this showing it is impossible to affirm of any proposition not being a contradiction in terms that is inconceivable. Antipodes were really, not fictitiously, inconceivable to our ancestors. They are indeed conceivable to us, and as the limits of our power of conception have been so largely extended by the extension of our experience and the more varied exercise of our imagination, so may posterity find many combinations perfectly conceivable to them which are inconceivable to us. But as beings of limited experience, we must always and necessarily have limited conceptive powers, while it does not by any means follow that the same limitation obtains in the possibilities of nature, nor even in her actual manifestations. Rather more than a century and a half ago, it was a scientific maxim, disputed by no one, and which no one deemed to require any proof, that, quote, a thing cannot act where it is not. End quote. Footnote. It seems that this doctrine was, before the time I have mentioned, disputed by some thinkers. Dr. Ward mentions Scotus, Vasquez, Biel, Francis Lugo, and Valencia. End footnote. With this weapon the Cartesians waged a formidable war against the theory of gravitation, which, according to them, involving so obvious an absurdity, must be rejected in limine. The sun could not possibly act upon the earth, not being there. It was not surprising that the adherents of the old systems of astronomy should urge this objection against the new. but the false assumption imposed equally on Newton himself, who, in order to turn the edge of the objection, imagined a subtle ether which filled up the space between the sun and the earth, and by its intermediate agency was the proximate cause of the phenomena of gravitation. Quote, "It is inconceivable," said Newton in one of his letters to Dr. Bentley, "that inanimate brute matter should, without the mediation of something else which is not material, operate upon and affect other matter without mutual contact, that gravity should be innate, inherent, and essential to matter, so that one body may act on another at a distance through a vacuum without the mediation of anything else, by and through which their action and force may be conveyed from one to another, is to me so great an absurdity that I believe no man who in philosophical matters has a competent faculty of thinking can ever fall into it." End quote. Footnote. I quote this passage from Playfair's celebrated Dissertation on the Progress of Mathematical and Physical Science. End footnote. This passage should be hung up in the cabinet of every cultivator of science who is ever tempted to pronounce a fact impossible because it appears to him inconceivable. In our own day, one would be more tempted, though with equal injustice, to reverse the concluding observation and consider the seeing any absurdity at all in a thing so simple and natural to be what really marks the absence of a competent faculty of thinking. No one now feels any difficulty in conceiving gravity to be, as much as any other property is, inherent and essential to matter, nor finds the comprehension of it facilitated in the smallest degree by the supposition of an ether, though some recent inquirers do give this as an explanation of it, nor thinks it at all incredible that the celestial bodies can and do act where they, in actual bodily presence, are not. To us it is not more wonderful that bodies should act upon one another without mutual contact than that they should do so when in contact. We are familiar with both these facts, and we find them equally inexplicable, but equally easy to believe. To Newton, the one, because his imagination was familiar with it, appeared natural and a matter of course, while the other, for the contrary reason, seemed too absurd to be credited. It is strange that anyone, after such a warning, should rely implicitly on the evidence a priori of such propositions as these, that matter cannot think, that space or extension is infinite, that nothing can be made out of nothing, ex nihilo nihili fit. Whether these propositions are true or not, this is not the place to determine, nor even whether the questions are soluble by the human faculties. But such doctrines are no more self-evident truths than the ancient maxim that a thing cannot act where it is not, which probably is not now believed by any educated person in Europe. Footnote. This statement I must now correct as too unqualified. The maxim in question was maintained with full conviction by no less an authority than Sir William Hamilton. See my Examination, chapter 24. End footnote. Matter cannot think. Why? Because we cannot conceive thought to be annexed to any arrangement of material particles. Space is infinite, because, having never known any part of it which had not other parts beyond it, we cannot conceive an absolute termination. Ex nihilo nihil fit, because, having never known any physical product without a pre-existing physical material, we cannot, or think we cannot, imagine a creation out of nothing. But these things may in themselves be as conceivable as gravitation without an intervening medium, which Newton thought too great an absurdity for any person of a competent faculty of philosophical thinking to admit. And even supposing them not conceivable, this for aught we know, may be merely one of the limitations of our very limited minds, and not in nature at all. No writer has more directly identified himself with the fallacy now under consideration, or has embodied it in more distinct terms than Leibniz. In his view, unless a thing was not merely conceivable, but even explainable, it could not exist in nature. All natural phenomena, according to him, must be susceptible of being accounted for a priori. The only facts of which no explanation could be given but the will of God were miracles properly so called. Quote, Je reconnais, says he, qu'il n'est pas permis de nier ce qu'on n'entend pas, mais j'ajoute qu'on a droit de nier, au moins dans l'ordre naturel, ce que absolument n'est point intelligible ni explicable. Je soutiens aussi que, enfin, la conception des créatures n'est pas la mesure du pouvoir de Dieu, mais que leur conceptivité, ou force de concevoir, est la mesure du pouvoir de la nature. Tout ce qui est conformé à l'ordre naturel pouvant être conçu ou entendu par quelque créature. Footnote. Nouveau essai sur l'entendement humain. Avant-propos. Works. Paris edition, 1842, volume 1, page 19. End footnote. Not content with assuming that nothing can be true which we are unable to conceive, scientific inquirers have frequently given a still further extension to the doctrine, and held that, even of things not altogether inconceivable, that which we can conceive with the greatest ease is likeliest to be true. It was long an admitted axiom, and is not yet entirely discredited, that nature always acts by the simplest means, that is, by those which are most easily conceivable. Footnote. This doctrine also was accepted as true, and conclusions were grounded on it by Sir William Hamilton. See An Examination of Sir William Hamilton's Philosophy and of the Principal Philosophical Questions discussed in his Writings, by John Stuart Mill. Chapter 24. End footnote. A large proportion of all the errors ever committed in the investigation of the laws of nature have arisen from the assumption that the most familiar explanation or hypothesis must be the truest. One of the most instructive facts in scientific history is the pertinacity with which the human mind clung to the belief that the heavenly bodies must move in circles, or be carried round by the revolution of spheres, merely because those were in themselves the simplest suppositions, though, to make them accord with the facts which were ever contradicting them more and more, it became necessary to add sphere to sphere and circle to circle, until the original simplicity was converted into almost inextricable complication. Part 4. We pass to another a priori fallacy or natural prejudice allied to the former, and originating, as that does, in the tendency to presume an exact correspondence between the laws of the mind and those of things external to it. The fallacy may be enunciated in this general form. Whatever can be thought of apart exists apart, and its most remarkable manifestation consists in the personification of abstractions. Mankind in all ages have had a strong propensity to conclude that wherever there is a name, there must be a distinguishable separate entity corresponding to the name, and every complex idea which the mind has formed for itself by operating upon its conceptions of individual things was considered to have an outward objective reality answering to it. Fate, chance, nature, time, space were real beings, nay, even gods. If the analysis of qualities in the earlier part of this work be correct, names of qualities and names of substances stand for the very same sets of facts or phenomena. Whiteness and a white thing are only different phrases required by convenience for speaking of the same external fact under different relations. Not such, however, was the notion which this verbal distinction suggested of old, either to the vulgar or to the scientific. Whiteness was an entity, inhering or sticking in the white substance, and so of all other qualities. So far was this carried that even concrete general terms were supposed to be not names of indefinite numbers of individual substances, but names of a peculiar kind of entities termed universal substances. Because we can think and speak of man in general, that is, of all persons in so far as possessing the common attributes of the species, without fastening our thoughts permanently on some one individual person, therefore man in general was supposed to be not an aggregate of individual persons, but an abstract or universal man, distinct from these. It may be imagined what havoc metaphysicians trained in these habits made with philosophy when they came to the largest generalizations of all. Substantiae secundae of any kind were bad enough, but such substantiae secundae as to on, for example, and to en, standing for peculiar entities supposed to be inherent in all things which exist, or in all which are said to be one, were enough to put an end to all intelligible discussion. Especially since, with a just perception that the truths which philosophy pursues are general truths, it was soon laid down that these general substances were the only subjects of science, being immutable, while individual substances, cognizable by the senses, being in a perpetual flux, could not be the subject of real knowledge. This misapprehension of the import of general language constitutes mysticism, a word so much oftener written and spoken than understood. Whether in the Vedas, in the Platonists, or in the Hegelians, mysticism is neither more nor less than ascribing objective existence to the subjective creations of our own faculties, to ideas or feelings of the mind, and believing that by watching and contemplating these ideas of its own making, it can read in them what takes place in the world without. Part 5. Proceeding with the enumeration of a priori fallacies, and endeavouring to arrange them with as much reference as possible to their natural affinities, we come to another, which is also nearly allied to the fallacy preceding the last, standing in the same relation to one variety of it as the fallacy last mentioned does to the other. This too represents nature as under incapacities corresponding to those of our intellect, but instead of only asserting that nature cannot do a thing because we cannot conceive it done, goes the still greater length of averring that nature does a particular thing on the sole ground that we can see no reason why she should not. Absurd as this seems, when so plainly stated, it is a received principle among scientific authorities for demonstrating a priori the laws of physical phenomena. A phenomenon must follow a certain law, because we see no reason why it should deviate from that law in one way rather than another. This is called the principle of the sufficient reason, and by means of it philosophers often flatter themselves that they are able to establish, without any appeal to experience, the most general truths of experimental physics. Footnote: not that of Leibniz, but the principle commonly appealed to under that name by mathematicians. End footnote. Take, for example, two of the most elementary of all laws, the law of inertia and the first law of motion. A body at rest cannot, it is affirmed, begin to move unless acted upon by some external force, because if it did, it must either move up or down, forward or backward, and so forth. But if no outward force acts upon it, there can be no reason for its moving up rather than down, or down rather than up, and so on. Therefore, it will not move at all. This reasoning I conceive to be entirely fallacious, as indeed Dr. Brown in his treatise on Cause and Effect has shown with great acuteness and justness of thought. We have before remarked that almost every fallacy may be referred to a different genera by different modes of filling up the suppressed steps, and this particular one may, at our option, be brought under petitio principii. It supposes that nothing can be a sufficient reason for a body's moving in one particular direction except some external force. But this is the very thing to be proved. Why not some internal force? Why not the law of the thing's own nature? Since these philosophers think it necessary to prove the law of inertia, they of course do not suppose it to be self-evident. They must therefore be of opinion that previously to all proof the supposition of a body's moving by internal impulse is an admissible hypothesis. But if so, why is not the hypothesis also admissible that the internal impulse acts naturally in some one particular direction, not in another? If spontaneous motion might have been the law of matter, why not spontaneous motion toward the sun, toward the earth, or toward the zenith? Why not, as the ancients supposed, toward a particular place in the universe appropriated to each particular kind of substance? Surely it is not allowable to say that spontaneity of motion is credible in itself, but not credible if supposed to take place in any determinate direction. Indeed, if anyone chose to assert that all bodies when uncontrolled set out in a direct line toward the North Pole, he might equally prove his point by the principle of the sufficient reason. By what right is it assumed that a state of rest is the particular state which cannot be deviated from without special cause? Why not a state of motion, and of some particular sort of motion? Why may we not say that the natural state of a horse left to himself is to amble, because otherwise he must either trot, gallop, or stand still, and because we know no reason why he should do one of these rather than another? If this is to be called an unfair use of the sufficient reason, and the other a fair one, there must be a tacit assumption that a state of rest is more natural to a horse than a state of ambling. If this means that it is the state which the animal will assume when left to himself, that is the very point to be proved. And if it does not mean this, it can only mean that a state of rest is the simplest state, and therefore the most likely to prevail in nature, which is one of the fallacies or natural prejudices we have already examined. So again of the first law of motion, that a body once moving will, if left to itself, continue to move uniformly in a straight line. An attempt is made to prove this law by saying that if not, the body must deviate either to the right or to the left, and that there is no reason why it should do one more than the other. But who could know antecedently to experience whether there was a reason or not? Might it not be the nature of bodies, or of some particular bodies, to deviate toward the right, or if the supposition is preferred, toward the east or south? It was long thought that bodies, terrestrial ones at least, had a natural tendency to deflect downward, and there is no shadow of anything objectionable in the supposition, except that it is not true. The pretended proof of the law of motion is even more manifestly untenable than that of the law of inertia, for it is flagrantly inconsistent. It assumes that the continuance of motion in the direction first taken is more natural than deviation either to the right or to the left, but denies that one of these can possibly be more natural than the other. All these fancies of the possibility of knowing what is natural or not natural by any other means than experience are, in truth, entirely futile. The real and only proof of the laws of motion or of any other law of the universe is experience. It is simply that no other suppositions explain or are consistent with the facts of universal nature. Geometers have, in all ages, been open to the imputation of endeavouring to prove the most general facts of the outward world by sophistical reasoning, in order to avoid appeals to the senses. Archimedes, says Professor Playfair, established some of the elementary propositions of statics by a process in which he, quote, borrows no principle from experiment, but establishes conclusion entirely by reasoning a priori. He assumes, indeed, that equal bodies at the ends of the equal arms of a lever will balance one another, and also that a cylinder or parallelepiped of homogeneous matter will be balanced about its centre of magnitude. These, however, are not inferences from experience. They are, properly speaking, conclusions deduced from the principle of the sufficient reason. End quote. Footnote. Dissertation on the progress of mathematical and physical science since the revival of learning in Europe, page 27. End footnote. And to this day, there are few geometers who would not think it far more scientific to establish these or any other premises in this way, than to rest their evidence on that familiar experience which, in the case in question, might have been so safely appealed to. End of section 74. Section 75 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 5, Chapter 3, Fallacies of Simple Inspection, or A Priori Fallacies, Parts 6 through 8. Part 6. Another natural prejudice of most extensive prevalence, and which had a great share in producing the errors fallen into by the ancients in their physical inquiries, was this: that the differences in nature must correspond to our received distinctions, that effects which we are accustomed, in popular language, to call by different names and arrange in different classes, must be of different natures and have different causes. This prejudice, so evidently of the same origin with those already treated of, marks more especially the earliest stage of science, when it has not yet broken loose from the trammels of everyday phraseology. The extraordinary prevalence of the fallacy among the Greek philosophers may be accounted for by their generally knowing no other language than their own, from which it was a consequence that their ideas followed the accidental or arbitrary combinations of that language more completely than can happen among the moderns to any but illiterate persons. They had great difficulty in distinguishing between things which their language confounded, or in putting mentally together things which it distinguished, and could hardly combine the objects in nature into any classes but those which were made for them by the popular phrases of their own country, or at least could not help fancying those classes to be natural and all others arbitrary and artificial. Accordingly, scientific investigation among the Greek schools of speculation and their followers in the Middle Ages was little more than a mere sifting and analysing of the notions attached to common language. They thought that by determining the meaning of words they could become acquainted with facts. Quote, "They took for granted," says Dr. Whewell, "that philosophy must result from the relations of those notions which are involved in the common use of language, and they proceeded to seek it by studying such notions." End quote. Footnote. History of Scientific Ideas by William Whewell, Book 1, Chapter 1. End footnote. In his next chapter, Dr. Whewell has so well illustrated and exemplified this error that I shall take the liberty of quoting him at some length. Quote, "The propensity to seek for principles in the common usages of language may be discerned at a very early period. Thus, we have an example of it in a saying which is reported of Thales, the founder of Greek philosophy. When he was asked, 'What is the greatest thing?' he replied, "Place, for all other things are in the world, but the world is in it." In Aristotle, we have the consummation of this mode of speculation. The usual point from which he starts in his inquiries is that we say thus or thus in common language. Thus, when he has to discuss the question whether there be in any part of the universe a void or space in which there is nothing, he inquires first in how many senses we say that one thing is in another. He enumerates many of these. We say the part is in the whole, as the finger is in the hand. Again, we say the species is in the genus, as man is included in animal. Again, the government of Greece is in the king, and various other senses are described and exemplified. But of all these, the most proper is when we say a thing is in a vessel and generally in place. He next examines what place is, and comes to this conclusion, that if about a body there be another body including it, it is in place, and if not, not. A body moves when it changes its place. But he adds that if water be in a vessel, the vessel being at rest, the parts of the water may still move, for they are included by each other, so that while the whole does not change its place, the parts may change their place in a circular order. Proceeding then to the question of a void, he as usual examines the different senses in which the term is used, and adopts as the most proper place without matter, with no useful result. Again, in a question concerning mechanical action, he says, "When a man moves a stone by pushing it with a stick, we say both that the man moves the stone and that the stick moves the stone, but the latter more properly." Again, we find the Greek philosophers applying themselves to extract their dogmas from the most general and abstract notions which they could detect. For example, from the conception of the universe as one, or as many things. They tried to determine how far we may, or must, combine with these conceptions that of a whole, of parts, of number, of limits, of place, of beginning or end, of full or void, of rest or motion, of cause and effect, and the like. The analysis of such conceptions with such a view occupies, for instance, almost the whole of Aristotle's treatise on the heavens. End quote. The following paragraph merits particular attention. Quote, "Another mode of reasoning very widely applied in these attempts was the doctrine of contrarieties, in which it was assumed that adjectives or substances which are in common language or in some abstract mode of conception opposed to each other must point at some fundamental antithesis in nature, which it is important to study. Thus Aristotle says that the Pythagoreans, from the contrasts which number suggests, collected 10 principles, limited and unlimited, odd and even, one and many, right and left, male and female, rest and motion, straight and curved, light and darkness, good and evil, square and oblong. Aristotle himself deduced the doctrine of 4 elements and other dogmas by oppositions of the same kind." End quote. Of the manner in which, from premises obtained in this way, the ancients attempted to deduce laws of nature, an example is given in the same work a few pages further on. Quote, "Aristotle decides that there is no void on such arguments as this. In a void there could be no difference of up and down, for as in nothing there are no differences, so there are none in a privation or negation. But a void is merely a privation or negation of matter. Therefore, in a void, bodies could not move up and down, which it is in their nature to do. It is easily seen." End quote. Dr. Werrell very justly adds, quote, that such a mode of reasoning elevates the familiar forms of language and the intellectual connections of terms to a supremacy over facts, making truth depend upon whether terms are or are not privative, and whether we say that bodies fall naturally. End quote. The propensity to assume that the same relations obtain between objects themselves, which obtain between our ideas of them, is here seen in the extreme stage of its development. For the mode of philosophizing, exemplified in the foregoing instances, assumes no less than the proper way of arriving at knowledge of nature is to study nature itself subjectively, to apply our observation and analysis not to the facts, but to the common notions entertained of the facts. Many other equally striking examples may be given of the tendency to assume that things which, for the convenience of common life, are placed in different classes, must differ in every respect. Of this nature was the universal and deeply rooted prejudice of antiquity and the Middle Ages, that celestial and terrestrial phenomena must be essentially different and could in no manner or degree depend on the same laws. Of the same kind, also, was the prejudice against which Bacon contended that nothing produced by nature could be successfully imitated by man. Quote, calorem solis et ignis toto genere differi, nisilicet hominis putent se per opera ignis a liquid simili eius cae in natura fuunt, eduter et formere posse. End quote. And again, quote, compositionem tantum opus hominis mistionem vero opus solius naturae esse, nisilicet hominis sperenta liquam ex arte corporum naturalium generationem aut transformationem. End quote. Footnote. Novum Organum Aphorisms Concerning the Interpretation of Nature and the Kingdom of Man. 75. End footnote. The grand distinction in the ancient scientific speculations between natural and violent motions, though not without a plausible foundation in the appearances themselves, was doubtless greatly recommended to adoption by its conformity to this prejudice. Part 7. From the fundamental error of the scientific inquirers of antiquity, we pass by a natural association to a scarcely less fundamental one of their great rival and successor, Bacon. It has excited the surprise of philosophers that the detailed system of inductive logic which this extraordinary man laboured to construct has been turned to so little direct use by subsequent inquirers, having neither continued, except in a few of its generalities, to be recognized as a theory, nor having conducted in practice to any great scientific results. But this, though not unfrequently remarked, has scarcely received any plausible explanation, and some indeed have preferred to assert that all rules of induction are useless, rather than suppose that Bacon's rules are grounded on an insufficient analysis of the inductive process. Such, however, will be seen to be the fact, as soon as it is considered, that Bacon entirely overlooked plurality of causes. All his rules tacitly imply the assumption, so contrary to all we now know of nature, that a phenomenon cannot have more than one cause. When he is inquiring into what he terms the form calidi aut frigidi, gravis aut levis, sicci aut humidi, and the like, he never for an instant doubts that there is some one thing, some invariable condition or set of conditions, which is present in all cases of heat or cold, or whatever other phenomenon he is considering, the only difficulty being to find what it is, which accordingly he tries to do so by a process of elimination, rejecting or excluding by negative instances whatever is not the forma or cause, in order to arrive at what it is. but that this former or cause is one thing, and that it is the same in all hot objects, he has no more doubt of than another person has that there is always some cause or other. In the present state of knowledge it could not be necessary, even if we had not already treated so fully of the question, to point out how widely this supposition is at variance with the truth. It is particularly unfortunate for Bacon that, falling into this error, he should have fixed almost exclusively upon a class of inquiries in which it was especially fatal, namely, inquiries into the causes of the sensible qualities of objects, for his assumption, groundless in every case, is false in a peculiar degree with respect to those sensible qualities. In regard to scarcely any of them has it been found possible to trace any unity of cause, any set of conditions invariably accompanying the quality. The conjunctions of such qualities with one another constitute the variety of kinds, in which, as already remarked, it has not been found possible to trace any law. Bacon was seeking for what did not exist. The phenomenon of which he sought for the one cause has oftenest no cause at all, and when it has, depends, as far as hitherto ascertained, on an unassignable variety of distinct causes. And on this rock every one must split, who represents to himself as the first and fundamental problem of science to ascertain what is the cause of a given effect, rather than what are the effects of a given cause. It was shown in an early stage of our inquiry into the nature of induction how much more ample are the resources which science commands for the latter than for the former inquiry, since it is upon the latter only that we can throw any direct light by means of experiment, the power of artificially producing an effect implying a previous knowledge of at least one of its causes. Footnote. See section 37 of this work, Book 3, Chapter 7, Part 4. End footnote. If we discover the causes of effects, it is generally by having previously discovered the effects of causes. The greatest skill in devising crucial instances for the former purpose may only end, as Bacon's physical inquiries did, in no result at all. Was it that his eagerness to acquire the power of producing for man's benefit effects of practical importance to human life, rendering him impatient of pursuing that end by a circuitous route, made even him the champion of experiment, preferring the direct mode, though one of mere observation, to the indirect, in which alone experiment was possible? Or had even Bacon not entirely cleared his mind from the notion of the ancients that rerum cognoscere causas was the sole object of philosophy, and that to inquire into the effects of things belonged to servile and mechanical arts? It is worth remarking that, while the only efficient mode of cultivating speculative science was missed from an undue contempt of manual operations, the false speculative views thus engendered gave in their turn a false direction to such practical and mechanical aims as were suffered to exist. The assumption universal among the ancients and in the Middle Ages that they were principles of heat and cold, dryness and moisture, and so on, led directly to a belief in alchemy, in a transmutation of substances, a change from one kind into another. Why should it not be possible to make gold? Each of the characteristic properties of gold has its forma, its essence, its set of conditions, which, if we could discover and learn how to realize, we could superinduce that particular property upon any other substance, upon wood, or iron, or lime, or clay. If then we could effect this with respect to every one of the essential properties of the precious metal, we should have converted the other substance into gold. Nor did this, if once the premises were granted, appear to transcend the real powers of mankind. for daily experience showed that almost every one of the distinctive sensible properties of any object, its consistence, its color, its taste, its smell, its shape, admitted of being totally changed by fire or water or some other chemical agent. The forme of all those qualities seeming, therefore, to be within human power either to produce or to annihilate, not only did the transmutation of substances appear abstractedly possible, but the employment of the power at our choice for practical ends seemed by no means hopeless. Footnote. It is hardly needful to remark that nothing is here intended to be said against the possibility at some future period of making gold, by first discovering it to be a compound and putting together its different elements or ingredients. But this is a totally different idea from that of the seekers of the Grand Arcanum. End footnote. A prejudice universal in the ancient world, and from which Bacon was so far from being free, that it pervaded and vitiated the whole practical part of his system of logic, may with good reason be ranked high in the order of fallacies of which we are now treating. Part 8. There remains one a priori fallacy or natural prejudice, the most deeply rooted, perhaps, of all which we have enumerated, one which not only reigns supreme in the ancient world, but still possesses almost undisputed dominion over many of the most cultivated minds, and some of the most remarkable of the numerous instances by which I shall think it necessary to exemplify it will be taken from recent thinkers. This is, that the conditions of a phenomenon must, or at least probably will, resemble the phenomenon itself. Conformably to what we have before remarked to be of frequent occurrence, this fallacy might, without much impropriety, have been placed in a different class among fallacies of generalization, for experience does afford a certain degree of countenance to the assumption. The cause does, in very many cases, resemble its effect. Like produces like. Many phenomena have a direct tendency to perpetuate their own existence, or to give rise to other phenomena similar to themselves, not to mention forms actually moulded on one another, as impressions on wax and the like, in which the closest resemblance between the effect and its cause is the very law of the phenomenon. All motion tends to continue itself with its own velocity, and in its own original direction, and the motion of one body tends to set others in motion, which is indeed the most common of the modes in which the motions of bodies originate. We need scarcely refer to contagion, fermentation, and the like, or to the production of effects by the growth or expansion of a germ or rudiment resembling on a smaller scale the completed phenomenon, as in the growth of a plant or animal from an embryo, that embryo itself deriving its origin from another plant or animal of the same kind. Again, the thoughts or reminiscences which are effects of our past sensations resemble those sensations. Feelings produce similar feelings by way of sympathy. Acts produce similar acts by involuntary or voluntary imitation. With so many appearances in its favour, no wonder if a presumption naturally grew up that causes must necessarily resemble their effects, and that like could only be produced by like. This principle of fallacy has usually presided over the fantastical attempts to influence the course of nature by conjectural means, the choice of which was not directed by previous observation and experiment. The guess almost always fixed upon some means which possessed features of real or apparent resemblance to the end in view. If a charm was wanted, as by Ovid's Medea, to prolong life, all long-lived animals, or what were esteemed such, were collected and brewed into a broth. Nec defuit illic squamia ginifae tenuis membrana celidrae, vivacisque jecur cervi cibus in super adit ora caput novem conicis saecula passae. A similar notion was embodied in the celebrated medical theory called the doctrine of signatures, quote, which is no less, says Dr. Paris, than a belief that every natural substance which possesses any medicinal virtue indicates by an obvious and well-marked external character the disease for which it is a remedy, or the object for which it should be employed. End quote. Footnote: Pharmacologia, pages 43 through 45. End footnote. This outward character was generally some feature of resemblance, real or fantastical, either to the effect it was supposed to produce or to the phenomenon over which its power was thought to be exercised. Quote, thus the lungs of a fox must be a specific for asthma, because that animal is remarkable for its strong powers of respiration. Turmeric has a brilliant yellow colour, which indicates that it has the power of curing the jaundice. For the same reason, poppies must relieve diseases of the head, agaricus those of the bladder, cassia fistula the affections of the intestines, and aristolochia the disorders of the uterus. The polished surface and stony hardness which so eminently characterize the seeds of Lithospermum officinale, common Cromwell, were deemed a certain indication of their efficacy in calculus and gravelly disorders. For a similar reason, the roots of the Saxifraga granulata, white saxifrage, gained reputation in the cure of the same disease, and the euphrasia, eyebright, acquired fame as an application in complaints of the eye, because it exhibits a black spot in its corolla resembling the pupil. The bloodstone, the heliotropium of the ancients, from the occasional small specks or points of a blood-red colour exhibited on its green surface, is even at this very day employed in many parts of England and Scotland to stop a bleeding from the nose, and nettle tea continues a popular remedy for the cure of urticaria. It is also asserted that some substances bear the signatures of the humours, as the petals of the red rose that of the blood, and the roots of rhubarb and the flowers of saffron that of the bile. End quote. The early speculations respecting the chemical composition of bodies were rendered abortive by no circumstance more than by their invariably taking for granted that the properties of the elements must resemble those of the compounds which were formed from them. To descend to more modern instances, it was long thought, and was stoutly maintained by the Cartesians and even by Leibniz against the Newtonian system, nor did Newton himself, as we have seen, contest the assumption, but eluded it by an arbitrary hypothesis, that nothing, of a physical nature at least, could account for motion except previous motion, the impulse or impact of some other body. It was very long before the scientific world could prevail upon itself to admit attraction and repulsion, that is, spontaneous tendencies of particles to approach or recede from one another, as ultimate laws, no more requiring to be accounted for than impulse itself, if indeed the latter were not in truth resolvable into the former. From the same source arose the innumerable hypotheses devised to explain those classes of motion which appeared more mysterious than others, because there was no obvious mode of attributing them to impulse, as, for example, the voluntary motions of the human body. Such were the interminable systems of vibrations propagated along the nerves, or animal spirits rushing up and down between the muscles and the brain, which, if the facts could have been proved, would have been an important addition to our knowledge of physiological laws. But the mere invention or arbitrary supposition of them could not, unless by the strongest delusion, be supposed to render the phenomenon of animal life more comprehensible or less mysterious. Nothing, however, seemed satisfactory but to make out that motion was caused by motion, by something like itself. If it was not one kind of motion, it must be another. In like manner, it was supposed that the physical qualities of objects must arise from some similar quality, or perhaps only some quality bearing the same name, in the particles of atoms of which the objects were composed. That a sharp taste, for example, must arise from sharp particles, and reversing the inference, the effects produced by a phenomenon must, it was supposed, resemble in their physical attributes the phenomenon itself. The influences of the planets were supposed to be analogous to their visible peculiarities. Mars, being of a red colour, portended fire and slaughter, and the like. Passing from physics to metaphysics, we may notice among the most remarkable fruits of this a priori fallacy two closely analogous theories, employed in ancient and modern times to bridge over the chasm between the world of mind and that of matter: the species sensibilis of the Epicureans, and the modern doctrine of perception by means of ideas. These theories are indeed probably indebted for their existence not solely to the fallacy in question, but to that fallacy combined with another natural prejudice already adverted to, that a thing cannot act where it is not. In both doctrines it is assumed that the phenomenon which takes place in us when we see or touch an object, and which we regard as an effect of that object, or rather of its presence to our organs, must of necessity resemble very closely the outward object itself. To fulfill this condition, the Epicureans supposed that objects were constantly projecting in all directions impalpable images of themselves, which entered at the eyes and penetrated to the mind, while modern metaphysicians, though they rejected this hypothesis, agreed in deeming it necessary to suppose that not the thing itself, but a mental image or representation of it, was the direct object of perceptions. Dr. Reid had to employ a world of argument and illustration to familiarize people with the truth, that the sensations or impressions on our minds need not necessarily be copies of, or bear any resemblance to, the causes which produce them, in opposition to the natural prejudice which led people to assimilate the action of bodies upon our senses, and through them upon our minds, to the transfer of a given form from one object to another by actual moulding. The works of Dr. Reid are even now the most effectual course of study for detaching the mind from the prejudice of which this was an example, and the value of the service which he thus rendered to popular philosophy is not much diminished, although we may hold with Brown that he went too far in imputing the ideal theory as an actual tenet to the generality of the philosophers who preceded him, and especially to Locke and Hume, for if they did not themselves consciously fall into the error, unquestionably they often led their readers into it. The prejudice that the conditions of a phenomenon must resemble the phenomenon is occasionally exaggerated, at least verbally, into a still more palpable absurdity. The conditions of the things are spoken of as if they were the very thing itself. In Bacon's model inquiry, which occupies so great a space in the Novum Organum, the Inquisitio in Formam Calidi, the conclusion which he favours is that heat is a kind of motion, meaning, of course, not the feeling of heat, but the conditions of the feeling, meaning, therefore, only that wherever there is heat, there must first be a particular kind of motion. But he makes no distinction in his language between these two ideas, expressing himself as if heat and the conditions of heat were one and the same thing. So the elder Darwin, in the beginning of his Zoonomia, says, quote, "The word idea has various meanings in the writers of metaphysics, it is here used simply for those notions of external things which our organs of sense bring us acquainted with originally." End quote. Thus far the proposition, though vague, is unexceptionable in meaning. Quote, "and is defined a contraction, a motion, or configuration of the fibres which constitute the immediate organ of sense." End quote. Our notions, a configuration of the fibres? What kind of logician must he be who thinks that a phenomenon is defined to be the condition on which he supposes it to depend? Accordingly, he says soon after, not that our ideas are caused by or consequent on certain organic phenomena, but, quote, "our ideas are animal motions of the organs of sense." End quote. And this confusion runs through the 4 volumes of the Zoonomia. The reader never knows whether the writer is speaking of the effect or of its supposed cause, of the idea, a state of mental consciousness, or of the state of the nerves and brain which he considers it to presuppose. I have given a variety of instances in which the natural prejudice that causes and their effects must resemble one another has operated in practice so as to give rise to serious errors. I shall now go further and produce from writings, even of the present or very recent times, instances in which this prejudice is laid down as an established principle. M. Victor Cousin, in the last of his celebrated lectures on Locke, enunciates the maxim in the following unqualified terms. Quote, "Tout ce qui est vrai de l'effet est vrai de la cause." End quote. A doctrine to which, unless in some peculiar and technical meaning of the words cause and effect, it is not to be imagined that any person would literally adhere. But he who could so write must be far enough from seeing that the very reverse might be the effect, that there is nothing impossible in the supposition that no one property which is true of the effect might be true of the cause. Without going quite so far in point of expression, Coleridge, in his Biographia Literaria, affirms as an evident truth that, quote, "the law of causality holds only between homogeneous things, that is, things having some common property, and therefore cannot extend from one world into another its opposite." End quote. Hence, as mind and matter have no common property, mind cannot act upon matter, nor matter upon mind. Footnote: Biographia Literaria, Volume 1, Chapter 8. End footnote. What is this but the a priori fallacy of which we are speaking? The doctrine, like many others of Coleridge, is taken from Spinoza, in the first book of whose Ethica, De Deo, it stands as the 3rd proposition. Quote, "Que vis nihil commun inter se habent, eram una alterius causa esse non potest." End quote, and is there proved from 2 so-called axioms, equally gratuitous with itself. But Spinoza, ever systematically consistent, pursued the doctrine to its inevitable consequence, the materiality of God. The same conception of impossibility led the ingenious and subtle mind of Leibniz to his celebrated doctrine of a pre-established harmony. He, too, thought that mind could not act upon matter, nor matter upon mind, and that the two, therefore, must have been arranged by their maker like 2 clocks, which, though unconnected with one another, strike simultaneously and always point to the same hour. Malebranche's equally famous theory of occasional causes was another form of the same conception. Instead of supposing the clocks originally arranged to strike together, he held that when the one strikes, God interposes and makes the other strike in correspondence with it. Descartes, in like manner, whose works are a rich mine of almost every description of a priori fallacy, says that the efficient cause must at least have all the perfections of the effect, and for this singular reason. Quote, Si enim ponamus aliquid in idea reperiri quod non fuerit in ejus causa, hoc igitur habet a nihilo. End quote. Of which it is scarcely a parody to say that if there be pepper in the soup, there must be pepper in the cook who made it, since otherwise the pepper would be without a cause. A similar fallacy is committed by Cicero in his second book De Finibus, where, speaking in his own person against the Epicureans, he charges them with inconsistency in saying that the pleasures of the mind had their origin from those of the body, and yet that the former were more valuable, as if the effect could surpass the cause. Quote, Animi voluptas oritur propter voluptatem corporis, et major est animi voluptas quam corporis, ita fit ut gratulator, laetior sit quam is qui gratulator. End quote. Even that, surely, is not an impossibility. A person's good fortune has often given more pleasure to others than it gave to the person himself. Descartes, with no less readiness, applies the same principle the converse way, and infers the nature of the effects from the assumption that they must, in this or that property, or in all their properties, resemble their cause. To this class belong his speculations, and those of so many others after him, tending to infer the order of the universe, not from observation, but by a priori reasoning from supposed qualities of the Godhead. This sort of inference was probably never carried to a greater length than it was in one particular instance by Descartes, when, as a proof of one of his physical principles, that the quantity of motion in the universe is invariable, he had recourse to the immutability of the divine nature. Reasoning of a very similar character is, however, nearly as common now as it was in his time, and does duty largely as a means of fencing off disagreeable conclusions. Writers have not yet ceased to oppose the theory of divine benevolence to the evidence of physical facts, to the principle of population, for example, and people seem in general to think that they have used a very powerful argument when they have said that to suppose some proposition true would be a reflection on the goodness or wisdom of the deity. Put into the simplest possible terms, their argument is, quote, if it had depended on me, I would not have made the proposition true. Therefore, it is not true. End quote. Put into other words, it stands thus, quote, God is perfect, therefore, what I think, perfection must obtain in nature. End quote. But since in reality everyone feels that nature is very far from perfect, the doctrine is never applied consistently. It furnishes an argument which, like many others of a similar character, people like to appeal to when it makes for their own side. Nobody is convinced by it, but each appears to think that it puts religion on his side of the question, and that it is a useful weapon of offence for wounding an adversary. Although several other varieties of a priori fallacy might probably be added to those here specified, these are all against which it seems necessary to give any special caution. Our object is to open, without attempting or affecting to exhaust, the subject. Having illustrated, therefore, this first class of fallacies at sufficient length, I shall proceed to the second. End of section 75. Section 76 of A System of Logic by John Stuart Mill. This LibriVox recording is in the public domain. Book 5, Chapter 4, Fallacies of Observation. Part 1. From the fallacies which are properly prejudices or presumptions antecedent to and superseding proof, we pass to those which lie on the incorrect performance of the proving process, and as proof in its widest extent embraces one or more or all of three processes, observation, generalization, and deduction, we shall consider in their order the errors capable of being committed in these three operations, and first of the first mentioned. A fallacy of misobservation may be either negative or positive, either non-observation or mal-observation. It is non-observation when all the error consists in overlooking or neglecting facts or particulars which ought to have been observed. It is mal-observation when something is not simply unseen, but seen wrong, when the fact or phenomenon, instead of being recognized for what it is in reality, is mistaken for something else. Part 2. Non-observation may either take place by overlooking instances or by overlooking some of the circumstances of a given instance. If we were to conclude that a fortune-teller was a true prophet, from not adverting to the cases in which his predictions had been falsified by the event, this would be non-observation of instances. But if we overlooked or remained ignorant of the fact that in cases where the predictions had been fulfilled, he had been in collusion with someone who had given him the information on which they were grounded, this would be non-observation of circumstances. The former case, insofar as the act of induction from insufficient evidence is concerned, does not fall under this second class of fallacies, but under the third, fallacies of generalization. In every such case, however, there are two defects or errors instead of one. There is the error of treating the insufficient evidence as if it were sufficient, which is a fallacy of the third class. And there is the insufficiency itself, the not having better evidence, which, when such evidence, or in other words, when other instances were to be had, is non-observation. And the erroneous inference, so far as it is to be attributed to this cause, is a fallacy of the second class. It belongs not to our purpose to treat of non-observation as arising from casual inattention, from general slovenliness of mental habits, want of due practice in the use of the observing faculties, or insufficient interest in the subject. The question pertinent to logic is, granting the want of complete competency in the observer, on what point is that insufficiency on his part likely to lead him wrong? Or rather, what sorts of instances or of circumstances in any given instance are most likely to escape the notice of observers generally, of mankind at large? Part 3. First, then, it is evident that when the instances on one side of a question are more likely to be remembered and recorded than those on the other, especially if there be any strong motive to preserve the memory of the first but not of the latter, these last are likely to be overlooked and escape the observation of the mass of mankind. This is the recognized explanation of the credit given, in spite of reason and evidence, to many classes of impostors, to quack doctors and fortune-tellers in all ages, to the cunning man of modern times and the oracles of old. Few have considered the extent to which this fallacy operates in practice, even in the teeth of the most palpable negative evidence. A striking example of it is the faith which the uneducated portion of the agricultural classes, in this and other countries, continue to repose in the prophecies as to weather supplied by almanac makers, though every season affords to them numerous cases of completely erroneous prediction. But as every season also furnishes some cases in which the prediction is fulfilled, this is enough to keep up the credit of the prophet, with people who do not reflect on the number of instances requisite for what we have called, in our inductive terminology, the elimination of chance, since a certain number of casual coincidences not only may but will happen between any two unconnected events. Coleridge, in one of the essays in the Friend, has illustrated the matter we are now considering in discussing the origin of a proverb, quote, which differently worded is to be found in all the languages of Europe, end quote. That is, fortune favors fools. He ascribes it partly to the, quote, tendency to exaggerate all effects that seem disproportionate to their visible cause, and all circumstances that are in any way strongly contrasted with our notions of the persons under them, end quote. Omitting some explanations which would refer the error to malobservation or to the other species of non-observation, that of circumstances, I take up the quotation further on. Quote, unforeseen coincidences may have greatly helped a man, yet if they have done for him only what possibly from his own abilities he might have effected for himself, his good luck will excite less attention, and the instances be less remembered. That clever men should attain their object seems natural, and we neglect the circumstances that perhaps produced that success of themselves without the intervention of skill or foresight. But we dwell on the fact and remember it as something strange when the same happens to a weak or ignorant man. So too, though the latter should fail in his undertakings from concurrences that might have happened to the wisest man, yet his failure being no more than might have been expected and accounted for from his folly, it lays no hold on our attention, but fleets away among the other undistinguished waves in which the stream of ordinary life murmurs by us, and is forgotten. Had it been as true as it was notoriously false, that those all-embracing discoveries which have shed a dawn of science on the art of chemistry, and give no obscure promise of some one great constitutive law, in the light of which dwell dominion and the power of prophecy, if these discoveries, instead of having been, as they really were, preconcerted by meditation, and evolved out of his own intellect, had occurred by a set of lucky accidents to the illustrious father and founder of philosophic alchemy, if they had presented themselves to Professor Davy exclusively in consequence of his luck in possessing a particular galvanic battery, if this battery, as far as Davy was concerned, had itself been an accident, and not, as in point of fact it was, desired and obtained by him for the purpose of ensuring the testimony of experience to his principles, and in order to bind down material nature under the inquisition of reason, and force from her, as by torture, unequivocal answers to prepared and preconceived questions, yet still they would not have been talked of or described as instances of luck, but as the natural results of his admitted genius and known skill. But should an accident have disclosed similar discoveries to a mechanic at Birmingham or Sheffield, and if the man should grow rich in consequence, and partly by the envy of his neighbours, and partly with good reason, be considered by them as a man below par in the general powers of his understanding, then, oh, what a lucky fellow! Well, fortune does favour fools, that's for certain. It is always so. And forthwith the exclaimer relates half a dozen similar instances, thus accumulating the one sort of facts and never collecting the other. We do, as poets in their diction, and quacks of all denominations do in their reasoning, put a part for the whole. End quote. This passage very happily sets forth the manner in which, under the loose mode of induction which proceeds per enumerationem simplicem, not seeking for instances of such a kind as to be decisive of the question, but generalizing from any which occur, or rather which are remembered, opinions grow up with the apparent sanction of experience, which have no foundation in the laws of nature at all. Quote, itaque recte respondet ille, we may say with Bacon, qui cum suspensa tabula in templo monstraretur eorum qui vota solverant quod naufragiae periculo elapsi sint, atque interrogando premeritur, ane tum quidem deorum numen agnosceret, que civit denuo. At ubi sunt illae depictae qui post vota noncupata perierunt, idem ratio est feri omnis superstitionis, ut in astrologicis, insomniis, omnibus, nemesibus, et hujus modi, in cibus homines delectati, hujus modi vanitatibus, advertunt eventus, ubi implentur, ast ubi fallunt, licet multo frequentius, tamen negligunt et praeteriunt. Footnote. Novum Organum Aphorisms concerning the interpretation of nature and the kingdom of man. 46. End footnote. And he proceeds to say that, independently of the love of the marvellous or any other bias in the inclinations, there is a natural tendency in the intellect itself to this kind of fallacy, since the mind is more moved by affirmative instances, though negative ones are of most use in philosophy. Quote, Is tamen humano intellectui era est proprius et perpetuus, ut magis moviatur et excitetur affirmatavis quam negativis, cum reit et ordine aequium se utrique praebere debiat, quin contra in omni axiomate vero constituendo major vis est instantiae negative. But the greatest of all causes of non-observation is a preconceived opinion. This it is which, in all ages, has made the whole race of mankind and every separate section of it, for the most part unobservant of all facts, however abundant, even when passing under their own eyes, which are contradictory to any first appearance or any received tenet. It is worth while to recall occasionally to the oblivious memory of mankind some of the striking instances in which opinions that the simplest experiment would have shown to be erroneous continued to be entertained because nobody ever thought of trying that experiment. One of the most remarkable of these was exhibited in the Copernican controversy. The opponents of Copernicus argued that the earth did not move, because if it did, a stone let fall from the top of a high tower would not reach the ground at the foot of the tower, but at a little distance from it, in a contrary direction to the earth's course. In the same manner, said they, as if a ball is let drop from the masthead while the ship is in full sail, it does not fall exactly at the foot of the mast, but nearer to the stern of the vessel. The Copernicans would have silenced these objectors at once if they had tried dropping a ball from the masthead, since they would have found that it does fall exactly at the foot, as the theory requires. But no, they admitted the spurious fact and struggled vainly to make out a difference between the two cases. Quote, The ball was no part of the ship, and the motion forward was not natural either to the ship or to the ball. The stone, on the other hand, let fall from the top of the tower, was a part of the earth, and therefore the diurnal and annular revolutions which were natural to the earth were also natural to the stone. The stone would therefore retain the same motion with the tower and strike the ground precisely at the bottom of it. Footnote. Playfair's Dissertation, Section 4. Other examples, scarcely less striking, are recorded by Dr. Whewell, where imaginary laws of nature have continued to be received as real merely because no person had steadily looked at facts which almost everyone had the opportunity of observing. Footnote. Novum Organum Renovatum, page 61. End footnote. Quote, A vague and loose mode of looking at facts very easily observable left men for a long time under the belief that a body 10 times as heavy as another falls 10 times as fast, that objects immersed in water are always magnified, without regard to the form of the surface, that the magnet exerts an irresistible force, that crystal is always found associated with ice and the like. These and many others are examples how blind and careless man can be, even in observation of the plainest and commonest appearances, and they show us that the mere faculties of perception, although constantly exercised upon innumerable objects, may long fail in leading to any exact knowledge." End quote. If even on physical facts, and these of the most obvious character, the observing faculties of mankind can be to this degree the passive slaves of their preconceived impressions, we need not be surprised that this should be so lamentably true, as all experience attests it to be, on things more nearly connected with their stronger feelings, on moral, social, and religious subjects. The information which an ordinary traveller brings back from a foreign country, as the result of evidence of his senses, is almost always such as exactly confirms the opinions with which he set out. He has had eyes and ears for such things only as he expected to see. Men read the sacred books of their religion, and pass unobserved therein multitudes of things utterly irreconcilable with even their own notions of moral excellence. With the same authorities before them, different historians alike, innocent of intentional misrepresentation, see only what is favourable to Protestants or Catholics, Royalists or Republicans, Charles I or Cromwell, while others, having set out with the preconception that extremes must be in the wrong, are incapable of seeing truth and justice when these are wholly on one side. The influence of a preconceived theory is well exemplified in the superstitions of barbarians respecting the virtues of medicaments and charms. The Negroes, among whom coral, as of old among ourselves, is worn as an amulet, affirm, according to Dr. Paris, that its colour, quote, "is always affected by the state of health of the wearer, it becoming paler in disease." End quote. Footnote: Pharmacologia, page 21. End footnote. On a matter open to universal observation, a general proposition which has not the smallest vestige of truth is received as a result of experience, the preconceived opinion preventing, it would seem, any observation whatever on the subject. Part 4. For illustration of the first species of non-observation, that of instances, what has now been stated may suffice. But there may also be non-observation of some material circumstances, in instances which have not been altogether overlooked, nay, which may be the very instances on which the whole superstructure of a theory has been founded. As, in the cases hitherto examined, a general proposition was too rashly adopted, on the evidence of particulars, true indeed, but insufficient to support it, so, in the cases to which we now turn, the particulars themselves have been imperfectly observed, and the singular propositions on which the generalization is grounded, or some at least of those singular propositions, are false. Such, for instance, was one of the mistakes committed in the celebrated phlogistic theory, a doctrine which accounted for combustion by the extrication of a substance called phlogiston, supposed to be contained in all combustible matter. The hypothesis accorded tolerably well with superficial appearances. The ascent of flame naturally suggests the escape of a substance, and the visible residuum of ashes, in bulk and weight, generally falls extremely short of the combustible material. The error was non-observation of an important portion of the actual residue, namely, the gaseous products of combustion. When these were at last noticed and brought into account, it appeared to be a universal law that all substances gain instead of losing weight by undergoing combustion, and after the usual attempt to accommodate the old theory to the new fact by means of an arbitrary hypothesis, that phlogiston had the quality of positive levity instead of gravity, chemists were conducted to the true explanation, namely, that instead of a substance separated, there was, on the contrary, a substance absorbed. Many of the absurd practices which have been deemed to possess medicinal efficacy have been indebted for their reputation to non-observance of some accompanying circumstance, which was the real agent in the cures ascribed to them. Thus, of the sympathetic powder of Sir Kenelm Digby, quote, "Whenever any wound had been inflicted, this powder was applied to the weapon that had inflicted it, which was, moreover, covered with ointment and dressed 2 or 3 times a day. The wound itself, in the meantime, was directed to be brought together and carefully bound up with clean linen rags, but, above all, to be let alone for 7 days, at the end of which period the bandages were removed, when the wound was generally found perfectly united. The triumph of the cure was decreed to the mysterious agency of the sympathetic powder which had been so assiduously applied to the weapon, whereas it is hardly necessary to observe that the promptness of the cure depended on the total exclusion of air from the wound, and upon the sanitative operations of nature not having received any disturbance from the officious interference of art. The result, beyond all doubt, furnished the first hint which led surgeons to the improved practice of healing wounds by what is technically called the first intention." End quote. Footnote. Pharmacologia, pages 23 through 24. End footnote. Quote, "In all records," adds Dr. Paris, "of extraordinary cures performed by mysterious agents, there is a great desire to conceal the remedies and other curative means which were simultaneously administered with them. Thus, Oribasius commends in high term a necklace of peony root for the cure of epilepsy, but we learn that he always took care to accompany its use with copious evacuations, although he assigns to them no share of credit in the cure. In later times we have a good specimen of this species of deception presented to us in a work on scrofula by Mr. Morley, written, as we are informed, for the sole purpose of restoring the much injured character and use of the vervain, in which the author directs the root of this plant to be tied with a yard of white satin ribbon around the neck, where it is to remain until the patient is cured. But mark, during this interval he calls to his aid the most active medicines in the materia medica." End quote. Footnote. Pharmacologia, page 28. End footnote. In other cases, the cures really produced by rest, regimen, and amusement have been ascribed to the medicinal or occasionally to the supernatural means which were put in requisition. Quote, "The celebrated John Wesley, while he commemorates the triumph of sulphur and supplication over his bodily infirmity, forgets to appreciate the resuscitating influence of 4 months' repose from his apostolic labours. And such is the disposition of the human mind to place confidence in the operation of mysterious agents, that we find him more disposed to attribute his cure to a brown paper plaster of egg and brimstone, than to Dr. Fothergill's salutary prescription of country air, rest, ass's milk, and horse exercise." End quote. Footnote. Pharmacologia, page 62. End footnote. In the following example, the circumstance overlooked was of a somewhat different character. Quote, "When the yellow fever raged in America, the practitioners trusted exclusively to the copious use of mercury. At first this plan was deemed so universally efficacious that in the enthusiasm of the moment it was triumphantly proclaimed that death never took place after the mercury had evinced its effect upon the system. All this was very true, but it furnished no proof of the efficacy of that metal, since the disease in its aggravated form was so rapid in its career that it swept away its victims long before the system could be brought under mercurial influence, while in its milder shape it passed off equally well without any assistance from art. End quote. Footnote: Pharmacologia, pages 61 and 62. End footnote. In these examples, the circumstance overlooked was cognizable by the senses. In other cases, it is one the knowledge of which could only be arrived at by reasoning. But the fallacy may still be classed under the head to which, for want of a more appropriate name, we have given the appellation fallacies of non-observation. It is not the nature of the faculties which ought to have been employed, but the non-employment of them, which constitutes this natural order of fallacies. Wherever the error is negative, not positive, wherever it consists especially in overlooking, in being ignorant or unmindful of some fact which, if known and attended to, would have made a difference in the conclusion arrived at, the error is properly placed in the class which we are considering. In this class there is not, as in all other fallacies, there is a positive misestimate of evidence actually had. The conclusion would be just if the portion which is seen of the case were the whole of it, but there is another portion overlooked, which vitiates the result. For instance, there is a remarkable doctrine which has occasionally found a vent in the public speeches of unwise legislators, but which only in one instance that I am aware of has received the sanction of a philosophical writer, namely Monsieur Cousin, who, in his preface to the Gorgias of Plato, contending that punishment must have some other and higher justification than the prevention of crime, makes use of this argument, that if punishment were only for the sake of example, it would be indifferent whether we punish the innocent or the guilty, since the punishment, considered as an example, is equally efficacious in either case. Now, we must, in order to go along with this reasoning, suppose that the person who feels himself under temptation, observing somebody punished, concludes himself to be in danger of being punished likewise, and is terrified accordingly. But it is forgotten that if the person punished is supposed to be innocent, or even if there be any doubt of his guilt, the spectator will reflect that his own danger, whatever it may be, is not contingent on his guiltiness, but threatens him equally if he remains innocent. And how, therefore, is he deterred from guilt by the apprehension of such punishment? Monsieur Cousin supposes that people will be dissuaded from guilt by whatever renders the condition of the guilty more perilous, forgetting that the condition of the innocent, also one of the elements in the calculation, is, in the case supposed, made perilous in precisely an equal degree. This is a fallacy of overlooking or of non-observation within the intent of our classification. Fallacies of this description are the great stumbling block to correct thinking in political economy. The economical workings of society afford numerous cases in which the effects of a cause consist of two sets of phenomena, the one immediate, concentrated, obvious to all eyes, and passing in common apprehension for the whole effect. The other widely diffused or lying deeper under the surface, and which is exactly contrary to the former. Take, for instance, the common notion, so plausible at the first glance, of the encouragement given to industry by lavish expenditure. A, who spends his whole income and even his capital in expensive living, is supposed to give great employment to labor. B, who lives on a small portion and invests the remainder in the funds is thought to give little or no employment. For everybody sees the gains which are made by A's tradesmen, servants, and others, while his money is spending. B's savings, on the contrary, pass into the hands of the person whose stock he purchased, who with it pays a debt he owed to some banker, who lends it again to some merchant or manufacturer, and the capital being laid out in hiring spinners and weavers, or carriers and the crews of merchant vessels, not only gives immediate employment to at least as much industry as A employs during the whole of his career, but coming back with increase by the sale of the goods which have been manufactured or imported, forms a fund for the employment of the same, and perhaps a greater quantity of labour in perpetuity. But the observer does not see, and therefore does not consider, what becomes of B's money. He does see what is done with A's. He observes the amount of industry which A's profusion feeds. He observes not the far greater quantity which it prevents from being fed, and thence the prejudice, universal to the time of Adam Smith, that prodigality encourages industry, and parsimony is a discouragement to it. The common argument against free trade was a fallacy of the same nature. The purchaser of British silk encourages British industry. The purchaser of Lyons silk encourages only French. The former conduct is patriotic. The latter ought to be prevented by law. The circumstance is overlooked that the purchaser of any foreign commodity necessarily causes, directly or indirectly, the export of an equivalent value of some article of home production, beyond what would otherwise be exported, either to the same foreign country or to some other, which fact, though from the complication of the circumstances it cannot always be verified by specific observation, no observation can possibly be brought to contradict, while the evidence of reasoning on which it rests is irrefragable. The fallacy is, therefore, the same as in the preceding case, that of seeing a part only of the phenomena, and imagining that part to be the whole, and may be ranked among fallacies of non-observation. Part 5. To complete the examination of the second of our 5 classes, we have now to speak of malobservation, in which the error does not lie in the fact that something is unseen, but that something seen is seen wrong. Perception being infallible evidence of whatever is really perceived, the error now under consideration can be committed no otherwise than by mistaking for conception what is in fact inference. We have formerly shown how intimately the two are blended in almost everything which is called observation, and still more in every description. Footnote. See section 63 of this work, Book 4, Chapter 1, Part 1. End footnote. What is actually on any occasion perceived by our senses being so minute in amount, and generally so unimportant a portion of the state of facts which we wish to ascertain or to communicate, it would be absurd to say that either in our observations or in conveying their result to others, we ought not to mingle inference with fact. All that can be said is, that when we do so we ought to be aware of what we are doing, and to know what part of the assertion rests on consciousness, and is therefore indisputable, what part on inference, and is therefore questionable. One of the most celebrated examples of a universal error produced by mistaking an inference for the direct evidence of the senses was the resistance made, on the ground of common sense, to the Copernican system. People fancied they saw the sun rise and set, the stars revolve in circles around the pole. We now know that they saw no such thing. What they really saw was a set of appearances equally reconcilable with the theory they held and with a totally different one. It seems strange that such an instance as this of the testimony of the senses pleaded with the most entire conviction in favour of something which was a mere inference of the judgment, and, as it turned out, a false inference, should not have opened the eyes of the bigots of common sense and inspired them with a more modest distrust of the competency of mere ignorance to judge the conclusions of cultivated thought. In proportion to any person's deficiency of knowledge and mental cultivation is, generally, his inability to discriminate between his inferences and the perceptions on which they were grounded. Many a marvellous tale, many a scandalous anecdote owes its origin to this incapacity. The narrator relates not what he saw or heard, but the impression which he derived from what he saw or heard, and of which perhaps the greater part consisted of inference, though the whole is related not as inference, but as matter of fact. The difficulty of inducing witnesses to restrain within any moderate limits the intermixture of their inferences with the narrative of their perceptions is well known to experienced cross-examiners, and still more is this the case when ignorant persons attempt to describe any natural phenomenon. Quote, "The simplest narrative," says Dugald Stuart, "of the most illiterate observer involves more or less of hypothesis. Nay, in general, it will be found that, in proportion to his ignorance, the greater is the number of conjectural principles involved in his statements. A village apothecary, and if possible in a still greater degree an experienced nurse, is seldom able to describe the plainest case without employing a phraseology of which every word is a theory, whereas a simple and genuine specification of the phenomena which mark a particular disease, a specification unsophisticated by fancy or by preconceived opinions, may be regarded as unequivocal evidence of a mind trained by long and successful study to the most difficult of all arts, that of the faithful interpretation of nature." End quote. Footnote: Elements of the Philosophy of the Mind, Volume 2, Chapter 4, Section 5. End footnote. The universality of the confusion between perceptions and the inferences drawn from them, and the rarity of the power to discriminate the one from the other, ceases to surprise us when we consider that in the far greater number of instances the actual perceptions of our senses are of no importance or interest to us except as marks from which we infer something beyond them. It is not the colour and superficial extension perceived by the eye that are important to us, but the object of which those visible appearances testify the presence. And where the sensation itself is indifferent, as it generally is, we have no motive to attend particularly to it, but acquire a habit of passing it over without distinct consciousness, and going on at once to the inference. So that to know what the sensation actually was is a study in itself, to which painters, for example, have to train themselves by special and long-continued discipline and application. In things farther removed from the dominion of the outward senses, no one who has not great experience in psychological analysis is competent to break this intense association. And when such analytic habits do not exist in the requisite degree, it is hardly possible to mention any of the habitual judgments of mankind on subjects of a high degree of abstraction, from the being of a God and the immortality of the soul down to the multiplication table, which are not, or have not been, considered as a matter of direct intuition. So strong is the tendency to ascribe an intuitive character to judgments which are mere inferences, and often false ones. No one can doubt that many a deluded visionary has actually believed that he was directly inspired from heaven, and that the Almighty had conversed with him face to face, which yet was only, on his part, a conclusion drawn from appearances to his senses, or feelings in his internal consciousness, which afforded no warrant for any such belief. A caution, therefore, against this class of errors is not only needful but indispensable, though to determine whether on any of the great questions of metaphysics such errors are actually committed belongs not to this place, but, as I have so often said, to a different science. End of section 76.